Aaron Yao, I'm the designated federal officer for the Clean Air Scientific Advisory Committee. In my role as DFO, I'd like to formally open this public meeting. The CASAC is an independent expert federal advisory committee chartered under the authority of the Federal Advisory Committee Act, FACA. The CASAC is empowered under the Clean Air Act to provide independent advice to the EPA administrator on the scientific and technical bases for EPA's national ambient air quality standards. FACA and EPA policy require that CASAC meetings be announced to the public in the Federal Register and that substantive deliberations, interactions with EPA and the public be conducted in open sessions where DFO is present to ensure that the requirements of FACA are met. FACA also requires that public meetings provide an opportunity for public comment. There is a public comment period noted on the agenda. However, there were not any members of the public who requested to make oral comments. Written public comments have been received and were distributed to the panel and posted on the meeting webpage. Minutes will be prepared to summarize discussions and action items in accordance with the requirements of FACA. I will work with the chair to certify the minutes and have them posted on the CASAC website. The CASAC consists of special government employees appointed by EPA to their positions. As special government employees, the members are subject to all applicable ethics laws in implementing regulations. The SAB staff office has determined that advisors participating in this meeting have no financial conflicts of interest or appearance of a loss of impartiality under federal ethics regulations relating to the topic of this meeting. I'd now like to turn the meeting over to Mr. Tom Brennan, Director of the SAB staff office, and then over to Dr. Leanne Shepard, Chair of the CASAC.
Thank you, Aaron, and welcome everyone to this public meeting of the Clean Air Scientific Advisory Committee. I'd like to first thank all the CASAC members and the lead panel members for your efforts today in preparing for this meeting and what you'll do in the future. This has been a very busy time for the CASAC, and I want you to know how much I appreciate you taking time out of your personal and professional lives to conduct this public service on behalf of the EPA and for the American public. So thank you all very much. With a special thanks to Dr. Shepard for being our chair. It's a lot of work being chair of the CASAC, and Leanne, you're doing a really good job, and I appreciate you very much, so thank you. I'd also like to thank my colleagues at the EPA for developing the material that is under review today. As you can imagine, it took a tremendous amount of work and effort over many years to get to the point where we're ready to conduct this peer review. So congratulations to them on all that hard work, and thank you. I'd like to thank our contractor and Dinah for their meeting support, so thank you to them. Thank you to the members of the public who submitted written public comments. Public participation is critical to this activity and to all Federal Advisory Committee work, so we appreciate that very much. And thank you to my team at the SAB staff office. As you can imagine, it takes a lot of logistical work to pull off a meeting like this, and there's a lot that goes on behind the scenes, and I want them to know how much I appreciate their efforts. And finally, to our DFO, Aaron Yao, the DFO of the CASAC, it is a ton of work that Aaron does. Aaron, you're doing a great job. Thank you very much. And now I'd like to turn the meeting over to Dr. Shepard.
Thank you, Tom, and welcome everyone to this meeting of the lead panel for the purposes of reviewing the integrated science assessment for lead. We'll go around and do introductions, but before that I wanted to make a couple of comments about the agenda. First of all, the times on the agenda are approximate, and so if we finish a section, we'll move on to the next one. Another comment is that before each section, EPA plans to provide some introductory comments and overview, so we'll hear from them as well. That's not listed on the agenda. And for each section, I'll call on the discussants in the order that they're listed on the agenda, and then we'll open it up to general panel deliberations. And so now I'd like to invite people to introduce themselves, and I think I'll start with the people on Zoom, and then we'll go around the room as we are seated in alphabetical order. So let's see, Howard, do you want to introduce yourself?
I just swallowed my cereal, but yes, hello from the West Coast. I'm Howard Hu, a physician epidemiologist and professor at the University of Southern California.
Thank you. Bruce?
Bruce Lanphier, professor at Simon Fraser University, but currently just outside of Cambridge, England.
Thank you. George.
Good morning. George Allen, Chief Scientist at NESCOM in Boston. I'm a former chartered CASAC member during the previous lead review, and my expertise is in measurement methods, aerosol science, and exposure assessment.
Thank you. Jim.
Hi, Jim Boylan, Chief of the Air Protection Branch at the Georgia Environmental Protection Division. My background is in NAAQS implementation, emissions inventory, ambient monitoring, and regulatory modeling.
Thank you. Judy.
Good morning. My name is Judy Chow. I'm a research professor at Desert Research Institute, Parker University in Nevada. My research interest has been on ambient monitoring, network design, and chemical analysis, data analysis, and receptor modeling. Thank you.
Debbie, sorry.
Hi, I'm Deborah Corey Select. I'm Professor of Environmental Medicine at the University of Rochester Medical Center, and my area of expertise and research is neurotoxicology of metals, including in air pollution.
Thank you. Philip?
Good morning, I'm Philip Goodrum. I'm a toxicologist with GSI Environmental. I also teach at SUNY Environmental Science and Forestry in environmental risk assessment. And my expertise is in toxicology and uncertainty analysis applied to risk assessment.
Thank you. Perry?
Yes, I'm Perry Goddesfeld, excuse me, with Occupational Knowledge International. We're a nonprofit organization based in the U.S., but we work almost exclusively in developing countries around the world to build capacity around environmental and occupational health. Thank you.
Thank you. Davin?
Morning, my name is Davin Henze. I'm a professor of mechanical and environmental engineering at University of Colorado in Boulder. My area of expertise is atmospheric fate and transport.
Thank you. Chris?
Good morning, everyone. I'm Chris Johnson. I'm a professor in the Department of Civil and Environmental Engineering at Syracuse University. I am by training a soil chemist and study fate and transport of lead and other metals in soils. This is the third time I've been a part of this process, first as an author and then the last two times on this panel.
Thank you. And just in speaking about myself, I'm a professor of both biostatistics and environmental occupational health sciences at the University of Washington, and the primary areas of research are in modeling of environmental exposures and assessing their health effects. Susan.
Good morning, I'm Susan Korek. I'm a physician epidemiologist and faculty at Harvard Medical School and Harvard T.H. Chan School of Public Health. My primary area of research focus is understanding the relation of environmental factors on child development, and those factors include lead. And this is the second time I've been on one of the CASAC lead panels.
Thank you. Joel.
Good morning. I'm a toxicologist, retired from the Pacific Northwest National Laboratory as a laboratory fellow. In my misspent youth, I worked with lead compartmental models and also the cellular and molecular toxicity of lead in bone.
Thank you. Brisa.
Good morning. My name is Brisa Sanchez. I'm a professor of biostatistics at Drexel University. My research interests are statistical methods development related to the assessment of health effects of multiple correlated exposures, including biomarkers of exposure and also built environment.
Thank you. Brian?
Good morning. My name is Brian Schwartz. I'm a professor of environmental health and engineering, epidemiology, and medicine at the Johns Hopkins Bloomberg School of Public Health, and I have led several NIH-funded longitudinal studies of health effects of lead, mainly in adults.
Thank you. Bill?
Bill Stubblefield. I'm a professor of ecotoxicology at Oregon State University in the Department of Environmental and Molecular Toxicology. I believe I'm about like Chris. This is my third go-around on this one, I believe, and look forward to it. Thank you.
Thank you. Kathleen?
I'm Kathleen Vork, and I'm a staff toxicologist at the California Environmental Protection Agency Office of Environmental Health Hazard Assessment, Air Toxicology and Risk Assessment Section. And my area of expertise and study is in occupational lead exposure, blood lead modeling, and effects of particle size.
Thank you. Mark?
Good morning. I'm Mark Weisskopf, Professor of Environmental Health and Epidemiology at the Harvard Chan School of Public Health. My expertise is in neuroepidemiology, so I look at effects of the environment on the brain kind of across the life course. I also have a strong interest and line in causal inference and epi methods for environmental health. Yeah, I think that's probably good.
Great, thank you. So since we don't have any public comments, I think we're ready to start on the deliberations. So I think next is to invite EPA staff that are going to lead Appendix 1 discussion to come up. And are you going to have a presentation as well? I don't think Steve wants to be up there by himself, so.
Don't forget your name tents, too.
All right, good morning, everyone. And I just want to introduce myself. I'm Steve Dutton. I'm Director of the Health and Environmental Effects Assessment Division. And my division is responsible for producing the Integrated Science Assessment. I just want to echo Aaron and Tom's appreciation for your time. It's really great to see such a fantastic panel and to hear so many of you are coming back for more after having done this many times before. So we really look forward to the next couple of days with you to get your professional input on our document. And one thing we're doing that's a little bit new this time is we have prepared a very short, just 3-minute reminder of kind of where we stood, what we presented to you 2.5 months ago. So we'll just be spending like 3 minutes to give that quick overview at the beginning of each segment in the agenda this morning. So I'll ask my colleagues to introduce themselves as they speak for the first time, but I'm going to go ahead and hand it over to Steve McDowell.
Hi, everyone. So I'm Steve McDowell, and I was the lead on the Atmospheric Sciences chapter, Source to Concentration.
We can go ahead and advance the slide.
I do that. So to summarize, from 1990 to 2017, national lead emissions have decreased from about 5 kilotons per year to about 1 kiloton per year. And according to the latest 2017 National Emissions Inventory, piston engine aircraft emissions accounted for about 70% of total national emissions. Industrial sources accounted for about 20%, and about half of that was from metal industries, including battery recycling. Regionally and locally, resuspension and wildfires are also potentially important contributors, and we have reported several references on that. To summarize fate and transport, lead in fine particulate matter is transported long distances, while in coarse PM, it's more likely to deposit closer to the source, and we have several new examples of that. Once deposited, airborne lead can distribute into the soil, water, sediments, and even into road dust and house dust, and we have summarized some of that in the lead appendix. Lead in hotspots of urban and industrial soil can be resuspended in air long after its accumulation, and so we've tried to cover some legacy lead references. And finally, despite large increases in lead emissions, lead is still observed in measurable concentrations in environmental media, especially near current and historical sources.
Great. All right, I think we'll hand it back over to you, Leanne.
All right. So next up on the agenda is going around and asking our panelists to share their comments. And first up is Judy Chow.
Appendix 1 is well-written and document lead concentration, lead emission sources, transport of lead in multimedia, and that's are most relevant to environmental concentration of lead. I just have a few there's 5 charge questions. I guess we just do one by one because it's quite, and I will just do the first one on first charge question on section 1.2 in terms of source of emissions, that just a few points need to be clarified. That the most current emissions ambient concentration were Appendix 1. So this year this time EPA started a new document called the Overview of Lead and Air Quality in the United States. So this Overview lead document is intended to represent the most recent emissions ambient concentrations. Figure 1 of this document shows large reduction of lead emissions from the last 3 decades, 1990 to the 2020. However, different source categories, source sector categories were used between the lead overview document and those presented in 27 NEI, National Emission Inventory. The long road mobile and highway vehicle categories in the overview document entitled, they changed from figure 1 to figure 2 to mobile and aircraft. So that sectors, so this is different from the lead emission sector based on the 27 National Emission Inventory. Some consistency is needed to source sector categories, so allow some cross comparison. In addition, section 1.2.3 of Appendix 1 on fuel combustion notes that biomass combustion accounts for 16% of fuel combustion, that's about 7 tons per year. And this is about 60% less than the 18 tons per year for Wi-Fi emission estimated by the 2020 AEI. So it is not clear if the Wi-Fi, including Wi-Fi burned infrastructure such as buildings and vehicles burned, are they included or excluded from the biomass combustion, and also are they the same as the section, I think it's 1.2.4 on files. So they call it biomass combustion, then they call files, and I'm not sure what are this need to be clarified. Next section also noted that higher lead emissions from smoldering phase of the combustion, which is really important because as compared to the flaming phase of the combustion, so that this references should be provided because prolonged smoldering smoke exposure has been related to the adverse respiratory effects. Section 1.2.4 on files also summarizes quite a bit of studies that have found elevated lead concentration in air, ash, and soil. As PM lead concentration vary between days before, during, and after the fire. It will be this 2-page long summary will be probably better to include a table that document the fire events because we need to understand the location, duration, and the acreage burned. So we can understand lead concentrations during different period of time at different area, and to compare the ratio of lead emission before, during, and after fire to evaluate the environmental impacts of the fires. Yeah, that's here for section 1.2.
All right, thank you.
That's question one.
So you'd like to go through each sub-question separately? All right, so moving on to Jim, do you want to also talk just about the first one, or?
Yes, so section 1.2 covers all the major sources of contemporary and legacy lead sources and does a good job of discussing the relative importance of these sources. It would be helpful to add additional details on the uncertainties associated with each source and provide an overall summary of the relative uncertainties across sources. Also, it would be helpful to include figures 1, 2, and 3 and the associated text from EPA's separate document that Judy referenced, Overview of Lead Air Quality in the United States, 2002. And I actually have some, under the fifth comment, I have some additional comments about that, but I'll just leave it at that. Thank you.
Thank you. So next up is Perry Gottsfeld.
Thank you. I'll try to keep my comments to the 1A question, but I think the appendix is obviously very comprehensive, but it could use some additional contextualization of these various exposures. I think it would be useful to add up front some clear statement that all lead exposures are bioaccumulative and that the relative contribution from the various sources discussed is situation specific. It does have that in there, but it's kind of buried away. I think it's also important that we notice up front that, the situations that we're talking about depends on age, geography, nutritional status, seasonal fluctuations, and so on, and that the relative contributions of environmental sources are changing, even if we just look at airborne sources. And as these sources change over time, that some become more and others become less significant. So as we remove lead from gasoline, for example, the other airborne emissions become more significant. And airborne lead deposited in soil, of course, can be resuspended, and I know that's in there, but it might not be upfront in terms of an overview of this issue. In terms of specific sources that I feel should have gotten better highlighted is you do discuss industrial sources, but that's not broken down. And I think it would be useful to talk about, in particular, something about the lead battery manufacturing and recycling industries, as these are the largest consumers of lead in the United States and globally. There's nothing specific about airborne emissions from ammunition, and this has become something that's been highlighted in recent years from studies looking at both indoor and outdoor uses of ammunition, both on the recreational side and on the occupational exposure side. It does seem like this is a significant and becoming an increasingly significant airborne source of lead, as this is a growing use of lead in the United States. I'm just trying to arrange this so that I'm sticking to this first point, but I think that covers mostly of what I had for that specific question. Thank you.
Thank you. Davin.
Thanks. Yeah, I also noted, like other panel members, that it could be useful to start with some kind of overview figures showing maybe the known budgets or ranges of budgets for the different sources. And I can appreciate the approach taken right now for all of the sort of figures related to emissions and concentrations trends to be in the separate document, but ultimately it'd be nice if that was integrated to some extent within the ISA, because it would just prevents a lot of flipping back and forth between two things. In terms of specific sources, there's a lot of discussion of lead from airports, takeoff, landing, taxiing, but there isn't a mention or comparison of these to the in-transit emissions. And also, it'd be interesting to see a connection between the discussion of lead sources from fires I think Judy mentioned this as well, with the connection of lead in infrastructures. So in paint and buildings, and thinking about fires. We had a fire very recently in Colorado. It was in the winter, and it was mostly a residential fire, and a lot of houses burned. So rather than just thinking of fires as biomass burning, thinking of urban fires and that as the source. I'll come back to this kind of last comment later, but I didn't see any mention of how emissions changed in 2020 in response to COVID lockdowns, and perhaps not as strongly here in the U.S. With sort of only aviations, but certainly globally that was something that's been noted in other studies on emissions, and I have more comments on that related to other sections.
Thank you. I think we should probably circle back to Judy then, right? For the next charge question.
Anybody else have comments on?
I'm thinking, given there's 5 of these, if we're going to go through each one, that we probably should keep going, and then, of course, people should raise their hand if they, or their cards if you want to speak up about anything.
Okay, thank you. Does charge question 1B regarding the lead feed and transport in soil, that document the lead transport in and within soil columns that reveal lead enrichment in different soil horizons, that it'd be helpful to add a footnote to explain the geological horizons that define soil type, soil property, and depths, especially the depths from the surface soils. The summary section noted that once deposit soil, lead is deposited on soil, is strongly retained in the organic surface horizon. It's not clear what does that mean. Is the topsoil, or is the that soil that can be more resuspendable, which will more impact the environment. And also this section look at the feed and transport in water and sediment. They summarize, the section summarize a lot of lead levels in surface water, lake and sediments at urban and non-urban environment. But they use different concentration unit in terms of milligram per kilogram, microgram per liter, and something called the PM. This is the first time I saw that one. And I think it's picomole, maybe 1 trillion of a mole. They also give us this information on the terms of different levels of PM or picomoles, and that in ice and snow, in terms of 100 to 900 to 1,000 level. But it would be probably nice to provide some of the guideline to evaluate the extent of lead contamination, so we know how severe is all these different levels are. So such as to give a more perspective on the levels of severity, it might be helpful to discuss the EPA's guideline in terms of aquatic water system for 15 microgram per liter, and for the toxicity level of 1,000 microgram per liter, so we have some idea in terms of the severity of the contamination or the environmental impact. Thanks.
Thank you. Jim?
Yes, I didn't have anything additional to add to this question.
Okay. Perry?
Yes, thank you. I think a couple of things that I think would be useful in this particular context would be to supply, if possible, some kind of an aggregate estimate or range for soil resuspension, how that exposure compares to the others that are being discussed in this section. I know this is kind of a big ask, but I think it would be useful to try to put that into some kind of a context in that regard. The other issue that I think is important is that the document does mention soil transport, but it doesn't say anything specific about tetraethyl lead and leaks or spills from aviation fuel. And in another location in the document, there is a figure for the quantity of aviation gas discarded on the ground. It's quite an alarming figure. I'm not even sure if it makes sense, but it's something like, 10% of all usage or some crazy number. So I think it's very useful to talk about the transport of tetraethyl lead in this context.
Thank you. So Davin, do you have anything to add?
Yeah, just briefly, in the section talking about transport and lifetimes, I just noted that in the summaries, it was all very qualitative. There's a phrase that's just repeated many times, that lead is transported long distances, but it's never quantified what is meant by that. And so in the context of the different sources and the different size of particles, it'd be nice to quantify what distances are being referred to and what atmospheric residence lifetimes are being referred to. And then another point of clarification in the discussion of neighborhood scale variability of ambient lead. At one point there's a statement that's saying it's not directly related to soil concentrations, although in other parts of the summaries it's mentioned that the neighborhood scale variability and ambient concentrations are thought to be an artifact of the historical lead source and resuspension of that source in soils. So it again, just sort of nice to get a little bit of consistency in the text on that point. Thank you.
All right, thank you. Let's see, we're back to Judy, and this is, I guess you want to talk about 1C, which is the measurement methods in section 1.4.
Yeah, thank you. So the section 1.4 on monitoring of lead in airborne air, that they did mention that conditions under which a lead PM10 FRM could be used as an alternative to the original lead TSP FRM, the federal references method. However, not much effort has been made to collocate comparison between the TSP and PM10 lead. For high volume TSP sampling, we all know that that they represent a very broad range of the particle from the upper end particle from the 30 to 60 micron. So, which is especially they have low sampling efficiency at the high end of the lead particle size distribution. So the EPA cited one references from Vanderpool et al. That they find out the low volume TSP sampling system vary by anywhere between 30 to 110% at different wind speed. So the further emphasize the importance of size-selective PM inlets is needed to represent, to get a representative PM mass and lead concentration. That's it.
Thank you. Jim?
Yeah, so I think it would be helpful to include figures 4 and 5 and the associated text from EPA's separate document overview of lead air quality in the United States. Also, it'd be good to include a sentence from that same document, the sentence that talks about source-oriented sites located to measure the maximum lead concentration, basically the emissions that are required for a monitor for an industrial site, it's a half a ton of lead or more, and it's 1 ton or more for airports. And then finally, it would be good to state the criteria that must be met for a lead monitor to be shut down, which I believe is less than 50% of the NACs.
All right, thank you. Perry, do you have anything to add? And Davin?
Yeah, just a small comment. There was a statement that there was no studies of the diurnal variability of lead, and I thought that maybe this could be looked at in a little bit more detail in terms of lead contributing to factors and factor analysis of particulate matter concentrations, and there's plenty of studies of the diurnal variability of PM composition in that sense, and factors that are indicative of lead or have a very clear lead signal. And so maybe if it wasn't explicitly a study of lead-only measurement that had diurnal variability, it could be part of some other works.
All right, thank you. I think we're on to 1D, which is, right? It's trends
Yes.
and it's section 1.5.
Section 1.5, recent concentration and trends and size distribution. That table 1-1 assembles studies with seasonal variation in ambient light concentration. Those 9 studies that focus, they find very low levels of lead concentration between the 0.2 to 42 nanogram per cubic meter, far below the next standard of 0.15 microgram cubic meter for a 3-month average. So some illustration on diurnal, seasonal, or annual trend of lead concentration will be informative, will be nice to be included. The overview document for none of this document, all the ISA Appendix 1 did not address the non-attainment areas as of lead non-attainment areas. As of March of 2023, there are 13 areas in 6 states and Puerto Rico are designated as non-attainment for lead. And I look at this a year ago, this is a 30% increase of non-attainment in terms of the area, in terms of lead. So the information given in the document does not correspond to the 5 states with design value exceeding next, showing in figure 6 of the lead overview document. So we need to have some temporal spatial distribution of lead concentration in areas with lead design value exceeding the current standard, so that to have a better to examine their temporal changes and to understand the community exposure. Also, the overview document, lead document, this EPA 2022, shows that 28 out of the 37 sites, that's about 75% of the site, report a decreasing trend in lead design value for the last decade. That ambient concentration show large reduction in lead concentration on the national scale. However, it does not represent the ambient concentration at the individual site. So I download the data from the AQS, and in my homework assignment, I show that that Ohio and Indiana sites, they have frequent spikes in recent years as source-dominant environment in Indiana. In both, they can be up to 24, up to 3 microgram cubic meter, about 20 times higher than the recent standard. So the AQS data show that there's some air pollution agency probably moved the site recently, and for the source dominant site that affect human exposure, that we'd like to have a better understand of the situation. For the Ohio site, I show in the figure that they have really high concentration in 2017 and 2018. And then it's come down just very low during the COVID period, like Devin mentioned, the COVID period influence. And then it spikes again after 2021. So those high concentration cannot be excluded as they are not in the non-attainment area. For some reason, I think because of 2020 low concentration, they're not designated as non-attainment, but this Republic still concentration is very high. So I feel that some neighborhood monitoring at this community is warranted to ensure safe exposure level. Thank you.
Thank you. Anything to add, Jim?
Yeah, so in this section, it'd be helpful to include tables 1 and 2 and figures 6, 7, 8, and 9, and the associated text from EPA's separate document, Overview of Lead Air Quality in the United States. I also had some comments on the non-attainment areas that I had put under the 5th question, but since Judy talked about it, I'll talk about it here. So the appendix is missing a discussion on areas that are currently in non-attainment for the current lead NACs. EPA should provide a list of current non-attainment areas and a map with their locations. Also, EPA should explain why the list of current non-attainment areas looks very different than the map with 2019 to 2021 lead design values over 0.15 micrograms per cubic meter, as shown in Figure 6 from the overview of lead air quality in the United States. That's it. Thank you.
Thank you. Perry, did you want to add anything?
Yes, many studies rely on toxic release inventory data to assess exposures at the local level. And I'm curious as to why that's not discussed in this section at all. I know that the NEI is a very different database than the toxic release inventory TRI database. And it would be useful, I think, to look at that given the limitations of ambient air monitoring and the current gaps in ambient air monitoring data. Thank you.
Thanks. Anything else you want to add, Dom?
My comments have been stated already.
Okay. So there's one more charge question, this section, just a broad one. And Judy, do you want to cover that one as well?
Charge question 1E is regarding pretty much the future researches. Now, so to better understand the extent to which various sources contribute to environmental lead concentration at or near the industrial sites, lead source attribution studies or modeling warrant additional research. Lead isotope is not just kind of mentioned in the Appendix 1. That has been found useful to distinguish different lead sources. In addition, section 1.5.4 on lead size distribution is kind of misleading as there are no particle size distribution data. I can't find any either. And, but they call the size distribution. If you only have PM10 TSP, it cannot sustain as a size distribution. So we did a report in 2017, it's a National Academy. We recommend that characterize particle size distribution, ambient air, and emission sources to better understand the particle mobility and transport at locations upwind of the downwind of emission sources to evaluate source contributions. Thank you.
Thank you. Anything else, Jim?
Yes, so this is so EPA pointed out, this is the first time they kind of created this standalone document, overview of lead air quality in the United States. And I really like the way that this document's set up, this standalone document. The document is outside the ISA and the policy assessment and can be updated as new data becomes available, which is really good concept. It allows ORD and OEKPS to work off the same data, figures, and tables. However, I think it would be helpful to include the current version of the figures and tables from this document in the ISA and the policy assessment. This will make it easy for the reviewer to see this important information, and it will document the data that was available at the time the ISA and policy assessment are released to the public. A sentence could be added to the ISA and policy assessment, letting the reader know that newer data and updated figures and tables may be available in the standalone document. Thank you.
Thank you. Anything else you want to add, Perry?
Yes, I think there's two things that I'd like to see discussed in this appendix. One is that there are a number of waste incinerators that are significant lead emitters, and I didn't see any mention of that. Some of them are emitting hundreds of pounds of lead. And the other one that's not well captured by ambient air monitoring is construction activities, particularly things like removing lead paint from bridges and steel structures, removing road paint, chromate lead paint, and of course, just general demolition. And these things are not well counted in ongoing ambient air monitoring over a 3-month period, et cetera. And that's something that gets lost, I believe, in this discussion, and it should be counted in the overall numbers. Thank you.
Thanks. And anything else, Donovan?
Sure, thanks. Just to reiterate a point I touched on earlier, that I was surprised to see no mention of the changes in emissions and concentrations in response to COVID. You know, a quick search in the literature, I do see other papers on this. One in North China Plains showing a 60% decline in ambient lead concentrations in the months of lockdown. And so, you know, if we have 70% of our anthropogenic emissions coming from aircraft and we're looking at trends on the scale of a few month averages, it seems like that's something that people may have already been reporting in studies, or if not, it's a future area of research. And it was just surprising to me, given how many papers there were on changes in atmospheric concentrations of NOx, of methane, of CO2, of even ammonia. Kind of everything got looked at within that particular lens. And I think this is an important way for us to understand the uncertainties in our anthropogenic emissions. There's mention here of a study in the ISA that was from Randall Martin's group looking at anthropogenic emissions, and they were doing modeling and had to increase their estimate of the anthropogenic emissions by a factor of 5, right, in order for their models to match the ambient data. So that's a huge uncertainty, a factor of 5 uncertainty that really isn't touched on in the section on emissions, and something that could be looked at via comparisons to ambient concentrations through these sorts of COVID-type experiments. And in that study, they do suggest that it's perhaps a lack of waste incineration in the inventories that is a missing source, but elsewhere in the ISA, they do mention waste incineration is not likely being a large source. So there's an open area for research there. Thank you.
All right, and with that, I think we'll open it up for anybody else who wants to comment on this appendix, or if there are any clarifying questions that EPA wants to ask. George.
I had a few questions and comments on a few different sections. I guess actually the first one might be for EPA staff. I'm trying to make sure I understand what counts and what doesn't count in terms of lead exposures. One example is, for example, lead paint from a house that finds its way into the soil. I think, if I have this right, if it's re-entrained into the air, it counts, but if soil is tracked into the house and ingested, it doesn't. Is that correct? It's a tough question, I'm sorry.
When you say counts, can you explain
Well,
that?
in terms of, you know, the definition here is that there has to be an air pathway to be considered in, you know, as a factor in this review. And in one case, in my example, there is, if it's re-entrained, and in the other case, there isn't. So I'm just wondering how literal that air pathway, and we're not counting the paint chips that might fall from the house. They are in the air for a short time. We're not counting that. But I just want to make sure, you know, the lead paint it's a big source, and I'm not sure if all the exposure from lead paint counts or just some aspects of it.
Yeah, so there's a couple of issues here in the atmospheric appendix. We're trying to, we're sort of counting the, like you said, what the contemporary sources are as well as what gets resuspended. And we're trying to do what we can to explain the non-air and legacy sources that contribute to potential resuspension. In the exposure appendix, then there is more consideration of how non-air sources compare to air sources to understand total exposure. Does that help?
I think so. Yeah, thanks. Let's see, so for section 1C, my favorite topic is, of course, the high vol. I couldn't let this go unmentioned. We had a lot of discussion on this last time, and that triggered a lot of really good work by Jonathan Krug and Bob Vanderpool and colleagues over the time period since the last review. So at least now we know what the high vol does. But on page 1-54, it does mention there is still a need to assess the feasibility of a revised TSP sampling method for efficient collection of particles larger than 10 micron. I bring that up because state agencies really hate the high vol. It's something they wish would go away. It's something that was invented during World War II, and if it were proposed as an FRM now, it would be laughed out of the ballpark. I don't know if there's a practical alternative. Sampling particles larger than 15 microns is really, really hard in ambient air, and we may just be stuck with it. But if there is a need to assess it, I'm wondering if there was any further consideration of possible alternatives or better approaches since the last review. Or is that just a thought that's out there, but nothing has happened yet?
So there are two new papers since the last review, but I think you probably heard about them during the last review, and now they're published. One is to look at to do a more comprehensive review of the FRM itself, and we've cited that in the current appendix. And then there is a second companion paper that looks at the alternative low-volume samplers that are sort of nominally TSP samplers, where those were also thoroughly reviewed through wind tunnel experiments. And so those two studies have been, are discussed in the appendix. Besides those, we didn't find any.
Well, the question is, to assess the feasibility of a revised TSP sampler, is that still alive or is that just sleeping?
Alive, meaning?
In active consideration, was EPA considering on going? I'm very familiar with the Vanderpool-Krug work, and it's really good. It's impressive. But, is the idea of maybe an alternative to the high vol FRM still alive, or is it just, that's what we're stuck with going forward?
I don't know of any research that's continuing on that in EPA, maybe.
Okay. I mean, this would be in the context of R&D for a new version of a big particle sampler for lead.
Yeah.
And it sounds like that's not happening. We have the performance characterizations, which, like I said, are wonderful. Kudos to ORD for doing that. But then the question is, now what? And I guess we're stuck with it. All right. One last one. No, actually, well, let's see. 1E, I agree with Jim's comment. The standalone overview of the lead air quality is great, but it would be useful to pull in, a little bit of it into the ISA. That was notably missing as you go through it, compared to all the other ambient data summaries that you find in other ISAs. But I think it's a good idea. The approach of the standalone to keep it updated is good. And then finally, there's one I'm not sure where it fits or even if it fits, but I wanted to pass this by Leanne and EPA and others. The elephant in the room for lead sources is avgas, and there was a lot of discussion on alternatives and progress towards moving past it in the previous review. And I know there has been a lot of progress made, but we're nowhere near to actually the changeover. And I'm wondering if well, two questions. One is, I didn't see any discussion of the current status of that process of getting the lead out of avgas. I think, to me, that would be helpful, and where is it and why is it stalled? And then, is there any role in this panel in encouraging EPA and other agencies perhaps in expediting the removal of lead from avgas? Because, it's 70% of the inventory. It really, it's a big problem. And I want to make sure we we do talk about it. So I think that's it for me. Thanks.
Thank you. Bruce has had his hand up for a while, and Judy also has her card up. Should we go to Bruce next?
All right. Thank you, Leanne. So a couple comments with some embedded questions. As I've listened, there's some concerns about whether we're picking up some of the exposure that's going on, what's happened during COVID. There was some discussion in the ISA about changes in particle size. And all of that makes me concerned because if I understand correct, based on what I looked at and found in January of this year, there's only about 100 air monitors for lead spread across the country. So I guess that's my embedded question. If that's true, it raises lots of concerns because, for example, one of the questions was, well, what happens during COVID? Well, in Santa Clara County around the Reed Hillview Airport, there was about a 50% reduction in traffic, aircraft traffic, and a 50% reduction in children's blood levels. Well, that's quite important. What were the background air lead concentrations? Well, we don't know because there aren't air monitors out there, even near some of the places that we might be concerned the air lead concentrations might be high. What's high? This is my next comment. Well, we don't really know. Blood lead levels today are still 10 to 100 times higher than our pre-industrial ancestors. And yet we seem to be taking these air monitors for lead and putting them out of commission if, I forget what Judy said, maybe they're below 50% below the existing NAC standard, but how do we know that's protective or low? We don't. In 2006, 2008, when I was last on the lead NACs committee, we suggested that there be an increase in the air monitors for lead. There was at least a temporary increase from 100 to 200 monitors, but then a few years or months later, I can't quite remember, it went back down to 100. So this is something that's really important to get our heads around so that the next time in 5 years, when people are back asking some of these questions, we actually have some data. And just to put that into context, over 1,000 of their 3,000 counties are monitoring for PM 2.5. They have at least one air monitor. And in many places, in many cities, that's many, many more. So we're really struggling with having good data to make decisions about particle size changes, about health effects, about exposures that are out there.
Thank you, Bruce, for that. Judy, did you want to follow up on something?
Yeah, I agree with Bruce that it's kind of disappointing to see some of the lead spikes, really high concentrations, but the number of sampling sites have been reduced over time. In addition, I'd like to echo on what George mentioned, that are we stuck with TSP? We all know that we don't know what we measure for TSP. Yes, it's super coarse, but the peak roof inlet, and it's very wind direction sensitive so it doesn't matter the measurement or modeling does not represent what they measure. So that for those high concentration sites, is it possible at least co-locate PM10 with the TSP so we have some sense of the lead levels at different sizes so that we can make some advancements. Yeah, Bob's study is really good, but doesn't look like low volume TSP works either, so that, but we still need to have more research in terms of co-located comparison to see if we can really measure a better super cross particle and in this case.
Thank you, Judy. Anybody else have questions or comments on this appendix? Judy, do you think you have what you need to draft the consensus comments?
Yeah, I will put it together. Yeah.
Okay. Steve?
Yeah, there were a couple of comments, but one on including more information about amount of resuspension compared to other sources, and another comment on how much COVID had affected the lead concentrations. And I wondered if the commenters could give us information on specific studies, or if they know of any research that's going on about that.
I did include a reference to one study that I found in my comments, but I didn't look super extensively. I think in terms of the reported lead concentrations, this particular study, again, it was a study looking at PM composition, and so it does include lead. So I didn't find anything with lead and COVID in the title, but I think looking more closely at the papers on PM composition changes during lockdown period would find more.
In terms of resuspension, I could say I haven't seen anything that gives broad global or national numbers or anything like that. But certainly there's been some research around the contribution of resuspension to children's blood lead levels. I think it's the Laidlaw study maybe in Flint that looked at that in seasonal variations. You know, certainly there have been some other attempts at looking at that link, but that's not exactly what you're asking for in terms of gross numbers.
Is that it, or anything else from EPA?
Yeah, that's helpful, thank you.
Okay. So I would like to get input from the panel. We are in, according to the agenda, we have one more appendix before lunch. Should we start on Appendix 2 and then take a break, or would you like to take a break now? Anybody have a preference? Thinking more like 10:30, we'll take a break. Maybe we'll get started on Appendix 2, and then we'll go ahead. And so Appendix 2 is about exposure, toxicokinetics, and biomarkers. And it describes the multimedia nature of lead exposure, toxicokinetics of lead in humans, biomarkers of lead exposure and body burden, as well as the models of the relationship between lead biomarkers and environmental lead measurements. Oh, and we need a changing of the guard for EPA. I saw people moving, so I realized I skipped that. So give you all a second, and you are going to actually give us a quick overview. So I'll give people a minute to get up and join Steve at the front table.
Yeah, I guess, hi everyone. My name is Peter Byerly. I'm a staff scientist at the EPA and lead on the exposure appendix. If we could just go to the next slide. Yeah, so I'm just going to give a general overview of the appendix. Just divided it up on this slide between exposure, toxicokinetics, and biomarkers. So similar to the 2013 lead ISA, exposures to lead occur through multiple pathways, including air, soil, dust, water, diet, paint, et cetera. And then we talk about in the appendix the difference between an air-related pathway, meaning that exposure occurred, or that before exposure occurred, lead passed through the air compartment, versus non-air lead pathways, such as leaching from lead pipes, et cetera. There's we also have a section on exposure disparities based on individual factors and proximity to lead sources, and there's a small section on co-exposures as well. In terms of toxicokinetics, since 2013, really the core principles that we have in our ISA haven't changed, but we do provide updated data. As you probably all know, absorption into the blood can depend on a number of factors, including the lead form, solubility, and nutritional status. And once lead is absorbed, it's distributed into the body to slow compartments and fast compartments, with the majority found in bones, about 90% in adults. and 90% of the body burden found in adults. And due to the long half-life of lead, we know that contributions from bone lead can contribute to elevated blood lead levels long after exposure has ceased. We also contain data in the appendix on blood lead levels over time using NHANES data, where since the 1970s, we've seen a drop in blood lead levels in the US over time. And also we have a section on air to blood lead slopes, where even we have a graph in there that shows that an increasing slope with lower air lead concentrations, but due to the varied nature of all of the study designs and the different conditions between older studies and newer studies, comparing those makes them quite difficult. And lastly, I'll just say that we really appreciate all of your comments thus far and all of your expertise, so thank you.
Thank you. So now we'll turn it over to the panelists, and Phil, you're up first. Do you want to do it by charge or a sub-question, or do you want to just do the whole?
Leanne, let's do it by charge question.
Yeah.
There's only 3 charge
Yeah.
questions this time, so, and 4 panelists, so, yeah.
Okay.
Okay. Well, the first, so there's 3 questions. This appendix 2 is about 120 pages, and seems like a lot of pages, but it's a huge topic area: exposure, toxicokinetics, and the connection between that. The first question really asks the committee to comment on the emphasis placed on different topics and the organization of the write-up, and then invites us to weigh in specifically on any recommendations we might have on how to better integrate the topics, exposure and toxicokinetics. So, and Peter, you just did a nice job kind of laying out what that connection is. My overall takeaway, and maybe I'll ask our projector folks to show figure 2-1 that's in appendix 2 while I'm chatting, but my overall opinion, it was really well written. It provided the kind of methods and findings, and then the what does it mean part of it for each of those topics, I thought very well. So most of my comments are going to be more nitpicks. There are a few places where I think some corrections could be made, and then I offer a few suggestions for at least thinking about changing some of the figures, adding a few tables and that sort of thing. The first figure actually ties in well with Alan's comment that I also focused in on. So the very beginning of the appendix shows one of these Venn diagrams that puts air kind of overlapped with other media. And I love Venn diagrams, but I also, once you look at them, it raises more questions. And from a risk assessment perspective, you might at least think about one of the more traditional ways to show the connections, particularly in this more complicated question of what constitutes what's in the air, how did it get there, is the box and arrow diagram. So from source to media to pathways to receptor, that sort of classic conceptual site model gives you the opportunity to show the cross connections. So you might give that a try. I don't think we're going to get to see figure 2-1 up here. I had a few specific, there we go, great. I had a few specific questions. It wasn't immediately obvious to me what newly emitted lead and historically emitted lead are, other than I think it's referring to the air compartment specifically, so what is emitted into air directly versus what's maybe resuspended. Of course, in the non-air lead releases, you have the same, potentially newly emitted and historically emitted. So that language, while helpful, is a little bit confusing in the diagram and maybe is better suited to the text. Likewise, there's many, of course, other potential sources of lead contributions, for example, to the indoor air environment that aren't really emphasized here. So the bottom polygons there, the ovals, show occupational, and then some examples of the consumer products, and of course drinking water pipes as important considerations, and there's many, many more. So it's a hard diagram to come up with. Alan's question was a good one. One additional comment that I have is that it might be helpful to do some more cross-referencing between sections. I was focusing on Appendix 2, but of course Appendix 1 might do a cross-reference to this diagram. I do think this diagram is a helpful one across multiple appendices. So it's difficult when you have multiple authors working on different pieces. It's that last refinement step of kind of doing the pointers to where there's maybe a more detailed discussion or a helpful diagram and that sort of thing. So the document would benefit from that fine-tuning at the end to do some more cross-references. A couple of other examples in my written comments on where some cross-references might be helpful. So we're used to thinking about the potential for particle enrichment when we're measuring soil and looking at different size fractions, and we've originally we were looking at 250 microns, and that's since come down to 150 or less. So in the study designs, when there is an effort to look at potential particle enrichment as a function of size fraction, that's a helpful way to understand what that concentration term actually represents from that study. Of course, throughout the ISA, there's lots of references to soil studies, soil and dust measurements. And this is a big ask, kind of what you said, Perry, as well. But in certain tables, particularly the more comprehensive tables that are trying to list the most relevant literature, it might be helpful to at least think about mentioning whether the concentrations that are being used from those studies or the interpretation of relationships from those studies took into account the sieve fraction. So that's one thought. And I give a couple of examples there, Table 2.3, Table 2.13, and then Section 2.53. I'll kind of touch on this theme. The other one that caught my eye was there's a few places where some kind of overarching statements are made about key exposure pathways and hand-to-mouth activity being an important activity pattern, particularly for young children. That's a mechanism for ingestion, but ingestion, of course, it ties in well to the inhalation pathway. And that's discussed very well, I thought, in Section 2.2.1.1, and forward references to that later section could be very helpful. So I found it a little bit kind of lacking in earlier sections, page 211 particularly, where that wasn't done. As far as recommendations for clarity and completeness, there was, these are just nitpicks, but there was a really helpful discussion of different studies, different study findings with respect to personal air monitoring versus ambient air monitoring. And what struck me was that there's conflicting findings from these. And I think that's a helpful overarching comment that you could probably start with. It wasn't until I got through the entire discussion that that point became obvious. And that got me thinking that this appendix in particular, where there's a lot of literature to synthesize, and you're making some good points throughout the write-up, it might be helpful to have these kind of call-out boxes, these text boxes that, these are the key points, these are the key takeaways. Sometimes that helps to, at least for the reader, drive home what the key points are, because there's a lot of dense discussion in places. Particle size distribution is a recurring theme, and that got me thinking that you might benefit from creating a diagram that kind of gives a range of particle sizes, and that would then give you an opportunity to talk about, different aspects of the particle size distribution being important for different exposure pathways, or certain relationships that are particularly helpful in epidemiological literature might focus on certain size ranges. Occupational exposures might have a different theme. So that kind of conceptual diagram of particle sizes might help you as far as pointers throughout the chapter. One thing caught my eye, there's some, in the exposure summaries, there's a discussion of soil ingestion rates and a reference to the updated exposure factors handbook, chapter 5, I think 2017. But since then, there's been, what's a little bit difficult with that type of summary is two things. One is users of the exposure factors handbook generally look at the reasonable maximum exposure, but in the lead modeling world, we're a little bit more focused on the central tendency. And so I think it might be helpful there to kind of just acknowledge that there's this slightly different way that we handle exposure parameters when we're using mechanistic models, and we're a little more focused on the central tendency. But more importantly, there's age group differences, and there was a nice series of kind of updated evaluations of this question of what is the literature support in terms of soil and dust ingestion rate for the age groups that we're trying to use as kind of ways to break up the exposure period over a lifetime. And so I give some references there, actually EPA's funded work. So 2021, some work that Syracuse Research Corp did for EPA on revisiting some of the good work at the Bunker Hill site, and then also an age-specific soil and dust ingestion rate update. I didn't have an actual date on that, but it's available through EPA's webpages as well. So other research programs are providing some good summaries that might be helpful on the soil and dust ingestion rate. Dietary exposure pathway, one thing that caught my eye was there's a lot of good work that Jackie Moya and others have done to answer this question about the uncertainty between extrapolating from the short-term recalls, 24-hour recalls, to a long-term average. And it all comes down to how you apply probability weights to the respondents and the non-respondent categories. People that indicated they ate certain food categories during that 24-hour period, and folks that didn't say what they ate during that period, but they could eat it later. So there's different techniques to handle that, and I provide some citations that might be helpful. So just mentioning that that extrapolation uncertainty and methods to address that might help. This is really just a nitpick. There's a reference to lead in spices as another potential exposure source, and then to New York State. New York State actually, so the citation was correct, but New York State actually it's a little bit more nuanced. They have class 1 and class 2 action levels, and those levels have changed a little bit, and I provide a more recent reference for you there. In terms of the time spent on, kind of setting up the different modeling approaches, mechanistic models that are available, I thought it was spot on. It was mostly a discussion introducing IUBK and the all ages lead model, which hopefully will be released again here shortly. And then it wasn't until well later in the appendix that we hear about the currently used adult lead model. So you might mention that up front. And then with a nod to my colleague from California, it might be helpful to represent lead spread as well, particularly because of its connection as it's one of the few models that's used to explicitly bring in the delta blood lead metric as a risk metric, whereas the other models try to predict absolute blood lead at different age points and as a function of different exposure regimes. So that delta blood lead versus the absolute blood lead, and I'll mention a little bit about that in a later response to one of the other comments. The question 1 still, 2.2a, asks us for our thoughts about integrating exposure and toxicokinetics. This is really just pointing out a couple of things I was looking for that I was pleased to see. There's a very nice discussion of the influence of age and physiology and how that can be incorporated in trying to understand, the kinetics that change during developmental stages, and how that can influence both exposure and how we think about the blood lead and bone lead relationships. That was really well done, I thought, in the chapter. So And then I was also looking for how specifically GI absorption under fed and fasted states would be covered, and that was done nicely as well. So I don't actually have any good recommendations. Hopefully the other committee members do for you there. I think I'm going to stop there. Oh, just one other, there was you specifically asked if the discussion adequately describes air-related and non-air-related pathways. So again, I was a little, one comment on that conceptual site model 2.1. Also, there's, right at the beginning of the appendix, there's a brief discussion of atmospheric soil lead, not atmospheric lead, but atmospheric soil lead, which seems like it's, resuspended soil and dust. So a little bit more discussion on what that actually, what you mean by atmospheric soil lead in the context of other sources of lead, I guess, would be helpful. That's all I had in hand.
All right, thank you. Perry, do you have comments about the first question, charge question?
Yes, thank you. I think it's a very well-prepared appendix, and most of my points are pretty narrow, but I think one larger point about conceptualizing various exposures and their contributions to blood lead levels, I think we need to be careful about the language that's used here. In this chapter, we discuss a, quote, primary lead source. In the first chapter, they mentioned aviation fuel as a dominant contemporary source. Obviously, in the first context, I think they're trying to say in terms of airborne emissions, but it doesn't specifically say that in that context. And in this chapter, we talk about primary lead source. We need to be very careful about who we're addressing or which population or subpopulation or individual you may be focused on. So I think for an elevated blood lead level, that's one consideration, but you need to be careful about how you characterize that. But I think it fails to provide the right context there, that there's no single primary source on an individual level that can be identified in many cases. I think we need to say that here explicitly. I think this becomes more important as we lower exposures overall, that each individual source has a relatively greater weight. So as we get rid of industrial emissions or aviation fuel, the other exposures all become more significant in that context. And it does discuss isotopic analysis in this context of sources in section 2.1.2. But I think it should be carefully noted here that this is a research tool and generally not used to identify an individual's source of exposure or sources of exposure. And I don't think it was explicitly stated that way in that particular section. I think that would be something that should be noted. And the other overarching point, I think, is that it discusses, for example, in the context of ammunition, it talks about it being a dietary intake, talks about it being an occupational exposure, but it doesn't mention that ammunition is also a key airborne source of lead exposure. And I think that would be important to provide some context around that, given the growth in ammunition sales in the United States and the larger contribution that it is providing both from the recreational side but also for the occupational side. Thank you.
Thank you. Joel, do you have anything you want to add to this first question?
So I commend the authors and the EPA for the synthesis of Appendix 2. They've done a remarkably comprehensive effort, well-written and cogent. And the EPA should feel good about Appendix 2. My comments relate to the second question. So,
all right. We'll move on to Kathleen then.
Yes, thank you. Um, Yes, I agree that the Appendix 2 is well-written and organized. And I have a few comments where I suggest some rewording and a reorganization of content for clarity and accuracy, but they're narrow as Perry had commented on his responses. I particularly like to call out section 2.2.1.1, the section on inhalation. And I've suggested some rewording to help with the clarification of that section on particle size influences. For example, particle size influences the pattern of regional deposition within the respiratory tract, along with other factors, and systemic absorption, and that captures, the essence of that subsection. And then there's some rewording in the next couple of paragraphs, but I particularly want to zero in on a description of Cal EPA's simplified method for estimating default inhalation transfer coefficient as a component of a physiologically based model, which is, how do I say this? It's misrepresented. So there's a more appropriate description that's provided in a very recent publication with myself as the lead author, and I think that particular section about Cal EPA's simplified method would better fit in section 2.6, which is the section describing the various different mechanistic and pharmacokinetic models. So that's what I have to say. Thank you.
Thank you. Is there anyone who wants to, on the panel, who wants to weigh in about this? We'll give you a chance at the end, too. I'm thinking it's almost 10:30, so maybe we'll take a 10-minute break before we have our lunch break. So if there's no other comments, then we'll come back to the next charge question after our break. So 10 minutes. 10 seconds. All right, our timer has told us it's time to get back to focusing on our task at hand. So I'll give people a minute to get to their seats. So I think, Phil, it's back to you for 2B, right?
Yes, 2B, thank you. Okay, so 2B is about biomarkers. Questions are, does the appendix cover the state of knowledge on lead biomarkers? Is the focus on blood and bone appropriate? What about other tissues? So short answer is yes, I do think the focus was appropriate. Most of what we're trying to learn about exposure and external exposure and internal exposure, we tend to look at blood and bone primarily, but not only. The chapter does a very good job talking about how the kinetics change as a function of different things. And so when we're particularly looking at the predicted bone and blood measurements from models, understanding, how the kinetics change as a function of age gives you the appropriate way to interpret those relationships between what you measure in bone and blood. And so that was explained well, and then the consequence of that in terms of potential implications for how we interpret epidemiological evidence was also well described, I thought. There's a very good discussion of the so-called prolonged terminal elimination phase. So this idea that blood can remain high if bone stores are high because of the ongoing distribution between compartments. And then in terms of other tissues, I thought it was appropriate to bring up some of the other tissue biomarkers. For example, urine is discussed, but mostly to bring up some of the limitations in its use, at least as a measure of chronic exposure. So those were my comments. I didn't have more comments on that.
Okay, Debbie, you had your flag up. Did you want to speak now? Yeah, absolutely. So Perry, you're next. Do you have anything, nothing to add? Joel, do you have anything to add on this one?
Thank you. Again, this section was nicely described, and I'm not aware of any key publications that would illuminate or modify the exposure kinetic information. I did have a couple of comments. However, on, for example, not to diminish my enthusiasm for this appendix, but several figures are presented in sections 2.2 and 2.3, which illustrate lead in selected compartments, mainly blood, bone, and body, and others, and to show the relationship with different exposure or age. So these simulations include children up to 10 years of age, and the figure legends for all these figures state that the simulation is based on the ICRP lead kinetic model and cites Liggett's 1993 paper. I'm sure your modelers are well aware that Rich's 93 model was not adequately scaled for children. In fact, his 93 paper provides a fairly detailed assessment of the limitations of his model for children, and mainly how it relates to partitioning between plasma, urine, and bone due to to the high rates of bone formation and bone turnover in children. So my question is, which Leggett code was actually used for these simulations? The cited papers, I conclude that the original 93 code was used, but I know that the EPA and others have implemented the Leggett code with modifications to be appropriate for children. And I think that strongly suggest that this appendix should clearly clarify the source code that was used and if appropriate, the modifications to be appropriate to children. Also, these simulations typically define lead intake as 20 or 120 micrograms per day. And it's never stated whether that was respiratory or intestinal. Not that it's terribly important, I just think that's a piece of information that's lost. Figure 2.8 illustrates the blood, bone, and body lead with a high, that is 120 micrograms per day, or extraordinarily high, 4,000 micrograms of lead intake per day. This extremely high lead intake seems extreme for the 21st century and not terribly useful, and thus detracts from the flow of Appendix 2. And I think the simulation could just as easily show the delayed clearance of lead from blood by using a lower intake and zooming in on the part of the blood lead curves, even superimposing the blood lead curves and the bone curves for the two different simulations in the same plot. And I thought, yes, the air-blood-lead relationship is very nicely described.
Okay, thank you. Kathleen, do you have anything to add to this question?
Just want to mention that the difference in the two Leggett papers is an important distinction. Thank you, Joel, for mentioning that. That's those are important distinctions. Anyway, and also wanted to add, as new updates appear, sometimes older or original information tends to get lost. And I suggest that in the Part C of the this second question, where our relationships between blood lead and lead in soft tissue and urine adequately described, I suggest adding a summary on the potential impact of deposition and elimination of lead during initial days following exposure through the inhalation route, such as that described in Leggett 1993, the metabolism model, because he points out that the impact of swallowed lead really changes the route of elimination, at least in the first couple of days. That's it.
Thank you. And now I think we move on to Debbie.
Yeah, hi. And what I would like to offer is something especially to think about for the future when you're talking about particle size and also toxicokinetics. So one of the things that's become very clear is that lead is carried on particles, we know that, but the ultrafine particles are a particular problem because when you breathe it in up the nose, those particles travel directly into the brain where the lead can be dissolved and agglomerate with other metals. I think it needs to be recognized, the problem being that once that lead is in the brain, it's not necessarily reflected in serum markers of, for example, blood lead. So that component of air inhaled lead is particularly, may be particularly toxic. So thinking about that as we move into the future, we don't measure ultrafine particles. We're regulating 2.5, and it almost looks like taking out the 2.5 component has left the ultrafine levels in the air being as high or higher than they were before. So, thanks.
All right, thanks for that. And anybody else on the panel? Oh, sorry, thank you. Brian, go ahead.
I apologize if I missed it. I saw that CBLI was covered. I saw that bone lead measurement was covered, but I didn't see a review of the studies that looked at relations of CBLI with tibia lead and the implications of what can be learned from those studies to the toxicokinetics and the health effects studies. I hope I didn't miss it, but I think those are very useful in sort of how we make inferences in the health studies.
Does anybody at EPA want to comment on that, or?
I mean, I think, I'll just say that I think that's a useful consideration, and we'll think about how to enter some information on that. So.
Oh, two more hands online. So Bruce, you're next.
Thank you. First, just to second Debbie's comment about particle size, that's especially important, for example, children, pregnant women, everybody else that lives around airports where the particle size of the lead is 4 nanometers, extraordinarily small. So of course it can, as Debbie said, go up the olfactory nerve, but also smaller particles may be more toxic, and maybe just reinforces the idea that we really need to move on getting rid of leaded aviation fuel. I also want to bring up a point that I know Howard brought up in his comments, and that is shifting from microgram per deciliter to microgram per liter. We get fooled, I think, in believing that the blood lead levels are almost zero, and we really don't need to worry about them because, well, it's only 1 microgram per deciliter, right? Well, if we convert to microgram per liter, which is how we talk about all the other metals, now we're talking about 10 micrograms per liter. Of course, it's the same thing, but as we get down to these lower levels and we're trying to look at apportionment, we're trying to deal with people's tendency to dismiss these, quote, low levels of exposure when evolutionarily speaking, they may not be. I think it's time to shift to a different metric. And then finally, I just wanted to make a comment on the challenge of identifying the slope. And this is, I'll read it from the executive summary, but it was discussed earlier. Although slope factors increase with decreasing air lead concentrations, it's possible that the contribution from non-air exposure pathways may lead to higher slope factors at lower concentrations. I had to read that about 10 times, and I'm still not sure I either understand it or agree with it. I can certainly come up with an explanation why the levels today would show exactly what we see, that is higher rise at the lower levels, because there's less confounding with other exposures that were more prominent in the past. And so I'm not quite sure, number one, if that's a useful paragraph. Number two, if it's true. If it is true, it seems to me it's equally likely not to be true. And so we should bring that out as well. Those are my only comments.
Thank you, Bruce. Howard?
Yeah, I just wanted to point out that in the health effects section, there's a lot of attention appropriately given to how cumulative exposure is a predictor of health impacts that are not predicted by blood lead. And this is something Brian Schwartz has studied, our group has studied. But there's relatively very few studies that actually have bone lead, since it has to be measured using this in vivo X-ray fluorescence instrument. But Sung Park and colleagues, including myself at the University of Michigan, have been doing research on how to predict bone lead using blood lead and a number of physiological parameters. They developed this methodology using NHANES data, and then showed that it could, once you impute this value, it has a much stronger relationship with blood pressure and hypertension than blood lead. And I think it's worth mentioning because I think the research community could use this tool, cross-validate it in other populations, and then use it to explore how cumulative lead exposure may impact on the chronic disease outcomes we're worried about in more studies.
All right, thank you. Andy Brisa.
Thank you. Amazing chapter. The amount of literature you synthesize is enormous. Thank you for providing this summary. I have a comment on section 2.1.5, which deals with disparities in exposure. I have a general comment about how sometimes place and race are sometimes conflated. In the very beginning of the section in page, so I have a couple of recommendations around that, if appropriate here. So one of the, in page 2.2-33, there is a call out to specific person level factors that are related to exposure. And then there is a sentence about place level factors, and there are no exposures given for place level factors. So it would be useful to, for example, call out urbanicity and racial segregation as specific examples of residential factors related to exposure. In section 2.1.5.4, I believe, this is the section looking at race ethnicity as a factor related to differential exposures. There are passages there that explicitly call out characteristics of census tracts, for example, percent of a particular race ethnic group. And, but sometimes the language seems to kind of imply that these are group, as in a population subgroup, versus characteristics of the place, which is racially segregated place. So throughout that section, there are a couple of other passages where, for example, differences in exposure for children, minoritized children compared to white children are linked or discussed in the same paragraph about differences between rural areas and urban areas. And so it may be useful if that section gets separated out into potentially two sections, one that talks about place level factors specifically, and then person factors such as race, and potentially link the two, right? So some of the differences that we see among black and white children or minoritized children and white children are related to these place level factors as well. This distinction of exposure at the neighborhood level versus person level has further implications for how we interpret health effects and disparities in health effects in the later chapters. So yeah, that's my comment. Thank you so much.
Thank you. Not seeing any other hands up. I think I'll return then to Phil for the third of these three questions.
Yeah, so the third section asks us to, or the third question asks us to focus on sections 251 and 252. These discuss empirical models, so not the mechanistic models, but the empirical models that are used to examine relationships between air lead and blood lead. And the question asks us to comment on the effectiveness of the synthesis of the current state of the science on that. I had two thoughts, and one maybe piggybacks a little bit off of Bruce, your kind of highlighting some language that's used in the summary section to try to interpret what might be biasing potential slope factors or quantifications of relationships. And this is one place, one of the rare places where I found the discussion of the literature, while thorough, jumped around a lot. So in this section 251, there's discussion of bias, potential bias that's introduced, either upward bias or downward bias in these estimates of slope factors, depending on study design and different population factors and that sort of thing. So it might be helpful to lay out those topics that are discussed in maybe a table format and use one of these sort of indicators of this type of aspect of a study design might tend to bias high, this other aspect might tend to bias low. And so one of these simple tables could be a good visual, and that might help later when you're trying to generate some overall summary statements. Then you're sort of indicating that most of the studies that are now the basis for maybe the lower level exposures don't suffer as much from these types of biases, but maybe these. So that's just an idea. The other thought that I had, and I mentioned this earlier, this might be a good place to introduce the idea that the empirical models that are developed do provide slope factors, and those slope factors can be viewed as one way of evaluating risk metrics, and that's distinct from estimates, modeling approaches that try to generate a predictive concentration or mass or amount. So the absolute estimates of lead in a compartment versus the relationship between change in exposure and change in lead are have a regulatory history, including here for CASAC. So I think it might be helpful to just have a short discussion right up front before you kind of, as an introductory concept, it'll help frame how some of the information from the empirical modeling approaches might have some merit in terms of understanding relationships between exposure and risk, ultimately. So those are my two main comments.
All right, moving on. Perry, do you have anything to add to this 2C?
Well, I'm not sure if it addresses this specific point, but within this appendix, I had a couple of other points that I wanted to raise. One is that in section 2.1.5.1, it uses the title Proximity to Lead Sources, but I think it should be clear, it would be clearer to say proximity to sources of airborne lead emissions in this context. And I think that this discussion about blood lead levels and exposures to airborne sources of lead would benefit from citing studies that the California Department of Public Health did around the Exide lead battery recycling facility, which was closed by the state, but looked at blood lead levels just before the closure and concluded that children's blood lead levels in the area closest to the site were more highly elevated than children who live further from that particular site. And I think that's an important point in this context. Also, I think another comment that I wanted to just, or a clarification that I wanted to raise was that in the discussion of the race ethnicity gap in blood lead levels, it's unclear in respect to indicating if the reduction in the gap is proportionate to the reduction in blood lead levels in the United States overall, or if the gap has been reduced as a relative percentage of the population's blood lead levels. So I just think that should be clarified as a key point there. Thank you.
All right, thank you. Joel, do you have anything to add? Microphone.
Again, I found this section very readable and coherent, and I don't have any comments to add to what Phil said.
Great, thank you. Kathleen.
Thank you. I just have a couple of comments that are kind of drilled down again. I thought
that the section was good and well explained on the broad sense. However, there was notably, a broad statement saying that looking at PM 2.5 to PM 10 and TSP, the differences in sample size has a potential factor in the consistency of statistical significance. Because when I looked at, for example, the Meng paper, which was cited as having, a broad data set, and I could see that there was one statistically significant finding from exposure to PM 2.5 in the age 6 to 11 cohort. But generally, the number of samples between the PM 2.5 and PM 10 or TSP, there was an order of magnitude difference, and certainly that would have an impact on whether or not you could see a statistically significant finding. So wanted to point that out. And I think it should be pointed out generally after the broad statement about the statistical significance of the PM 10 and TSP being consistent across the data set. And then wanted to point out that there's a paper that I'm familiar with and used in the most recent paper that I published, or that I and my colleagues published, Pierre et al. 2002. It was mentioned in this section of the EPA's review that there was a steep slope from the Pierre data. However, the slope is based on a microgram per liter rather than a microgram per deciliter in blood. So therefore, it's not comparable to the other measures. And just wanted to point that out. And then, let's see, is there something else? I also suggested that there should be a brief explanation of the relationship between bioaccessibility and the surface area of small particles versus large particles. I think that's an important thing to explain in this section. That's all I have.
All right, thank you. So that we've completed the list of discussants and charge questions. Anyone want to follow up? Did you want to say something, Phil?
I just had a question in terms of taking notes and writing up this sort of comment section. Actually, Howard, this is going to go back to you and your comment. I was curious about your comment about multi-factor modeling with the NHANES data and maybe improving it. And I can read your comments, but I missed your point about what it is that was being predicted. Was it an outcome, or was it a tissue level, or someone said bone? But I thought your comment, Howard, was that when you incorporate bone along with blood, you can predict, but maybe I misheard.
Sure. Yeah. No. The research and the reference I put in the chat was a method for predicting bone lead using blood lead and other physiological parameters like chemistry screens and et cetera. And that could be a tool that could be used in other large cohort studies that have lots of data, like the Framingham study on cardiovascular outcomes and other things, and blood lead, but they don't have bone lead measurements, but they can impute it by using these kinds of methods. And then they could see how predicted bone lead might behave in terms of predicting those cardiovascular outcomes.
Got it. Thank you.
So Howard, just a reminder not to use the chat for that, just email it to me. Thanks.
I will.
Bruce.
Yes, thank you. I just wanted to make a comment about the Richmond Bryant paper, 2014, that was described. And to me, that's one of the more important studies that's come out, certainly around air lead in the past decade or more, because what it raises questions about is whether we can be complacent, whether blood or air lead levels are coming down, so we don't need to worry about them. We don't need more air monitors, for example, because what it really is saying is that the lead exposure begins to increase dramatically where most people are being exposed. And for those of you that aren't familiar with some of that work, like Jeffrey Rose really promoted, one of my favorite examples is, we look at something like cocaine and heart attacks, and people that use cocaine in the past 24 hours are over 20 times more likely to have a heart attack. And that's a big deal, right? That's a huge risk. I'm not sure there's much else that I've heard that's got a bigger risk. But altogether, it accounts for less than 1% of heart attacks, whereas air pollution, which accounts for a fairly small increase, like a 10% increase, ultimately attributes over 7% of heart attacks because everybody's exposed. And so that study with that shape of air lead versus blood lead, it seems to me, is extraordinarily important. It deserves a lot more discussion.
Thank you. Mark.
Yeah, thanks. So just to follow up actually on Howard's point, not exactly sure where my point is going to fall in on this, but the idea obviously of predicting bone lead through blood and other things is a great one, and then can be utilized in other places, because as he pointed out, the classical KXRF is not very widely in use just because of all the issues around it. And I don't know whether this belongs in here or not, but I wanted to sort of put in a plug in that same kind of vein for a lot of work we've been doing on a portable XRF device, which was originally also explored and to not very great effect because of the technology at the time, but the technology has advanced dramatically. And so we have, especially in detector technology, so we've been doing a lot of work kind of validating a portable XRF device to measure bone lead. So it's not totally devoid of issues in trying to use it in studies, but it is far easier to do than the KXRF. And so I don't know whether it is worth a discussion, because then it can be employed in many other places like the Framingham study or in the field in ways that the KXRF cannot.
All right, thank you. I'm not seeing any other hands up. Any further discussion on this appendix? And Phil, you already asked for some clarification. Do you think you have what you need to do the draft discussion? Great. So Steve, we were going to circle back and I'll turn it over to you.
Yeah, thank you. I think we have one clarifying question for Appendix 2, but I'm also would like to invite colleagues up from OER to address a couple of the questions that kind of going back to some of the monitoring network that came up under Appendix 1 and kind of bleeds into Appendix 2 as well. So first I'll start with the question on Appendix 2.
Yeah, this question is just for Kathleen. You mentioned in your comments the Fleming papers to include. I just wanted to make sure, are those the two papers, the Fleming 97 and Fleming 1999 from your paper? Okay, just wanted to make sure we had them all. Thanks.
Yes.
Okay, yeah, thanks.
Hi, my name is Deirdre Murphy with Office of Air Quality Planning and Standards, and I have with me Kevin Cavender, who's also from Office of Air Quality Planning and Standards. He's the lead on the lead monitoring for the office, and I'm the lead on the lead NACS review for the office. And we just wanted to clarify a couple things that came up in the discussion on monitoring and concentrations. First, before having Kevin talk a minute about the network and how it differs from the PM network has a different focus. With regard to the two sites that Dr. Chow mentioned with regard to lead monitoring data, those data have been used extensively by the office. One of those two sites, the one in Indiana, has been proposed for the Superfund list, so it's getting action because of those data. And the second one, additionally, because of those data, the office has taken action and it is now designated a non-attainment site. It's on the map that's on our website. It was designated earlier this year, at the early part of the year. So those two sites, those data have been used by the agency in actions to reduce the sources of those lead to the environment. Now, with regard to the monitors, maybe Kevin could talk about how the PM monitoring network is different. It's a non-source oriented, well, he'll say it better than me, but lead has been a source-oriented monitor. Back in the 2008 review, we made a number of changes in that regard.
Yeah, thank you. So yeah, there were a number of questions that came up about the monitoring, so I thought I'd add some clarification. There were some comparisons to the PM 2.5 network, noting the size difference, several thousand versus maybe 100 or so. And it really goes down to both networks really have the same objective. They're both NAAQS surveillance networks. They're out there looking for NAAQS violations so that we can address them through our regulations. The primary difference is lead is a source-oriented. What we've seen, the high concentrations are all associated with sources, and the concentrations tend to drop off very rapidly with distance from that source. So when we monitor in non-source areas, we find very low concentrations compared to the NAAQS. We actually, as part of the 2008 review, we put out a population monitors where they weren't source-oriented. And in 2016, we took those back down because they were all reading in the range of 0.01 micrograms versus 0.15 micrograms per cubic meter. And so we obviously deal with resources is monitoring. It's all kind of a zero-sum game. So when we see resources that are, we thought, low priority to measure those concentrations, and again, there was not a lot of variability, and that could be well due to the limitations of the monitors itself at those concentrations. So anyways, we identified those as kind of low priority monitors, and in 2016, I believe it was, we changed the regs and had those removed. So that was about 50 monitors that went down. When 2008 went out in the 2010, we made another monitoring revision in 2010. We put out about 150 source-oriented monitors, all of them trying to identify the concentrations around specific sources. And then as time went on, we allowed many of those monitors to shut back down because we saw the concentrations were less than what we have as a waiver allowance at 0.05 of the NAAQS, 50% of the NAAQS. We said, okay, we think the concentrations are low enough, we can probably shut that monitor down. And so we regulate it that way. And so that's why we see the drop back down after probably about 2016, we started getting the data in and folks started asking for those shutdown allowances.
And if I can just add one more to clarify, those regulations that went into place in 2008, 2010 were specific to requirements for what areas had to have a monitor. And there's a requirement that they be at places where there's a source that emits a certain magnitude of emissions, and that those regulations are retained. They are still there. So as information comes in with a source of a particular magnitude, we are required to put a monitor there. Additionally, if there is site-specific information, there can be a monitor put in based on that. The case is made and a monitor can go in. And as was said, they can only be shut down when then you have measurements that go below a certain magnitude.
Right, a 3-year period, looking at the design value over a 3-year period, if it's less than half of an X, we allow for a discontinuation.
Thank you. Bruce Lampier has a question or comment.
Yes, thank you for the clarification. It certainly makes sense from that perspective. One of the things that we saw in the Santa Clara County study of an airport is that presumably at levels below NAAQS, we don't really know because we don't have air monitoring. We saw a 25% increase in children, a 25% increase in the blood lead level of children, who live downwind, 10% if they lived within half a mile, another increase if they went to school nearby. Without having access to air monitoring, we can't really know whether the existing NAC standard is adequate to protect children or pregnant women or anybody else. And so it seems to me that you've got really at least two different reasons to have air monitors out there. One is, you've described it as to understand the source. And if the source is below a certain level, doesn't really matter. Wouldn't it be a waste of time and money to have air monitors out there? Perhaps under that justification, yes. But what if you're really interested in is making sure you're protecting the public's health? Well, then you need air monitors out there to find out not only where the sources are, but what you're finding at lower and lower levels, not at the NACs, not at half the NACs. It could be at 10 times lower than the NACs, that in 10 or 15 years, if we had a monitoring network, we might find evidence that there's harm. But without a national monitoring network, we won't know. There's a reason that there's tens of thousands of studies on PM 2.5, and they're finding more and more health impacts of PM 2.5 because they've got the ability to measure it. And so even if you say we don't need to measure it, lead, because it's below some cutoff, you're failing to provide the evidence, the information to know whether in 5 or 10 years we're adequately protecting the population. And it seems to me that that's at least half of what EPA is supposed to be doing.
If I could just clarify, I believe there was a monitor at that airport in Santa Clara. As part of the 2008-2010 monitoring requirements, there were monitors put out at a number of airports of different types with different levels of activity in an effort to collect information about this issue, because aviation gas at that time had become such a large portion of the national emissions inventory. So based on those data, we've been collecting the data, and I believe that's one of the sites where we then learned about concentrations that were monitored. Our sister office of Transportation Air Quality has been doing a lot of work since that time with those data, including doing additional monitoring and modeling work. And as a result of that, in last year, they proposed to make the agency proposed to make a finding of endangerment for emissions from airports utilizing aviation fuel, and the agency is currently working on completing a final decision on that action. Subsequent to that, the process then goes into standards decisions. So there's an activity going on based on collection of those data, just to clarify.
Yeah, thank you, Deirdre. And if those had been done at the same time, the study that I was involved with looked at blood levels between 2011 and 2017, I believe. If we had air monitoring done during that time, we could have learned a lot more, couldn't we? But we didn't, and so we couldn't.
Yeah, a couple of cards up, Brian, and then we'll move to the other side of the table.
Are any of your lead monitors strategically placed to detect disturbance of legacy lead contamination near urban smelters, near abandoned houses in Baltimore? And if so, how many of the 100 are like that, and how are those locations selected?
So we certainly do have some monitors that are still in the legacy, primarily near smelters that have shut down, and we see a lot of potential for exceedance of the NACs. Again, we're primarily focused on the exceedances of the NACs. And so, yes, we do have, it's probably just a handful, maybe 3 or 4-ish. But in order to be able to shut that monitor down, the concentrations have to drop again down to less than half the NACs. Once that's happened with a 3-year design look, we do allow them to shut them down. There is a lot of work at the EPA to evaluate that decision, whether that is something that we want to do, because there is the potential for disturbances, well after that 3-year period that could be an issue. So that's something we're considering.
Did you say 3 or 4-ish, or 30-ish, or 40-ish? 3.
Three, yeah, sorry.
All right, on the other side of the table, we have Judy, and then Perry, and then online we have Howard, so we'll take, go ahead, Judy.
Yeah, thanks for the clarification. Are those new sites when you add between 2008, 2016, are they TSP or PM10?
Primarily TSP. We did make an allowance for PM10 in very limited situations where we're very confident the source is emitting less than PM10 size lead.
Yeah. Another question is that, thank you. Another question is that it is true we have about together over 300 sites for the CSN and improved sites that have lead, but not seeing any concentration trend or any analysis or any attention has been paid on the lead, PM 2.5 lead at those sites. Have anybody looking at those data?
I know I'm not, I can't speak for ORD.
It is the question, just to make sure we understand the question, looking at trends of PM fine at monitoring networks such as the CSN, just to see the trends, right? Because, right.
CSN site started the lead analysis since the year 2000, whereas improved site started 1988. So we do have a long-term PM 2.5 lead on those filter measurement based on XRF. It's probably worthwhile looking at it.
Yeah.
Yeah.
I'm not sure if that's been done yet, but that would be useful.
Thank you. I think we're up to Perry now.
Yes, thank you. I had a question regarding the private ambient air monitoring that's going on under by companies at their fence line for their permitting. And given that lead is source-specific, airborne lead is very source-specific, if there's been any attempt by EPA to collect that data and evaluate that data from specific fence line monitoring. And I know the precedent for that is in South Carolina, where the largest battery recycling facility, the Clarios Johnson Control Plant, and South Carolina was required to provide that information to the State Department of Environment on a regular basis that was then posted online, et cetera. Is there any attempt by EPA to do that at any other location and monitor that from those sources? Thank you.
Yeah, so when you mention fence line, for the most part, I think what you're referring to is our next compliance monitoring. So South Carolina is one of the few states I'm aware of that has used private, basically having the company do the monitoring and then they use the data. For the most part, all the other states and monitoring agencies do their own work. There could be some others. So South Carolina is the rarity in that situation. Nonetheless, all of that data must be submitted to EPA through the AQS database, so that if they are collecting it for the next compliance network, it must be reported.
Only if the state is, only if the state is already collecting it. But my question is, could EPA collect it?
Oh, could EPA collect it?
Yeah.
We could. We tend to not do that. It's the monitoring agency's responsibilities, and we regulate them to have them monitor where we think it needs to be done.
So just to clarify, the NAAQS compliance network that we refer to, the state and local agencies are the agencies that collect those data. The EPA does not do monitoring per se, except in special studies, right? And
Yep.
so in this case, I think Kevin's saying, if I'm following, that at the South Carolina site, rather than the local agency or the state agency doing the monitoring at a site where monitoring was required because of potential for exceeding the NAAQS, it was sort of outsourced, you might say. They require the company themselves to do the monitoring work and just submit the data to them. I'm not sure if that was clear, but that may or may not answer your question.
Well, I think the point is that there's this, a lot of data out there that's not being collected by EPA that maybe can be collected from states unlike South Carolina that don't collect that data.
But those data, all of those data are submitted to EPA's air quality system, which is a national database. So those data do come to the public and EPA. Is that clear?
That's beyond the 100 monitors you're talking about, right?
It's part
No,
of
that
it.
is the 100 we're talking
Part
about.
That includes the 100 monitors. Okay, that's all in there. Okay, thank you.
All right, I think we're up to Howard now.
All right, yeah. This gets back to this whole cumulative lead exposure thing. I think the EPA has done a very nice job of talking about the toxicokinetics in the different compartments. But then when the discussion of the air lead blood lead relationship, what I haven't seen, excuse me, is a discussion of how internal stores might actually be contributing to the blood lead and be maybe affecting the apparent relationship, quantitative relationship between air lead and blood lead. And this makes, this is really important because depending on not only the age, but the cohort calendar effect of when these studies were done, you could expect that internal sources of lead would be contributing a lot to the blood lead, with apparently a reduction of the air lead blood lead relationship. Whereas, you know, the perfect study would be a population that was completely naive to lead exposure, then being exposed to air lead and following what the blood lead air lead relationship is occurs. That hasn't happened. So you need to, it seems to me that EPA needs the sophistication in their discussion to sort of understand how to disentangle the cohort effects and the age effects from the apparent air lead blood lead relationships.
All right, thank you. Is there any, I don't think, is there any follow-up needed? No. George?
Let's see, Deidre, I wanted to thank you for mentioning the proposed endangerment finding. That actually is potentially very important. If I understand it correctly, once it's finalized, well, which I think should be soon, fairly soon, that, let me know if I have this right, would give EPA the authority to develop limits for lead emissions from aircraft. Is that the process?
Yeah, our office, the Office of Transportation and Air Quality, is the lead on that action, and I believe they have pretty explicit information on their website about this, but that sounds consistent with my understanding as well.
Okay, so that would be, you know, the subsequent possible regulatory action actually could be a way to clean it up, which that's good news. I wanted to make sure folks in the panel were aware of that, because that could be a game changer in terms of the lead emissions into the environment. Thank you.
Bruce, you have your hand up.
Yeah, I just wanted to respond to Howard's comment. When we looked at the children who lived around the airport in Santa Clara County, what we saw is that as we looked at younger and younger children, so for example, we could look at children under 18, under 5 years of age, and we could look at under 3 and toddlers under 2. And as we looked at younger and younger children, or in Howard's words, naive children, children who are more naive, the relationship was greater at the lower levels of exposure, which could be both air lead, of course, but also settle lead that's ingested, right? It could be both of those. But what the data suggest, and cutting it very different ways, like what happens during the reduction in air traffic during COVID, we saw a pretty dramatic reduction in blood leads, would suggest that those differences were driven by air lead. And so the more naive children, the younger children, we saw even greater increases from the air lead.
Thank you. Any further discussion on this appendix or further questions for EPA? Steve, go ahead.
I just want to thank my OER colleagues and mention that, this has been a good discussion about the monitoring network, and certainly any suggestions or comments you have on the network are within the scope of this review of the ISA. We definitely comments on how we've characterized it, but also if you identify sort of needs, kind of looking forward, certainly include those in your comments. Thank you.
All right, thank you. I think even though our agenda says we're not going to get to Appendix 3 until after lunch, we have about a half an hour. So why don't we switch gears to Appendix 3? So there will be different EPA people up at the table with Steve, and a quick overview, and then I'll turn it over to the lead discussants.
Okay, good morning. My name is Evan Kaufman, and I'm an epidemiologist with the EPA and the health lead on this assessment. And so as we transition to talking about the health effects of lead, we'll start with a discussion of nervous system effects. And so I just wanted to provide a quick refresher on some of the information that we provided in the briefing in April. So before we dive into the specific causality determinations for nervous system effects, I just wanted to talk about our causality determinations in general. Which, as detailed in the ISA and as well as the preamble to the ISAs, our causality determinations are made using a weight of evidence causal framework, and there are 5 levels to that framework, and the delineation between each of those levels is based on our ability to rule out with reasonable confidence chance, confounding, and other biases. I noted in some of the preliminary CASAC comments that there were some questions about how we make causality determinations when there are differing levels of evidence across endpoints within the health outcome category. So I just wanted to touch on that briefly. For each of those endpoints, we evaluate the lines of evidence using the same weight of evidence framework, but I just wanted to mention a few things as we evaluate those lines of evidence. First, evidence for a specific endpoint, if there's strong evidence, can result in a causal relationship for that overall health outcome category. So similarly, the lack of evidence for a given endpoint doesn't preclude a causal relationship. That said, coherence across related endpoints obviously strengthens our evidence base in making causal determinations. So just as a quick example, for this ISA, for cardiovascular effects, we obviously have strong evidence for lead-related increases in blood pressure and hypertension, as well as cardiovascular mortality. And so those lines of evidence for those endpoints really drive our causality determination, which is a causal relationship. On the other hand, there is limited evidence for cerebrovascular disease, but that doesn't play into our causality determination. So in our causal summary, we really try to highlight the strength of the particular lines of evidence that are driving the causality determination, and then also mention the limitations for those other endpoints where we do have limited data that aren't contributing to the causal relationship in that case. So I realize I used up most of my 3 minutes, but just quickly here on the causality determination for nervous system effects, we made 11 total causality determinations. Most of those are similar to the causality determinations made in the 2013 ISA. We had one new health outcome category for which there wasn't a causality determination in 2013. That was social cognition and behavior. And additionally, we had 2 changes in causality determinations from 2013, including sensory function decrements, which changed from likely to be causal to suggestive, and neurodegenerative disease, which changed from inadequate to suggestive. The change for sensory function decrements was really related to a slight change in the wording of our causal framework as published in the 2015 preamble, which was slightly different than what was available for the 2013 ISA. So moving quickly to the next slide, In addition to our causality determinations, we also made a few other key conclusions related to some of the science policy questions from the IRP Volume 2. And in general, those conclusions were consistent with the main conclusions from the 2013 ISA, including cognitive effects in children being substantiated to occur in populations with mean blood load levels as low as 2 micrograms per deciliter. No evidence, though, of a threshold across the range of blood load levels examined in those epidemiologic studies. Recent studies continue to support a superlinear relationship. And finally, we don't have strong evidence to identify an individual critical life stage or timing of lead exposure, noting that blood lead levels measured across various life stages and time periods are associated with cognitive function decrements in children, which is also consistent with the toxicological evidence. So that's all I have by way of intro, and we look forward to the discussion from the panel.
All right, thank you for that. So we'll move on to our discussants. So first up is Susan Corrick, and you can decide how you want to organize the response to this charge question.
Sure, thank you. Well, we can start maybe by doing it by question, although I'm not sure it works as well as for the previous appendices. I just wanted to start by commending the EPA. This is an incredible piece of work, and I'm in awe of all the effort that went into synthesizing such a vast amount of literature. So that said, I think there are some areas for potential improvement, and I want to start with a very generic comment, and that is about the use of full-scale IQ in research. And I appreciate that the document is dependent on past and existing literature for which full-scale IQ has been a critical component of identifying hazards related to lead. But I think increasingly full-scale IQ is being considered a dated construct, and the instruments for assessing it have tremendous amounts of bias potential, especially in underrepresented or disadvantaged groups. And adjusting for sources of disadvantage don't necessarily address that bias. And so there's been a push to try to get away from that as a relevant health outcome because of its bias. And to also consider that full-scale IQ has become identified as a source of, has been used in the past as a way to justify discriminatory practices. So it has an aura of weaponization around it, so that there's a growing community of researchers who feel uncomfortable using it as an outcome. And I say this appreciating that from a practical point of view, you can't change what's been done in the past. But I do think in order to be sensitive to how we think comprehensively about exposure risk and health risk, at least acknowledging the limitations of this outcome in the context of current thinking would be a helpful comment to include in the document. And then, with that caveat in mind, you're able to then build on what's been done in the past, and hopefully in future research there'll be more sensitivity to this issue. So that's just sort of a very generic comment. So I'll start with how the appendix identified strengths and limitations in the literature. And I think there's some inconsistency across the many measures that were used in the appendix, and I appreciate that when you have multiple authors doing something on this scale, things may not be as homogeneous as otherwise would be the case. But I think there are a couple of fundamental principles that it would be helpful to clarify. So for example, when discussing the various forms of exposure biomarkers that are used, particularly in understanding the relationship of lead to children's health or children's neurodevelopment, in a number of places, tooth lead is identified as tooth lead exposure is sort of described in a context that implies it's a cross-sectional study design, and that the timing of tooth lead collection between ages 6 and 8 years is identified as the relevant exposure time period, when in fact tooth lead is almost entirely used to represent prenatal and early postnatal exposures, so that understanding the temporal relationship between exposure and outcome is very different than when it's attributed to be an exposure assessment that reflects the time of collection. And I think there's a fair amount of inconsistency in that and some potential confusion that should be clarified. I think another theme that comes up a lot, again, especially in regards to children's neurodevelopment, is uncertainty around how to integrate the impact of past exposures on current blood levels of lead, and whether that makes it more difficult to understand the true concentration response relationship. And there's examples in this appendix where cord blood lead is not downgraded, but there's uncertainty associated with cord blood lead because it's unclear what the maternal contribution to cord blood lead might be based on past maternal exposures. And I think that's a misplaced concern. I mean, cord blood lead is fetal blood, and it reflects exposures that occurred at least at the time of birth. And if that's a relevant exposure window, the mother's history of exposure is completely irrelevant. So I think there are some instances where the document is overly critical or identifying limitations that really aren't limitations, unless, for example, looking at exposure windows close to the end of pregnancy may not be relevant to a particular outcome, which is a separate question and not really how the issue was addressed. So then I think some other issues that came up with strengths and limitations is I think there are a number of cases throughout this section where issues are identified as a source of confounding bias, and therefore sort of certain studies are considered less robust, when in fact they're probably not confounders, and they are potentially important determinants of outcome or potential causal intermediates, but not confounders. And those are useful factors to consider, but they don't undermine the validity or they don't present bias problems. So examples would be looking at the relationship of childhood exposure with neurodevelopment and adjusting for birth outcomes, which could be causal intermediates. So studies that don't adjust for birth outcomes may not be biased, it's just a different issue. Or looking at the use of psychotropic medications in studies of adult exposure and neuropsychological disorders. Psychotropic medication use is unlikely to be a confounder. It could be an important determinant of symptom reporting and other issues, so it's important to consider, but it doesn't, lack of adjustment for that doesn't introduce confounding bias. So I think oftentimes studies have been downgraded in terms of their rigor in ways that are actually probably not correct. The other thing that I found hard is I know that the study sample sizes are in the tables, but in reading the integration paragraphs and the summary paragraphs, oftentimes the study sample sizes weren't presented, and it was just hard to go back and forth, and it would be helpful to consistently present those, because in studies where you have very strong effect estimates but wide confidence intervals, if it's pretty clear it was a small study, that says something different about its potential contribution to sort of causality determinations than if it's a really large study. And the other thing that I think I found a little confusing is the more recent literature, as you know, has focused a lot on exposure mixtures and effect measure modification in analyses. And some of the exposure mixture studies were also criticized because they failed to account for the potential for exposure mixtures not only to confound each other, but to interact in lead's role. And in fact, a lot of those studies use BKMR and other techniques which allow one to explore whether there's interactions going on. And absent interactions, they don't need to be modeled. So I think sometimes there were criticisms of those studies which actually probably, again, aren't applicable, that interactions weren't found in those analyses. And so looking at exposure mixtures and their potential to confound each other is a totally appropriate analysis. I also couldn't tell, there was a lot of focus on effect modification studies, and it was hard for me to follow whether the overall main effects in those studies were considered in the analysis of strengths and weaknesses, and oftentimes those studies are underpowered because they're looking at smaller strata. And so interpreting those stratum-specific estimates can be challenging. One more list in the strength and limitations. I think for some outcomes, again, I think that a lot of these studies are perhaps more robust than the document would reflect. So for example, looking at childhood behavior using either behavioral checklists that are reported by a parent or a teacher or the child themselves versus a formal psychometric test. There was some discussion about behavioral checklists being less valid or incurring more measurement error. And I actually would argue that's not necessarily the case, and that oftentimes behavioral checklists can identify functionally very important behaviors that psychometric testing does not. And there are internal measures in most of these behavioral checklists, which are standardized, validated instruments that allow you to account for reporter bias. And so I think undermining the behavioral checklist literature by saying that it's a less valid or more error-prone measure is actually a disservice, that those are really very, very useful measures. And then, but I do think what was missing is that the more recent literature especially, I think, is increasingly focused on more diverse populations in terms of nationality, cultural, and linguistic issues. And some of these assessment instruments that are used in kids are not always culturally or linguistically appropriate, and that's actually something that wasn't addressed and would be important in interpretation of the more, sort of international body of literature that we now have access to. So I can stop there if we want others to then comment about strengths and limitations.
Thank you. Debbie, you're next.
Yeah, I too want to congratulate you. This is Yeoman's work to put together this chapter, having been in the area of lead for a long time. So my comments are going to be more general about this section sort of overall. And I'll give you one specific one after that. But I found it difficult to sometimes understand. There's a lot of interspersed discussions of the blood lead concentration and which data was the most important. So I found it difficult to actually hone in, if you will, on how you came to your causal determinations, because there's also a lot of repetition within each of these particular sections. So I thought there might be two things that would be helpful. One would be, and it's inconsistently done throughout this particular appendix, would be inclusion of things like forest plots. So yeah, maybe there is a causal effect, but it's only being seen at blood leads of 5 or more, right? But that doesn't come through very well when you're reading it. So maybe even italicizing that paragraph that says, okay, this is how we came to the conclusion, because I'm not sure I disagree with any of the specific causal determinations that you actually came to. I just think for a reader, it's really difficult to, in your head to say, well, they're talking about blood leads at 2, there was nothing. Is that because we're higher up on the concentration effect curve, or there really is nothing? So maybe sifting those out somehow and including plots would be helpful to the reader. I did notice that going back to some of the things Susan said, there is a lot of discussion with respect to the epidemiological studies in terms of potential bias and confounds that doesn't seem to get into the studies of animal toxicological studies. They seem to be cited as if whatever they said they found was in fact, what they found, which isn't always the case. So let me give you an example of something like a water maze, and I don't know who wrote this section or whatever. There can be lots of reasons why animals don't swim as fast to escape from the water. They might have motor deficits. Maybe they can't see. Maybe they can't smell. Are those particular confounds or potential sources of the effect that they see actually described by the author? Did they control for some of those things? They'll typically do something like measuring the swimming speed of an animal. I don't care how fast the animal swims. He needs to be Michael Phelps to stay in the water for life. So things like that. Novel object recognition, you cite data only from the second section, the second session of that, where you get a discrimination index. But I really want to know what happened before that. Was there any bias that was, were lead-treated animals staying on one side more than the other? Were they more active? So I didn't see those kinds of limitations discussed. They seem to be absent from some of the animal work, and it may be that authors don't even mention that they did any of that or don't present that data, but by itself, that's a limitation. So those are my comments.
Thank you. So next up is Howard.
Hi. Well, this section's amazing in terms of its comprehensiveness. A few other general comments. One is that the chapter kind of loses the reader in sort of discussing the high-level exposure effects and the low-level exposure effects. And I would say, as someone who is often in an environment where I'm trying to explain the literature, there's a lot of skepticism about, whether the low-level lead IQ cognitive effects are quote unquote real. And the animal literature basically says, well, this is what we found with blood levels less than 30. I wonder if the EPA could be a little bit more specific about, how about 10 to 15 or, something like that. And then also there's I think, a potential to use some of the in vitro and experimental systems to try to say how they might be relevant to really low-level effects, because there's a skepticism that low-level effects are real, and if the experimental literature can shed some insight onto why even at really low levels where there's no cytotoxicity, there's no this, that, and the other, you can still have interference with synaptogenesis or synaptic pruning or other important developmental mechanisms that preserve IQ and behavior. I think that'll be important. The other comment is that there's various observations about some studies that showed sex-specific effects, whether it's in females or males. This is another thing I hear in the sort of the general public sphere, which is that, oh, why should there be sex-specific effects? There must be some bias or confounding in the study. Well, in fact, there's actually a very good scientific reasons why sex-specific effects may occur, whether it's in the animal literature or in the epidemiology literature, and a sort of a general discussion of that could help the reader interpret those kinds of studies and understand their relevance to the overall question.
All right, that it? Yeah, thank you. Bruce?
Yes, thank you. I concur with the other commentators that the overall ISA report in this was excellent. So I had some comments that were, in some ways, I think they're trying to get at the same issues. So, for example, there was a lot of focus on here's the new studies, almost to the point where I felt overwhelmed by a lot of new studies, but not all of them were necessarily specific to trying to reach a conclusion, a determination of causality. And so I thought it would be useful to focus on perhaps even bringing in some of the older studies that weren't emphasized here to help make some of the key points. So, for example, this idea of low-level toxicity. There was the focus on the pooled analysis and the reanalysis by Crump, and that was great. But I think here I would have also wanted to see Howard's paper from 2006, where he looked at plasma, and so it showed the same kind of shape of the dose-response relationship. And Gail Wasserman, who did it with bone lead and IQ, and actually showed she did it with both bone lead and blood lead. And to the point that was made earlier, when they used bone lead, the association was significantly stronger than when they used blood lead. And then bringing in some of the academic literature, like Evan's work in Chicago, which had over 50,000 children. And you still see for academic outcomes across the continuum, that same dose-response relationship with steep decrements in either IQ or academic abilities beginning at the lowest measurable levels. And when you have 50,000 children, you know that many of those kids are at the very lowest levels. And so collectively, by bringing in that data And in fact, every study I've seen that looked at the shape of the dose response finds the same thing. It's so consistent. And so bringing in that data in addition to the new studies, I think could be really powerful because some people may not be aware of it. And so when they review this, like you bring in a consultant who reviews it and they make comments without knowing that literature. Well, if that's an important point, this idea of low effects at low levels or even the shape of the relationship, then that's worth bringing back and focusing on those specific studies that were used to reach that determination. Those are my comments. Thank you.
Thank you, Bruce. Brian, you're up next. Oops, I skipped, no.
So I was thinking that we'd get to lunch first. I have 2 minutes and I'm going to be keeping you all from lunch.
No,
I have about 45 minutes of comments right now.
Well,
Just kidding.
lunch hasn't even arrived yet, so.
Okay. Well, I had one question for you before I started. I was assigned to most of the health chapters, and I have some general comments about things that appeared in most of the health chapters. I hope I don't have to say that 7 or 8 times. So should I do those now as just a big picture set of concerns about the health chapters, or do you want me to be very specific about chapter 3 right now?
You know what? How about we focus on chapter 3 and then we maybe circle back to that maybe after lunch as a way of like, since we've got some momentum on, does that make sense? Or do you think that these general comments are really pertinent to chapter 3? So you want to bring them in now?
Yeah, I think they are.
Well, then go ahead.
Okay, so
And you can just remind us, you don't have to go over it 7 times today, please don't. But you could remind us occasionally that those comments pertain.
Okay, I'll try to do this, and I'll try to do this efficiently because some of these things have already been said. It's unclear to me whether you consider evidence from different human study designs differently. Best as I can tell, you kind of take evidence from human studies independent of their design, when in fact the evidence from a longitudinal study that included blood lead and bone lead, for example, is way better than the other kinds of studies that you can rely on. And so I'd like to see a bit more consideration about the strength of the study design. And I mean, Howard and I have done these studies over the last 20 years that were really, really hard to do. And they're sort of not distinguished from other studies. And I guess I'm a bit biased. I think that there's strong evidence from some of those studies. Particularly discuss what a longitudinal study does for you that other kinds of study designs do not. Because concerns about temporality and about confounding and other important threats to validity, I think, are much reduced in those kinds of studies. And I don't see a lot of emphasis on longitudinal designs. I'd also like to see a little bit more consideration given to hierarchy of human versus animal versus other kinds of evidence. It looked like there were some sections where the lack of animal evidence made your causal conclusions get ratcheted down to a category, when in fact, like if you look at IARC and how IARC decides things about carcinogens, I mean, human evidence is weighted more strongly than other kinds of evidence. One thing that's really, really relevant to Chapter 4, Susan has already mentioned this, is also present in Chapter 3, which is effect measure modification studies. And in the document, studies that evaluate effect modification, first of all, we don't know if it's pre-specified ideas about effect modification. Confounding is generally a nuisance that we'd like to try to get rid of, but effect modification is stuff that can teach us things about mechanism, and we can learn a lot about sort of the strength of our inferences. it's very unclear to me which of these were pre-specified analyses and which of these were just exploratory kinds of analyses, which I think is going to be very important to deciding. Howard already said some things about effect modification by sex, but in Chapter 4 in particular, but Chapter 3 also, effect modification studies are referred to as stratified analyses, interaction studies, effect modification, moderation, modified by. I think it'd be nice to have kind of an overview of what can be learned from effect measure modification and why stratification is done, and if stratification was done because of confounding, we should say that, but if it was because some risk factors are chained together and they cannot be separated, we should say that too. And it would be, I think, useful to have a formal consideration of effect modification and what can be learned from that. Regarding some of the things that I said for Chapter 2, I'd like to see a bit more formal consideration about the inferences that can be made with the different lead biomarkers. And sometimes studies find things, you know, they measure 3 or 4 lead biomarkers and find different things with each of them. And is that expected? And did the authors give an explanation for why that happened or not? I'd like to see a bit more consideration for exposures to lead across the life course and how things that happen in early life can get progressively worse in later life, and the implications of that are that some of these methodologic issues and that issue have the general effect of us underestimating the true population impacts of lead. And I think I'd like to see a general discussion about that. Throughout, I was a little bit distracted and confused why this is an update of a prior ISA, and yet some of the studies that are emphasized are before 2006, they're before 2013. And in some places, studies that were before 2013 were referred as recent studies. I think we should try to clean up a little bit of that language and explain why we're going back to older studies when this is primarily supposed to, I thought, be, I wasn't on a prior CASAC, but an update of a prior ISA. I think, okay, then in terms of the specific comments for this chapter, I think there's nothing more that I have to say at this time.
All right, great, thank you. Mark, we'll at least cover your comments before we stop.
I was going to say that now I am wishing Corey Ziegler was here, and then I wouldn't be the last one before lunch, but I guess it will be me. So first, let me just echo what others have said about this chapter. I mean, it's an immense amount of work that you've done, and it's tremendous. And I gave it to one of my students to make sure they have full background on all of this stuff. But so I also echo all the points that were already made. I will maybe highlight a couple, and then there's some very specific things that are in my comments that I won't go over. You can see there are a couple sections where there are some papers that I don't think I saw, which I think need to at least be referred to in the olfactory section and then in the ALS section. The ALS one in particular, there were 3 that I think I didn't see, and one of them was looking at blood metals, lead being one of them. But again, to Brian's point about the different study designs, which I really also want to echo, I think it's very important to keep those distinctions in there. One of the ALS studies is somewhat problematic because the blood was collected after disease in a case control, so that's an issue. The 2 others were occupational, so I know you tend to prefer the environmental ones, but given the occupational nature and the use of job exposure matrices, they have this advantage that they get around some of the reverse causation issues. So I think putting that in context is worth getting in there. As somewhat more general things, and I'll get back to it in Appendix 9 later, but I do agree also with Susan's point about sort of sample size, keeping some eye on that. To the question of interactions too, I also completely agree what's been said already with effect modification and interactions. One of the things I just want to point out, because felt like this might have occurred sometimes, that if things get sort of downgraded because they weren't looking for interactions, I just want to make sure that it's clear that I think the most likely scenario, if an interaction is not looked for and the result is given without that, is that you would be probably underestimating the overall effect, at least in the susceptible group. So it shouldn't be used as sort of a downgrading effect. I think it would only make it harder to have seen something if there was an interaction going on there. And then the last sort of main point that applies to Appendix 3 is, again, to reiterate and focus on what Debbie was saying about the sort of causal consideration. As a kind of general thing, I too sort of felt like, I think I agree with most of your final considerations on this. I think I wanted a little bit more text about what you were what was really driving that, right? And part of that is, which were the stronger study designs, that they're prospective longitudinal, maybe there's sort of confirmatory evidence in case control studies that have weaknesses but support the consideration, and how heavily did animal versus human weigh in. I think I just wanted a little more text where you made the final consideration about what was really driving it in that particular case. So I think that's all from me now.
Thank you. Are there anybody want to weigh in about this while we have momentum on this appendix? Or is everybody too hungry to? We can come back to it after lunch too. Go ahead, Mark.
I did realize one other point I had in my comments before is that I don't know whether this is the time, but I think the causal determination for neurodegenerative diseases is being done as a bulk, as just any of them. And I think it's worth a discussion of whether they should be separate or treated as a group. I mean, they are certainly different mechanistically, so at some point I think it should be separate.
Okay, anything else anybody want to bring up before lunch? So we have an hour for lunch, and we'll ask the timer. I'm assuming our food is somewhere nearby. We'll find out. We'll have the timer on so that we can be reminded. So that'd be about 10 after 1. And see you and Howie and Bruce in an hour.
The bar, so you can just go to the bar and you can pay for it there. And then you can bring it back here if you want. You can leave your laptops and stuff here. We'll have people in here. We'll see you in an hour, Bruce and Howard.
All right, welcome back. Encourage people to gather back at their seats. So what I thought we would do is we'll revisit, see if we have any further discussion about Appendix 3, and then we'll move on to the next item on the agenda. But before we do that, I thought it would be worth having a little bit of a discussion about how we're going to write this up. And Susan and I had a nice conversation right before we left for lunch where we thought that, particularly the way the charge questions are structured and the way things have come out, particularly some of Brian's comments earlier, but other people's touched on this as well, that it makes sense for us to write up like overarching considerations for all the health appendices. And so that's charge questions 3A, 3B, and 3C. And so there is a number of cross-cutting comments that have already been made. And so what we'll do is, in response to the charge questions, we'll address that across the board, and then we will address specific details for any of the appendices. We've only assigned, I guess, 3 of them separately, 3, 4, and 9, but if there's anything that emerges for the other 5 to 8 and 10, then we can also call those out separately as well. So I think that's how we'll structure our report. And then separately, George Allen is the lead discussant on the integrative synthesis, and he's struggling with the fact that in order to really know whether the integrated synthesis did a good job, he needed to read the entire report, which was a little bit too much. And so what I would ask people, and maybe particularly the lead discussants on each of the second, not just the lead, but the group of you, is if you could think about and maybe tonight look at the integrated synthesis with respect to the area that you are expert in, and just see if there's anything content-wise in the integrated synthesis that should be brought into that summary. So hopefully that's not a big lift, but since you've read the appendix in detail, that will help the lead discussants of the integrated synthesis make meaningful comments about the content and not just the structure and the form of it. Okay, so any questions or comments about any of that? Okay, let's circle back to Appendix 3. Susan, did you have something that you wanted to lead us out with?
Yeah, sure, thank you. I think in the previous iteration of our discussions of this appendix, I was mostly focused on the first charged question, which is the degree to which the appendix describes and appropriately interprets strengths and limitations of the various health studies. But I know our discussion touched on causality and other issues. I did have a couple of comments about the third charge question, which has to do with the extent to which the appendix causal determinations appropriately reflect the strengths and weaknesses of the reviewed literature. And there's a little bit of overlap with the first charge question, but not complete. So I think there are some issues with the causality determination for this appendix that I think could be clearer, and one of them is, and I think you've addressed it a little bit, but how do you consider, within a particular category of outcomes, how do you consider the different measures that contribute to that outcome? And I know you said that you sort of look at, if you have a particularly strong outcome in the epi literature and others are weak, that doesn't preclude causality, and conversely, if you have a particularly weak measure in a particular, or for particularly weak association with the particular measure, that doesn't preclude, that also doesn't preclude causality. But I think that it seems to me that within categories, there are some outcomes that may be functionally important, more important than others, or more important from a public health perspective. And maybe this isn't part of the approach to causality, but that thinking about how to prioritize the different measures that contribute to a different outcome would be helpful. Because I do think some are more important than others, and therefore the strength of evidence in support of a particular outcome may be more important in the causality determination than another. So with that sort of in mind, I sort of think that the internalizing behavior analysis in kids, I wasn't sure I understood why that was considered likely causal as opposed to causal, since there have been some recent really strong studies. And I think some of the other readers of this section had questions about some of the causality determinations that may be worth talking about. And I mean, the other thing that came up as well is it didn't seem like the mixtures studies, the studies that look at exposure mixtures, including lead, or that looked at effect modification, didn't seem to be integrated into the causality determination, or if they were, it wasn't clear to me how that was happening, and I think it would be helpful to understand better what role those studies play. And I think the other issue which has already been brought up is just that the discussion of cross-sectional versus longitudinal studies doesn't distinguish between the potential differences in robustness of those two designs and the different limitations of those two designs, and that certain study designs potentially should be given more weight in the causality determination than others, and that wasn't clear, I guess. And I thought that for some of the adult neurologic outcomes, I felt that the causal analysis was just a little harder to follow. None of those reached this level of being considered causal, and I couldn't tell if it was for lack of toxicologic research or because of inconsistencies between the tox and the epi, and having a more explicit matrix for demonstrating how a decision was made, I think would be helpful. It doesn't necessarily have to be the same, obviously, for each outcome, but sort of explaining to the reader why this decision was made in this case versus not, I think would be helpful, because it just was hard for me to follow what inputs were being used, and it seemed at times a little bit arbitrary. So, so I think those are my comments on the causality issues.
Mark.
Yeah, just to follow up on that, I agree, and I think Brian made this point in one of your comments too, so you can pick up, Brian, on this thread, but as an example, the adult cognitive function, it wasn't clear why that one was necessarily likely versus causal, and so I agree with your point, Brian, and maybe I'm okay with that, but I wasn't quite clear why one was, why it was going one way versus the other, so.
Does the EPA want to comment? Anybody from EPA want to comment?
Sure, thank you. Oh, it's a little loud. For cognitive effects in adults, sorry, try that again. Should I try this other? Is that better? Okay. So for cognitive effects in adults, we agree that the evidence, for us anyway, was sort of right on the border between likely and causal. Those two Rubin studies in particular were strong new evidence in support of a causal relationship. Some of the uncertainty came from inconsistency across lead biomarkers, particularly certain studies finding associations with both either patella or tibial lead across studies, and sort of trying to understand where those differences were coming from, as well as differences between the specific domains in the cognitive testing, where we were seeing associations that differed for the specific domains across the studies. So if there's input from CASAC on sort of how to interpret those differences, I think that would be helpful in clarifying our position on the causality determination.
Did you want to follow up?
I can follow up unless that's what Howard was going to do. I don't know, Howard, whether you were going to follow up on that or. I can quickly, let me follow up on one thing is that I think, getting at cognitive function is always a tricky thing, and there's definitely a lot of error involved. One way that we and others have often handled sort of different tests is to almost, to some degree, there is an element of wanting to see, is there an effect in certain domains? So absolutely, but to another extent, they can also be kind of viewed as another attempt at getting at some kind of general cognitive function and sort of treating it as a almost repeated measure across cognitive function. So we've done sometimes where we kind of consolidate into one measure. I guess I would just, yeah, I mean, I guess I would just say that, I mean, cognitive function it's a tricky, it is an inherently sort of variable thing to try and get at. So part of the differences may come from that. So anything that sort of tries to also consolidate and see if that gives a clear picture, I guess I would put more weight on.
Thank you. Howard, did you want to comment?
Yeah, actually, the section on lead and Parkinson's disease was interesting, but it reminded me of something that goes back to section 2, which is that one of the studies that it discussed was a study I actually wasn't aware of. It's a study that used a DNA methylation signature that our group had developed of cumulative lead exposure, bone lead, to do a reanalysis of data from 2 large case control studies showing that there's a much stronger relationship between lead and Parkinson's disease if you use that DNA signature of cumulative lead exposure. So I think it would behoove the EPA chapter on biomarkers to include a section on epigenetic signatures of exposure, which is an emerging science and a really fascinating and promising area for how we might actually retrospectively assess exposures that haven't been measured, particularly things like cumulative exposure.
Thank you. Any other comments? Should we go around to Chapter 3 panelists again? I don't know how much people covered all 3 of the charge questions in their comments, or whether you might want to elaborate on any other points like Susan did. So I'll just check in. Debbie, do you have anything more you want to say about Chapter 3?
Only that I'll go back to what I said for Chapter 2, and I think it's important to include in there, in some respects, to give more emphasis to the inhalation studies, because you do have lead going directly into the brain, bypassing the blood-brain barrier. I know that evidence is very limited to toxicological studies, but it is a different ballgame, and it's not reflected in the blood lead necessarily. So more thoughts for the future to some extent. So next time we're back here, we'll be thinking about those things.
Okay, thank you. And Howard, did you want to say anything else? Nope. Bruce, anything else?
No,
Nope.
thank you.
Brian?
My only other comments about 3B and 3C was that I agree that the causality determination for cognitive function in adults should be causal. And the way it was written, you basically said you were really close the last time, and then you said there were a bunch of new studies came out, they've been consistent, and then you came out with the same as the last time. And now you're concerned about, looking for specificity in lead's effects on cognitive domains is a big ask, I think. And cognitive domains are highly intercorrelated, but there are other aspects of health that can affect your function on a reaction time device versus, the Stroop test, which requires better vision. And so there's all sorts of things that could affect your performance across domains. And I don't know that the expectation that we look for consistency in domains across studies is a reasonable one. You could certainly write about that in there and talk about what you might expect.
All right, thank you. Mark, you anything else? No, that's it. So anybody else have any comments about Appendix 3? And, oh, Susan.
Yeah, it's sort of in follow-up to the earlier discussion, I think, in analogy to cognitive domains, I think the likelihood of there being coherence across different lead biomarkers is very low. In other words, I don't think we're ever going to be in a state of the art where observational or epidemiologic research is going to see the same associations with every possible lead biomarker. And I think in that setting, it's really important to think about what are the critical exposure windows for a given outcome and which biomarkers are better at measuring those windows. And I think that type of analysis was less prominent in this appendix than I think would be helpful to have.
Okay, thank you. Yeah, Chris.
So Susan started the whole discussion of this chapter with a comment about the IQ being a difficult, if that's the right word, metric. I think it's indisputable at this point, you know, the basis of that comment. And at the same time, she also, I think, acknowledged the difficulty in taking long-term data that largely relies on that as a metric and building a new structure. So I guess I wonder from the folks at EPA, over the course of the last 5, 8, 10, 12 years, have you done some background work to think about what alternative markers or metrics there might be that either in this review or maybe the next review would be able to satisfactorily replace IQ as a metric for this purpose?
Yeah, I think it's been a consideration, but to be honest, it would be helpful if you all would weigh in on that. There's academic achievement, there's other measures.
Susan.
Yeah, so, I mean, I think unfortunately academic achievement can have some of the same problems as full-scale IQ, but I'm part of the ECHO, the Environmental Influences on Child Health Outcomes Consortium, and we've started trying to look at domain-specific measures and measures that, in theory, reflect less acquired knowledge. So, for example, verbal intelligence is very dependent on environmental and acquired information, whereas a lot of nonverbal intelligence tasks are not. And so most IQ tests have multiple components that are used to then give you an IQ. And so we've tried to focus on those components and use priors for which components we thought would be most sensitive to a particular exposure factor and which components are the least biased. You know, that requires a frame shift in the literature in terms of how people do this, which I realize is way out of EPA's jurisdiction, but there are, I think, people trying to do that work, and some of the work coming out of ECHO will reflect that. But I think it is a challenge to know how to replace IQ going forward.
Yeah, Bruce, thank you.
Yeah, just to follow up on this thread, I think this is a process. It probably will take several years, maybe a decade or two, and I'm not sure we'll ever necessarily want to get rid of IQ or whatever next generation measures are become available, because it's so useful in the sense of all the evidence being able to predict future outcomes. Which isn't to say we couldn't augment it, we couldn't, and in fact, many studies now are reporting on the subtests of the full-scale IQ, whereas in the past they tended to just focus on full-scale IQ. So I think there's ways that we can present the subtests. Those provide some challenges, but nothing particularly hard. Just you take up more space, people will be critical because of multiple comparisons when they probably shouldn't be, but you know, those are easily overcome. But I think the idea of trying to replace it within the next 3 or 4 years doesn't make a lot of sense, but maybe thinking about measures that could be integrated so that we can continue to take full advantage of the full literature and search for new measures that might either augment or even ultimately replace. But it just offers so much data despite some of the concerns. But even within, like in our Mongolia study, very homogeneous population, and still it can be quite useful. And we are not worried about cultural bias or other things in that particular cohort. So we know it has some value, and so I wouldn't want to get rid of it too quickly, but also support the idea of looking for ways to augment it.
Thank you. Perry? Any further discussion on this point then? Looks like we're ready to move on to your new point.
My point in regards to the Appendix 3 is that currently you have crime lumped in with externalizing behaviors. And I can see why that was done in the past. But I think it's time to put this in a separate category at this stage, given the growth in the literature around this topic. And also given that we're looking at various life stages, whereas the externalizing behavior has been focused more on children, but now we're talking about adult crime and looking retrospectively at blood lead levels and other biological markers of exposure. So my one comment on that was that it would probably be best to look at that as a separate category going forward.
Okay, thank you. Anything else about the nervous system effects? So Susan, as the lead author for this appendix, sort of distinct from the overarching, do you feel like you have what you need to draft something?
Yeah, I think so. I have one point of clarification for the causality determination for adult cognitive stuff. What was I sort of not sure how Mark's question was resolved, or if it was resolved. You had a question about whether the causality determination was underestimating it or something.
Yeah, and I guess I would side with Brian. I mean, Brian's point was that he felt like it maybe should rise to causal given how close it was before, and you only presented more evidence that it moves there. I guess I would just say I would probably second Brian's.
Okay.
Okay, and any questions from EPA on this?
Yeah, I think we just have a few that we want to circle back on. For the issue of full-scale IQ, if it's possible in your individual comments to discuss if there are any references that discuss the implications of the bias in terms of when we are, because we're sort of limited to what's in the research. So if we could expand our discussion a little bit about what those implications are, that would be, I think, really helpful to us. Dr. Cork, you also mentioned internalizing behavior, and we were wondering if you sort of thought we emphasized the limitations of those studies, and that's sort of the disconnect between the likely causal and causal for that.
Yeah, and I thought some of the newer studies were pretty strong. So I think it's back to, how do you prioritize discordant information? And do you prioritize it based on the study design and what's more robust, or you just kind of are doing a balanced numbers that are associated? I know that's not really what you're doing, but it's just hard to figure out how you prioritize that information.
Yeah, I think we can certainly do a better effort to highlight those, what we're weighing. And then I had one last follow-up to Dr. Schwartz. You had a question about the older studies that were included. So generally we're building on the causality determinations from the 2013 ISA, so we like to bring forward some of the key studies, and that's sort of how we decide which older studies to include in our write-ups. Also the studies prior to 2013 that we cite as recent references, the literature cutoff date for the last ISA was 2011. So there are some studies that were published after 2011, but before 2013, that would be considered recent because they were not evaluated in the 2013 ISA. So just wanted to clarify that point.
Thank you. And did you want to follow up, Brian?
I want to pick a word that's more interpretable. Or define your use of recent up earlier in the document and say, we'll use the word recent to mean old but not used before.
And I'd like to have us to have a little bit of a conversation about. It sounds like EPA is already trying to do that, sort of bring forward the older studies that are particularly important for the causal determinations and the current conclusions. I know this came up in our recent ozone review where we focused a lot on a CORIC study that wasn't actually emphasized at all in the policy assessment, but that we thought had really important implications for the policy. And I guess I just want to make sure that the panel weighs in and that we're clear on how EPA is approaching the older literature, because I think with the volume of literature, it can be really easy to start losing things, or obviously you don't want to bring everything forward because it's just too much. And so maybe we could just have a conversation about like a little bit more clarity from you about how you make those decisions, and then whether we need to give any more advice on that. And so I see Bruce has his hand up. Would EPA like to comment first, or should I ask Bruce to weigh in first?
Yeah, we can maybe let Bruce weigh in and then we'll answer that question more broadly.
Okay, go ahead, Bruce.
Okay, thank you. So I had a couple thoughts. One is, as we're providing recommendations to EPA, if we can find ways to help prioritize them, because it's a lot of stuff. And the second part is how the EPA brings studies from the past, even before the 2011 in this case, to the present ISA or the future ones. And I do think one way to do that is to say that you're going to prioritize those endpoints that you've identified as being causally deterministic, right? So there are some areas you may want to focus on more than others. Another question you might be asking is, well, is it important what the shape of the dose response curve looks like? Absolutely. And so you may want to bring forward some of those studies, like I mentioned earlier, Wasserman and Hu and Evans, that all show that, and maybe even do a page or two on the studies that have looked at it and what they found and how consistent they are. So I think there are ways you can prioritize it rather than just feel like you've got to do everything for every one of the outcomes.
Thank you, that's helpful. Now I'll invite EPA to comment if you would like.
Sure, and I'll just say I introduce myself. I'm Scott Jenkins. I am giving Steve a break up here, so I manage the group that within Steve's division that develops the human health and exposure and dosimetry parts of ISAs. So obviously this issue is always a balancing act in terms of how much we bring forward from old ISAs versus how much we're focused on the newer literature. Typically what we try to do is, if there are studies from previous ISAs that are particularly informative, particularly strong studies, and remain so in the context of the newer evidence, we tend to bring those studies forward. Whereas if there are, in cases where the overall, looking at the evidence overall is driven largely by the newer evidence, we might do more citing back to old sections of the old ISAs without necessarily bringing forward a lot of the individual studies. So I think sort of building on kind of Evan's request of the panel to provide us information, I think if there are situations where you see older studies that are particularly informative and you think they need to be brought forward, by all means, please let us know those, if you can identify any of those sections or any particular studies, it would be really helpful for us in thinking about how to strike that balance. I don't know, Evan, if you want to.
All right, thank you. I think that's been a helpful conversation. Anything else? I think we're ready to move on to Appendix 4. Oh, Brisa, did you want to say something first? Go ahead.
I think it's a similar comment, but a little bit reversed. So there are some outcomes where prior ISAs have already made a causal determination. And in reviewing new literature, it's reviewed, it's summarized, but it's not always clear that the new studies necessarily have stronger designs to make you maybe walk back the prior determination. So it may be useful to, in summarizing the new literature, to add some context about whether the new studies that are now included, only reiterate or make, the prior conclusion stronger, or if, I guess I'm having trouble in reading some of the summaries to know whether what is being summarized is really adding something new to what was there before, especially because some of the newer studies are not necessarily stronger designs. So it's a little bit of the reverse from bringing back those strong studies. It's the relative importance of the newer studies.
Okay, thank you. Mark?
Just to build on that a little bit, because I agree, and I think it relates a little bit also to my comment about wanting a little bit more text about, what was driving whatever causal determination. And I mean, part of that may be that, as you say, in the last one, here's where we were, here is what we're focusing on the new stuff that either says, it all looks good and really doesn't change our determination, or it's a stronger design and is actually refuting what was there before, and that's why we're going down. So I just want to reiterate, I guess, my earlier point to build on that one, that a little bit of this is just being a little more specific about what's driving that causal determination, some of which may be the prior ISA said, we already came to this conclusion and this new data is no better and doesn't shift the needle at all, and so we're staying here, but just a little bit more precision on what's driving it.
Thank you. That's helpful articulation, something we want to bring forward into our overarching comments, I think. So I think we're ready to move to Appendix 4. And so there was a specific charge question, and of course, any of the overarching charge questions for cardiovascular effects can also be addressed in response to this. And so our lead discussants are Brisa Sanchez, Brian Schwartz, and Bruce Lamphere. So are you ready to give us a summary, Brisa? Oh, wait. Oh, sorry. Thank you. Before we launch into the panel, EPA is going to give us a summary. Thank you for reminding me.
Yeah, thank you. This should be a little bit quicker, and you can go ahead and go to the next slide. I'm actually going to pull these up because my eyesight is not that good to see the small screen. Okay, so really I just wanted to emphasize a change in how we classify the causality determinations for this ISA. So in 2013, we had 4 causality determinations for cardiovascular-related health outcomes, and these were based on the Surgeon General's report on smoking as a guideline. And those causality determinations included hypertension and increased blood pressure, subclinical atherosclerosis, coronary heart disease, and cerebrovascular disease. For this draft assessment, sort of recognizing that these are really interrelated endpoints, and in an effort to be more consistent with recent ISAs for other pollutants, we decided to combine those into one causality determination for which we've reached a causal relationship determination. So again, as I mentioned in my example, for nervous system effects, we're really trying to focus on the strongest lines of evidence that are driving that determination of a causal relationship. In this case, it's evidence, again, for increases in blood pressure and hypertension, as well as cardiovascular mortality. So in terms of the strength of the evidence, that sort of remains the same, but there's just more stronger evidence coming for cardiovascular effects that's sort of further supporting that causal relationship.
All right, thank you, and thank you for the reminder that I overlooked your summary. So go ahead.
Thank you. I think I would just want to reiterate the amount of work that has gone into this appendix as well, and great job on putting together so much literature. One of the recurrent themes that we are, keeps resurfacing in our conversation is the panel's desire to include more of the comparison or of strengths and limitations of the studies that are summarized at some context. And so the comments that I have are along these lines and provide some examples of that. So we'll, I guess, do again the question by question, 3A, 3B, so on. And so we'll start with 3A on the degree to which the appendix accurately describes and appropriately interprets the strengths and limitations of various health studies, including epidemiologic and animal toxicological studies. So here, one of the things that I found is that there is some distinction in the text about, this study was cross-sectional, this study was longitudinal. But even then, there is room to further emphasize or de-emphasize a particular study given the information of the study. So, for example, the Malmo study is quoted here as it's a longitudinal study. So we might all think it's a stronger study given its longitudinal design, but it's not always clear, or it could be added what was the link, the loss to follow-up of that study. So in that particular case, it was a study that did not find an association. And so it left me wondering whether part of the reason for that is just, some sort of systematic loss to follow-up. Similarly, there was another longitudinal study that is among very highly exposed workers, and the effect identified was really tiny. And the point that the effect was tiny was made, and but I think it would have also been useful to include the fact that because most of the associations are nonlinear, the fact that it's a study of exposed workers, it might be that association is already at the part of the curve, the exposure association curve, that it's already flattened out. And so that just gives a little bit of more context to the information being interpreted, being quoted. On a similar vein, there is often lack of clarity on whether the effect measure modification results that are shown are due to differential exposures or due to unmeasured confounders or stressors in the populations being studied. So, the idea that the association is different between one group versus another could be further contextualized in whether, yes, the effect was stronger in this population, which also was more highly exposed or less highly exposed, whatever the case might be. And so in that way, you can create some linkages to the earlier appendix on exposure differences between groups. Another part where again with effect modification, is that it is not always clear how or why a particular modifier was selected and whether the particular modifier is something that really needs to be highlighted. One particular case is the allostatic load. And the part that was troubling to me in that particular effect modifier is that summary measures such as allostatic load often include cardiovascular endpoints in it. And so it's, I am, even though it is a newer study, highlighting it just, you know, there's some reservation there on what the effect modifier is, and that it includes some circularity. There was a wealth of studies based on NHANES, which I think is especially important to include, given the importance of NHANES. And I think that there may be some need to explain how the different NHANES studies relate to one another, especially because sometimes, especially for effect modification results, there appear to be some contradictory results between studies. So there might be one study that says, yes, there was an effect modification by race ethnicity, and another one that didn't find or found an opposite association. But it seems to be that the reasons for that have to do with what factors were adjusted for or not adjusted for. And so just so that, you know, in terms of providing cohesion to the results, it may be useful to highlight among those NHANES studies potential reasons for differences in results when there are differences. Another related point in terms of evaluating the strength of the evidence or the strengths and limitations of the evidence is that is related to exposure variability. And I noted, and I really liked, that in most of the figures, there's many forest plots in this appendix, which I really liked. I thought that was great. And many times, the forest plots also include some summary of the exposure, which I thought was really, really great to have. And some of those exposures, as has already been pointed out, have, you know, the mean has been decreasing. And oftentimes what we see is the standard error, and not so much the variability in that particular population. I think the variability of the exposure is also good to point out, because as the exposures decrease, the average level exposure decreases, my intuition is that some of the variability is also decreasing. And with decreased variability, you have less power to detect associations. So it's not that that there's no longer an association at lower levels, but it's maybe harder to identify it. And so putting in context the reduced lead levels with the exposure variability, I think is also important in evaluating the strengths of particular studies. The last point I have is a bit of a nitpicking comment. The word has been used before today, and it deals with how studies are interpreted when they are cross-sectional versus longitudinal, and the use of words such as increasing the exposure was associated with an increase in the outcome versus higher exposure is associated with higher outcome. You know, I think that a lot of the way that you've summarized, it's not the EPA, but it's also sometimes those studies that you're summarizing are using those words in not the most rigorous way. But I think as you are compiling this information, maybe making those distinctions also helps to highlight the strengths and limitations of the particular study designs.
Thank you, and I just wanted to make a comment on one of your comments about the forest plots, and it builds on something Susan said. I'm noticing, like in figure 4-5, that it's helpful that you have the lead distribution, but you have the mean and the standard error, and then you need to know the sample size in order for the standard error. So it should be the standard deviation or the IQR. It shouldn't be the standard error. So that's actually pretty important. Okay, where are we? Next is Brian.
Another heroic chapter. I tell you, the ISA for lead has got to be the worst job ever. I have a little hesitation about what I'm going to say because the bottom line is it doesn't seem like it's going to matter very much, right? Because there's 4 questions. 4D, do I agree with a single causal determination? Yup, I do. 4C, do I agree with causal? Yup, I do. So then why do I have to give you all these details about giving you a lot of additional work to do? Well, I'll say it and you can decide. This chapter has a lot of the things that I said earlier on, and this is, I had no idea before reviewing this ISA how cardiovascular epidemiologists like effect modification so much. There are so many studies of effect modification, and I just want to be honest that so much effect modification is studied in the epidemiologic literature sort of post hoc. It's not pre-specified. And so there's a lot of possibility of chance findings. But the problem is that the way all these really subdivided studies are presented is, I actually looked at it. There's the word interaction, effect modification, moderation, modified, effect measure modification, subgroup analyses, and stratified analyses. And they're all the same kind of study, right? And so it makes it unclear to the reader about whether you're trying to make the same point about these studies or different points about these studies. Now, sometimes analysts will call it a stratified analysis because, you know, they're actually doing it for confounding because you can't separate. But most of the time when there's a stratified analysis in there, they have the p-value for the cross-product term. So they're evaluating effect measure modification. So my recommendation is that you just be a bit more formal about, you know, this literature is loaded with this stuff. And you can't always tell what's pre-specified, and thus there might be a higher likelihood of kind of false positive associations. And then I would just try to standardize the terms that you use and say, whereas the writers of these studies use 12 different words, we want to use one because it seems to be all the same thing. And you also see this similar problem with some of the figures. They're all doing the same thing, but some of the ways that they're described are all using different terms. Come back to something that Breeza said, allostatic load is a hot topic. It's a great idea. Not only are lead-related outcomes may be part of allostatic load, but if you want to use an effect modifier like allostatic load and perceived stress and other related ones, you should just put somewhere how they measured it, because this is one that's been measured a lot of different ways, and if it's measured the way Brisa is worried it's measured, then it's a problem. And the study by Peters on perceived stress has similar potential problems. And then finally, there are some effect modifiers that have been evaluated that I would just like to hear something about why they evaluated it, like effect modification by BMI. Why did they do that? And it looks like they didn't report the main effect of BMI, and so effect modification by BMI, it just seemed a little bit incomplete. So I just wonder whether, just because the study is done, do you have to include it in the chapter? That's all I got.
Debbie.
I just want to respond to that. If they didn't, we'd be sitting here telling them that they forgot study X, and that would be the problem.
And so your advice is?
Put in the most important, prioritize. You can
down.
always put the ones that aren't in a table, right? But you don't have to incorporate all of that into the text.
It comes down to what we've said, many people have said multiple times, it's the kind of study quality. And we want to rely on the best studies and not necessarily rely very much on or even present the other studies.
All right, thank you. I think we're up to Bruce.
All right, thank you. So again, overall, an excellent job. I just had a couple comments. One is going to be a new study that won't be included, but I was so impressed by it, I'm going to share it. Using an electron microscope, a master's student in South Africa looked at the effect of various concentration of lead and other metals on endothelial cells. And beginning at the very lowest levels compared to the control, and the very lowest levels were 0.14 micrograms per liter. The second level were 4.1 microgram per liter, and the third 8.2 microgram per liter. So these are all well below 1 microgram per deciliter. And even at the first increase in blood lead, they saw blebs and tears in the endothelial cells. Now, this was, of course, a laboratory study. It was not in vivo. And by the third level, quite significant differences in interactions with other metals. And it might be a little bit premature to say, but it's easy to imagine that these tears are what set up the whole process for atherosclerosis. So this is by Van Strip, as I said, a master's student now who's moved to Canada, not working with me, but moved to Canada. And then I just wanted to suggest that there's a section here that needs a little bit more discussion because it's so important, both to emphasize that more work needs to be done. We need a lot more research in this area, but also to point out that we don't need to let it prevent us from developing policy. And that is page 462, lines 9 through 11. And I'll just read it. Notably, adult blood lead levels may be representative of contributions from both recent lead exposure and mobilization of legacy blood lead from bone. Mobilization of legacy lead from bone. Therefore, it remains unclear as to what extent either recent, past, or cumulative exposures contribute to the observed associations. So that's absolutely true, and it deserves to be said. At the same time, I think there's ways that you can use the existing literature to show that either with natural experiments, with a randomized controlled trial, with removal of lead from gasoline, within months to years, not decades to 100 years, but months to years, you see changes in hypertension. You see changes in cardiovascular events. So I think because that's such a critical statement, I think it just needs to be fleshed out a bit to help provide some context for how much of a limitation is it? And should it encourage us to do more research in this area? Absolutely. Should it prevent us from taking action? Absolutely not, because virtually all the studies, but a handful, have relied on blood lead, and it's been very useful in understanding the relationship of lead, cardiovascular disease mortality, hypertension. So it's clearly a valid biomarker. And yet, of course, it's true what you said. So I just think fleshing that out, because it's such an important point. And if the burden of disease is anywhere close to what we found and what some new studies are going to suggest, it's really important. And that's one of the reasons it's so important to get our heads around what's the exposure out there? What is airborne lead doing across the country? So that's the only comment I had.
Thank you. And you said that was page 4-62? Is that what you said?
That's correct. Lines 9 through 11.
I didn't find it on that page. Maybe. Anyway, maybe we can just check that.
I'll double check it, Leanne.
Let's see. So open it up to just questions, comments. Susan, and then Mark.
Yeah, I just have one comment on this section, and it's reiteration of a previous comment, but it has specifics here. So in describing longitudinal and cross-sectional studies, they're sort of lumped together. It's hard to tell what's considered more robust or more relevant. And I think in this setting, it's equally important as in the neural setting to think about what the critical exposure period is. So the literature is probably strongest in looking at blood pressure as compared to hypertension as an outcome. But I think that's because the time frame of exposure for those two outcomes may be slightly different. And blood pressure may be more susceptible to shorter-term exposures, whereas the hypertension literature is pretty robust when people use bone lead or a cumulative exposure measure, not when they use blood lead. So it doesn't mean that hypertension is not strongly associated with lead. It just means that the choice of the exposure biomarker in terms of the relevant exposure window is important. And so, I mean, I don't know this for sure, but I'm speculating that actually the hypertension literature is a little stronger than it sounds from the way it's summarized, because if you distinguish between studies that looked at an exposure window that was probably most relevant, those studies are quite robust. And so I think being able to do that will make the distinctions amongst these different measures that go into the cardiovascular effects easier to see.
Thank you. Mark?
Yeah, so I had a different point, but just to follow up on Susan's, and now I'm forgetting where this came up, but I noticed the same thing, and I think it's in Appendix 9, but it relates to what she's saying, is that there was a comment about some weakness related to difficulties with blood lead or something, but one of the issues that came up was this one, is that it's very important to pay attention to whether it's capturing an appropriate window. And importantly, there's a lot of places where there's references to how blood may reflect what's coming out of bone, which is true, but it certainly doesn't do that as well as bone. And so there's a lot more possibility that you're going to miss something with blood lead because it's not capturing that cumulative exposure nearly as well as the bone. So to echo Susan's point, we shouldn't look at an absence of an effect with blood lead as evidence that there isn't a lead effect. It may simply be not capturing the right exposure window. So that was just to follow up on that point. Very important point, this will come up for Appendix 9 too. So in this case, for the cardiovascular mortality, there are references made to my paper from 2009. That we had to correct because the model was dropping some things, and so it is probably not the correct article to cite. And this is a learning lesson for myself in how to reference papers, because we subsequently published a paper that dug into more of the issues of the problems with selection bias in these kinds of studies. So it may not get flagged as a cardiovascular paper, but in EHP in 2015, we basically redid this looking at the issues of selection bias. And it's that paper that really should be cited, and it's in fact table 2, I think model 4, after doing all the sort of corrections for selection bias that I think give the most representative effects of cardiovascular mortality there. And actually I don't remember whether this is in one, I can't remember whether it's in 9 or 4, but this paper is in part of a table and results are given from this paper, but those are really not correct, so it shouldn't be used.
And I've heard some connected points, and maybe Brissa wants to follow up on this, although it looked like you had a different point. This idea of treating the cross-sectional and longitudinal studies as though they are both similarly useful is one important point. But then the other point that I heard Brissa mention that it's also important is that an individual study may be potentially misleading in some kind of way. And Mark actually gave you a very specific example from his own work where he corrected it. And so there's the strength of the design itself inherently, and then there's on top of that the particular study and whether it actually gets at the question it's trying to get at. And of course that's a lot to figure out when you're reviewing the literature. But I think I'm hearing people make both of those points, and I think they're different but related points. And then Brissa, you were going to say something? You wanted to move on to the next charge question?
I was wondering if we were, yeah.
Unless anybody has further comments, I guess we'll, do you want to go further in this particular appendix, right? You want to yeah, okay. Back to you.
The next charge question is the panel's view on the integration of evidence from mechanistic studies to inform conclusions on biological plausibility. I personally did not have any specific comments on that question. I thought it was any specific recommendations, I thought it was well done.
And then Brian.
I agree.
And Bruce.
Nothing to add.
Okay. Well, back to you, Brisa.
The 3C is, to what extent do the causality determinations appropriately reflect the strengths and limitations of the evidence? Here, I have two points. One point is that it is not always clear how the effect measure modification results or studies play a role in causality determinations. So I'm not even sure exactly how to answer this charge question related to the effect measure modification studies, but you know, given what Brian mentioned earlier about how the effect measure modification studies are currently reported and whether they are strong or not, then so my question back to you, or the comment back to you, is to better integrate those, or maybe not, but be explicit about whether effect measure modification studies inform causality determinations and why or why not. And that's the only point I had on that.
Go ahead, Brian.
I agree. It takes your eye off the ball. To get a single causality determination for cardiovascular doesn't require that you look at any of the effect modification studies. Now, to the extent that some are biologically important and mechanistically informative, you should rely on them, but it illustrates the point of the confusion entered by all that other stuff.
Thank you. Bruce, anything you want to add?
Yeah, it's just a little bit coming at it a little differently, but I think there's a role here for looking at, let's call them more innovative study designs, natural experiment studies, a chelation study, a randomized controlled trial of chelation, changes over time in blood pressure, followed by changes in lead exposure. So I'm wondering if there couldn't be a narrative that brings in some of these novel study designs that helps. Well, there's another one, the NASCAR shifting away from their lead fuel and seeing a reduction in cardiovascular events in older people. I should just say over 65. And bringing in some of those different types of studies helps to give you more confidence in not so much in the size of the effect, but in the causality determination.
Thank you. Any other discussion? So now maybe we're on to the specific question in this appendix, Brisa?
The specific question is to comment on the current organization of the appendix and the decision to develop a single causality determination for cardiovascular effects. I thought the overall structure was well done, you know, with some of the comments that had already been made, but the structure itself I thought was good. And I think that single causality determination is okay to do. I think you explained the rationale for doing that and how intercorrelated the cardiovascular outcomes are. So I thought that it was appropriate.
Thank you. Brian?
I agree with the single causality determination.
And Bruce?
I do as well. It did leave a residual question for me, which I don't think needs to be answered in this document, but I think it's an important one. And that is, if, for example, you end up trying to look at the population attributable fraction for lead's impact on hypertension, and you calculate X, and then you look at the attributable fraction for lead's contribution to coronary heart disease, and you calculate something else. I don't quite know how that would be done, and if it's just all glommed together and treated as a single outcome, that would be my only caution or concern. But other than that, I agree with how it was done and the single causal determination.
All right, thank you. I think that's it for Appendix 4. Any other panelists want to weigh in, or questions from EPA? Perry, go ahead.
Yeah, I had one comment on the structure. I found it odd that the document broke down cardiovascular mortality from all-cause mortality and discussed it in two separate sections. I think that should be combined, given that one is a subset of the other. I thought that was pretty artificial. And I had one more point on that I think would strengthen this discussion about cardiovascular mortality, is that it could easily point to the large body of epidemiology linking blood pressure to mortality, as we know that lead is also associated with elevated blood pressure.
Okay, thank you. Any EPA have any clarification requests?
No, I don't think we have anything. That was really helpful. Thank you.
All right, are we ready? Oh, sorry, Bruce.
Yeah, I just wanted to respond to Perry's comment. When we published our paper, we looked at all-cause mortality separately from cardiovascular disease mortality, separately from coronary heart disease mortality. We even at one point looked at acute MI mortality separate from those others. We ultimately decided to leave them separate, even though they are subsets. And the first reason we did is because at the time, and I think still today, we were much more confident in the calculations for lead exposure and cardiovascular mortality and coronary heart disease mortality, given the body of literature that was already out there. And there's something to be said for that. By looking at the all-cause mortality, it might give us a better indication of the impact on all deaths. And there's something to be said for that, because we know, for example, we're not capturing the impact of lead exposure on chronic renal failure and mortality from that. At the same, anyway, so I think there is value to having both of them and making it clear. Even maybe in 10 years, we end up collapsing them. But for now, until we have a better sense of what is all that other death and under all-cause mortality, I think the strongest evidence really points to cardiovascular disease mortality.
Thank you. Perry, you want to follow up?
Yeah, just to clarify, I wasn't suggesting that it be dropped. I was just suggesting that the two chapters be combined together, where all-cause mortality is discussed, plus the section on cardiovascular mortality.
All right, so Bruce says thumbs up on that one. All right, Mark.
Just a quick comment on that. I mean, I think to your point, Bruce, I mean, this is maybe a comment for research in the future. Is I don't think any of the papers, I think the way you were describing that, Bruce, right, is that you had left them as subsets. So when you did mortality, you showed the results for mortality, but it was all mortality. You didn't take out cardiovascular, right? You weren't looking at non-cardiovascular total mortality.
We just looked at all-cause mortality, cardiovascular disease mortality, which of course is a subset, coronary heart disease mortality, simply because we thought the mechanistic evidence was stronger for the latter two, but we didn't want to lose sight of the fact that there could be greater mortality than just those two things.
Right, yeah, and we did the same in our paper, and I guess what I would say, though, is that, clearly there's a very strong cardiovascular component, and it might be nice in the future to actually just simply separate them out and say, is it entirely due to the cardiovascular part, or is there some signal with the other mortality? But I don't think that's not in the literature yet, so we just don't know that.
Okay, let's see. We have stamina to, we're going to have a break around 3. So let's move on to Appendix 9. This time I'm not going to forget EPA's introduction. Is there any changing of the guard at EPA? No? Okay.
Okay, so moving on now to Appendix 9, which some of that discussion just now sort of encapsulated the issue with total mortality. This appendix covers effects on other organ systems that weren't covered in the first 8 appendices. So these are health effects for which there is somewhat less evidence than the other outcomes. So we grouped them together in one appendix just so that we didn't have another 9 to add in. The main change in this assessment is the inclusion of the total mortality causality determination for which we deem there to be a causal relationship. As was just mentioned, the strongest evidence for this causal relationship does come from cardiovascular mortality, which is supported by also by the cardiovascular morbidity, which provides biological plausibility for a continuum of effects whereby lead exposure can lead to cardiovascular morbidity and then mortality. There are also these all-cause studies, as Dr. Lanfear mentioned, that are also showing a signal between lead and total mortality and all-cause mortality, such that we felt that the science was appropriate to lead to an overall total mortality causality determination. In terms of other lines of evidence contributing to that all-cause mortality signal, that's a little bit less established, and so there's uncertainty there, and we'd be interested to get feedback from the CASAC panel on that. Thank you.
All right, thank you. And we have 2 discussants assigned for this one, Mark and Howard. So Mark.
Okay, so, I mean, I guess there's a lot in this section. I think if, I would probably go through all 3 of these charge questions at once, I guess, and I guess, Howard, you can just follow up on that and then get into some specific things. I mean, for 3A, on the degree to which the appendix accurately describes and appropriately interprets strengths and limitations, overall throughout this, I actually thought, I mean, and again, let me start by saying, once again, an amazing job of pulling together a whole bunch of literature all over the place. And I thought actually that was done in general quite well, going through all that. I think these strengths and limitations were well described in there. So from my perspective, I thought that was well done. I think the integration of evidence from mechanistic to inform the conclusions on biological plausibility, I was okay with that as well. And the causality determinations appropriately reflecting strengths and limitations, generally okay on that. I guess the one place where I had some uncertainty, I suppose, was in the bone mineral density and osteoarthritis sections, with a lot of the epi being cross-sectional studies. And I don't remember what was there in the past ISA, I can't remember how you referred to that, but certainly the new stuff, I think it seemed largely cross-sectional. And those are 2 areas that are, because they were studies of blood lead, are particularly problematic with respect to reverse causation. So I wasn't sure whether the determination of the causality level was being driven more by the animal literature. So that was another place where I sort of wanted precision of is that where you're sort of leaning more heavily on that side of things. But other than that, I thought that it seemed appropriate what was done. There are the general comments too. Why don't I go over those, and then I guess Howard can chime in. So in some of these, I'll try and touch on them briefly, because some of them have been related to other things we've talked about. I mean, this issue, Susan raised the issue of tooth lead and the timing aspect. The discussion of cross-sectional studies and limitations come up, but I would also say that it's there's sort of shades of problems with that, and a cross-sectional study with blood lead is much more prone to this problem than bone lead, just because, especially if it's tibia and you're capturing the last 20 years or something, then it's not quite at the same level of problem as blood lead. So there's sort of shades of that, and maybe that's worth stating more explicitly. There were several times where this discussion, the issue was raised about blood lead levels that we don't actually, it's difficult to characterize the specific timing, duration, frequency, and level of lead that contributed to this. And that's certainly true and absolutely an issue. It felt sometimes like it was being contrasted with bone lead, and I guess I would say that bone lead is better if you're going after that cumulative average, but if there's some sort of particular pattern in there, bone lead isn't going to help with that either. So just to keep in mind. Yeah, this is another one that I guess maybe the statisticians can weigh in on. There were several places also where it was sort of discussed that, sample sizes were small, and the statement was made that that reduces statistical power as well as the likelihood that an observed result reflects a true effect. So absolutely it reduces statistical power. With a binary outcome, and Brissa and Leanne can correct me if I'm getting mistaken here, but with a binary outcome, I would also be worried that it raises this problem, because if you just made a mistake on one or two people, you can dramatically affect the effect estimate. On a continuous exposure, a continuous outcome, I'm not sure that's the case. And I think the lower power and uncertainty is reflected in the confidence limits that you get. And I don't think there's anything beyond that that would make you worry. Yeah, then there were a few places I have in my comments where I think this was a point that Susan brought up at one point too, the issues of confounding. There's discussion of confounders and control for confounders where it didn't appear to me that things really were confounders. It was like the idea of medication use, for thyroid problems or antidepressants or something, where that's not going to affect your lead level, right? So it's more like either it's a mediator because the lead led you to go on the meds and then that had some effect, or it's an effect modification where if you're on a med, you're not going to see the outcome because it's being suppressed or something like that. So just being a little careful about what's referred to as a confounder versus something else. This is, I guess, a sort of minor point, but it probably comes up in other places as well, but I did notice it in many places in Appendix 9 where there's sort of language around lead levels, especially when it's like cross-sectional setting. The language of the effect and the exposure is that of increasing lead and decreasing this or increasing effects, and that sort of to me has a connotation of within a person if you raise their level, as opposed to looking across people where someone has a higher level than someone else, and just being a little careful. That sort of implies a longitudinal type thing that isn't really there. Let's see, yeah, then I mentioned the osteoarthritis, the bone lead. I mean, I think those studies are particularly problematic, as I said, for reverse causation, so we need to be a little careful there. And then the last specific point, again, about overall mortality in both the Weisskopf 2009 and 2015 in EHP, we did do all-cause mortality. Again, the 2009 is really not the one to be looking at. I would look at the 2015 where we do have all-cause mortality, and it's again the sort of last model after we've tried to account for all the selection bias problems. So I think I'll leave it to Howard.
Go ahead, Howard.
This is a pretty wide spectrum of health outcomes to look at. I pretty much would second what Mark has said about some of the reservations regarding the bone health studies. But I do know that the toxicologic studies are actually pretty strong. I think Ed Puzas and company at the University of Rochester had a whole PO1 that was focused on bone health and published some really neat studies there. So even though reverse causality is a real issue when it comes to epidemiology, it really raises the importance of doing some sort of prospective of the lack of prospective studies that can give us better insight as to what the ultimate implications are for human health and bone health. There are a couple of endpoints that I was surprised were more studied. In the normative aging study, we published a study on blood and bone lead and cataracts in JAMA. This was quite a few years ago, back in 2009. And I was surprised that there haven't been more investigators have tried to look at this because, in fact, the lens of the eye is just so subject to oxidative damage that in some ways it's like a model for how you might look at pro-oxidant influences on the body. But that study wasn't even mentioned And cataracts is not mentioned as an outcome of interest in the EPA summary. Similarly, we had published a study on lead and dental caries, the number invading study, another outcome that is associated, for instance, with smoking. Again, probably because of the pro-oxidant effects on bone mineralization and dental mineralization. But that also has not been looked at in many other studies, but remains, given the commonplace nature of dental caries, as an outcome of interest. But other than that, I think that the EPA summary, looking at all these other outcomes, came to, I would say, supportable conclusions about the insufficiency of the evidence on a number of the different things. And I don't see why I would otherwise revise those conclusions.
Thank you. Open it up to anybody else who wants to weigh in about this section. Not seeing anybody. So I guess are we ready to, Susan?
Just one minor comment, but I think and I'm contradicting myself, but because I had said that it's important to think about what outcomes are the most meaningful, and there is a part of the section looking at hepatic disease that talks about serum markers of liver function that the levels vary with blood lead, but that they don't vary outside of the normal range, so that's of unclear clinical significance. So I'm sort of saying two things at once. I think it's important to look at the more significant outcomes, but I also think that changes in a dimensional measure that has a distribution in the population can still have implications for population health, even if they don't have implications for individual health. And so I wouldn't discount those measures entirely based on the fact that they're still within the so-called normal range for clinical purposes. I think they're still meaningful.
Thank you. Let's see, where are we in terms of time? Yeah, maybe we've covered quite a bit of ground on all of these with the specific chapters, and the next up is quite a few discussants assigned to appendices 5 through 8 and 10, and I imagine EPA has a summary of that. You do.
Actually, Leanne, before we go, sorry,
Sure.
It's Mark.
Oh,
over
sorry,
here.
did I miss you? I apologize.
Well, no, I was sort of flagging at the end because I had left the specific charge question to the end. I didn't cover that one because there is a specific one for Appendix 9 about keeping, I mean, I guess we sort of addressed it in cardiovascular by keeping mortality and cardiovascular separate. So I just wanted to make sure that got covered. I mean, I think I think I'm in agreement with Bruce. I think that's what Bruce was saying about that. I think it is worth actually saying something about overall mortality and about cardiovascular. But as Perry's point, I think your point was just where it should be and whether it should be in this section or the other one. And I guess I'm a little bit more agnostic on that. But I just wanted to make sure that that got in to the record. And I don't know if other people have specific thoughts on that specific charge question.
Yeah, and thank you for reminding me too, because I didn't circle back to you and make sure you had the answers to all the things you needed to be the lead on. So that's an important, and I don't know if I asked you, Brisa, for the last one either. So make sure you got what you needed. Anybody else want to weigh in more about, I mean, it seems to be two aspects. It seems like we have consistency, or we have, I've not heard difference of point of view that we should, that we agree that EPA should have addressed and both total mortality and cardiovascular mortality. And what I'm a little less clear on is how strongly we agree with Perry that they should all be in one part of the document. But that's just an organizational detail, I guess. I don't know if EPA, I see you all smiling. I don't know if maybe you've wrestled with this already internally, and you can shed some light on what you think. Oh, Howard has his hand up. And true, I didn't give him a chance to speak first either.
I would actually be in favor of this being a separate kind of section, because if one takes a more holistic view of what lead's really doing to people, we tend to, like in medicine, consistent look at each organ system, right? But in fact, the organ systems have interrelationships among them as well. And particularly when we consider disparities and the whole movement to understanding health disparities between social strata, race, ethnicity, et cetera, understanding the full impact of an environmental exposure needs to consider all of these different things. Kidney disease combined with cardiac disease, et cetera, could have more of a effect that's not just additive. And so I would be in favor of thinking about a separate section, but that also tries to take a more holistic discussion of how an environmental toxicant like lead can, exert its ultimate influence on human mortality and well-being that cannot be gleaned by simply looking at each separate organ system.
Yeah, I guess, I mean, I think I agree with that too. And I also, as Howard was talking, was just thinking, I believe in things like even the PM ISA, right? I think it is separate. And so in sort of paralleling that, that would be another reason. I mean, I agree with Howard. I mean, I do think it is it's an important one. I think it may need to be on its own.
Okay, so keeping it organizationally separate and maybe adding some additional text about the broader holistic implications, I think what we heard for that. Bruce.
Yeah, maybe just to add to that, and I know there's a systematic review ongoing, and Perry mentioned a study that had been overlooked on firearm injuries in Milwaukee and lead exposure. It wouldn't surprise me if somebody looked at it, and I can't think, maybe there has been something done, but I can't pull it up now. If there was a way to look at large populations, would lead exposure lead to an increase in homicides? Very possibly. So I think there's other ways to do it. And so having it as a separate section, when you might bring in things like cardiovascular disease and kidney disease, which might be related, although distinct, but then you may have something that's really quite different. So that's really more of a future perspective, but I think there's lots of different ways that lead could cause mortality.
Okay, thank you. So now maybe we're ready. Do you have what you need now, Mark, as lead discussant? Okay, so now I think we're ready to move on to the rest of the appendices, health effects appendices, and I'll turn it over to EPA for whatever summary you want to give.
Do we have the slides for appendices 5 through 8 and 10? So these appendices cover renal effects, immune system effects, hematological effects, reproductive and developmental effects, and cancer. For the most part, these causality determinations remain stable from the 2013 ISA. There were two changes that I want to note. The first is for renal effects, which was the evidence was previously suggestive of a causal relationship. There was an emergence of new prospective studies that controlled for baseline liver function, epidemiologic studies that controlled for baseline liver function that really addressed the issue of potential reverse causality, which was a major hang-up in the 2013 ISA. And those are also supported by experimental animal studies at lower concentrations that also provide that temporality. The other change was for immune system effects for sensitization and allergic response. That causality determination was changed from likely to be causal to suggestive. There was just a few epidemiologic studies, prospective epidemiologic studies in the previous ISA that looked at asthma incidents and found associations, but these were actually pretty imprecise associations due to small sample size. There was an emergence of a few new studies prospective studies that looked at asthma and other atopic diseases, and they were consistently null, along with some cross-sectional studies that were also null. So there's still some animal evidence that supports a suggestive relationship, but really the strength of the epi evidence in the 2013 ISA was sort of negated by some of these newer studies.
All right, thank you for that summary. So we have a long list of people, starting with Susan Corrick, to respond to this. And yeah, I'll leave it to you individually how much you have specific points about these various appendices, or just affirming things that we've already said that are more broad-based.
Yeah, thank you. So I think I'm going to sort of address all three charge questions somewhat simultaneously, but I just have one big picture comment on Appendix 5. Can we just do it one appendix at a time? And that is, I know you said that in the previous ISA analysis, we were very concerned about reverse causation for renal effects. And there are now prospective studies that make that seem less likely. But my read was there's only a handful. And in one case, it was a relatively short follow-up period. Women were followed for 2 menstrual cycles after lead exposure assessment. So basically just a couple of months, which I think is hard to interpret in the context of renal function. And that the bulk of the new literature was still cross-sectional or case control studies. So I guess it sort of gets back to the sort of fundamental questions we've asked before, like how, with so few additional studies, that was sufficient to take this from a suggestive or to a causal relationship. I guess I was surprised that it, skipped 2 levels with just what I saw as only 1 or 2 new longitudinal studies. It seemed like the new cross-sectional data were also playing a role in that, and those have the same problem. One of the longitudinal studies was in a population with chronic kidney disease, and reverse causation is also a problem there. So when you get rid of the longitudinal studies that didn't have other issues, there was maybe only 1 new one. So I guess I just had a little problem with that. So I think that's my main comment, that sort of gets at how these studies were evaluated in terms of their relative strengths and limitations, and then how that was used to invoke a relatively big change in the causal determination.
So are you looking for EPA to give you an answer?
Yeah, I'm sort of asking you guys, I mean, maybe it's just a question of clarifying how it's written, but and it kind of gets back at stuff that others, Risa and others have said, that the quality of a longitudinal study is not always inherently better than a cross-sectional study, and understanding which were the most informative longitudinal studies in this particular body of literature is valuable. And then once you've done that, figuring out if that's sufficient to justify a big change in causality would be, sort of the order of operations that I didn't quite figure out from what I read.
Yeah, thanks for the comment. I think it's sort of 2 parts. It's one, that longitudinal epi evidence, and I think you mentioned that there are some issues with some of those studies that we could better highlight. I think the other sort of arm of that is these experimental animal studies at lower concentration that sort of give the biological plausibility that we would see this association in the epi studies, not caused by reverse causality.
Yeah, it's always tricky because, the experimental animal studies in bone health are really strong, but the epi studies are, I always find this hard to figure out because the epi studies are really weak. And I would sometimes argue that the epi studies are more important, but maybe that's my bias. others should chime in.
Any further discussion on this renal topic? Anybody else have, look at it carefully enough to weigh in?
I didn't, oh,
Go ahead, Bruce.
I didn't look at it carefully enough, and I was trying to scan quickly to find an article to see if it was included, but unfortunately, the first author's name is LIN, and so I'm finding thousands of those. And so the question is whether a study on chelation, environmental lead exposure and progression of chronic renal failure in patients without diabetes was included. And it's a particularly strong study because it's a randomized controlled trial. They show a reduction in blood lead and a prevention of progression to chronic renal failure, which is pretty strong. But I don't know that it's in there. I couldn't find it quickly, but it's something worth bringing into the mix.
And it sounds like if any of us have some bandwidth over the next few hours to look at this a little more carefully, this might be something that we might look at as a panel and think about a little bit more. And there is also, just so we all know, I mean, we need to deliberate in public, but if we develop thoughts after this meeting, we can still deliberate in public when we finalize our report. So even if people don't have the bandwidth to look more carefully and circle back about this tomorrow, we can see if we have any more thoughts to weigh in about this as we're developing our report, and make sure we just air that in public at that time. So, Jim, you have your hand up.
Yeah, so I didn't review this chapter, but I guess my comment is, I wasn't clear if the recommendation was that it should not be causal, but it should be likely causal, and if so, I mean, I don't weigh in on either one because I didn't review this chapter, but that's something I think the CASAC needs to make a recommendation on, if they agree it should be causal or if it should be suggestive causal. So that's just something for CASAC to, that will need to go into the final letter.
Yeah, and I agree with you. This is an important point, and it also sounds like we collectively haven't looked at it carefully enough to, have, other than Susan asking the question and bringing it to our attention. I think, yeah, by our final letter, we do need to make a recommendation about whether we agree with this causal conclusion or not, particularly since it was a big change. So that's important. But I'm not going to try to get people to speak when they're not ready. So, are you done, or do you want to? You want?
For renal, I think that's good.
So, does anybody else want to speak about renal now?
I reviewed the chapter.
Okay, go ahead.
I agree with causal determination.
You agree with the causal determination. Do you have any further thoughts on the shift or the evidence that justified the shift?
I think that there are some uniquely designed studies of renal function that are, I think, higher quality evidence. And I think Bruce mentioned one, and I think that there were some older studies that also, I mean, before 2013, that also had a similar design. The idea of chelation for low to moderate lead levels and improvement of renal function over time. It's a powerful design.
Okay, thank you. Did anybody else that's listed, Debbie, Howard, Bruce, O'Brien, you just weighed in, or Mark, want to talk about renal effects anymore? Okay. Then Susan, is it back to you for one of the other outcomes? Do you want to address any others specifically?
Yeah, for immune system effects, I have a couple of comments and suggestions. I mean, this is another example of a health outcome, a health measure for which there's tremendous diversity of outcomes that try to characterize the immune system. And just like the nervous system, it's a complex organ system with a lot of different manifestations of its function. And so I think in the text, the ISA acknowledges that functional measures of immune system health are preferable to non-functional outcomes, but a lot of the studies that were used in assessing sort of causation were non-functional, like, unprovoked serum immunoglobulin levels or white blood cell populations. And I think, as we've talked about before, figuring out how to prioritize those different types of outcomes in terms of what should contribute the most to causation is valuable, and it wasn't exactly clear how that was being done or if that was being done. And in terms of the I guess the downgrading of sensitization and allergic responses, which includes asthma, I think, let me see just a second. I didn't quite follow the rationale for that. So the tox literature hasn't changed much between the current and the previous ISA. And the longitudinal studies are similar in terms of quality and quantity between the two ISAs. So, and I think that those longitudinal studies are strong and should play an important role in causal determination. So it wasn't clear to me if a lot of the change was being driven by cross-sectional assessments, and I'm not sure, especially for things like asthma, whether a cross-sectional blood lead is really capturing the relevant exposure period. And so I was a little concerned that the change in causality was based on studies that were not very robust, and that was an issue. And I'm sort of asking you at the EPA to respond a little bit, but also if others on the panel have looked more carefully at this section to get their input as well.
Looks like Debbie wants to say something first, and then we'll switch.
I actually had the same response. I was struggling trying to figure out how that rose to that level of causation. And, I'll go back to my overall comment about, having some paragraph that prioritizes. We decided this level of causality because of A, B, C would be really helpful. But I struggled with that one as well.
Yeah, so this is one, especially dating back to the 2013 ISA, if you read the causality determination, that really emphasized two prospective epidemiologic studies that looked at asthma incidence. And if you go back and actually look at those studies, these were really small sample size, like cases less than 10 maybe, or around 12, and really imprecise estimates. There are newer prospective studies that are also small sample sizes that are null. And so I think our sort of determination was that the epi was overstated in the 2013 ISA. And so for this determination, we relied a little bit more on the tox, but the downgrade was the result of sort of less emphasis on the epidemiologic studies. And I'll let my colleagues speak a little bit more to the tox evidence.
The tox evidence was limited to things like total serum IgE. We also had indications of lymph node cell proliferation, and then just unregulated inflammation. I think that evidence is reasonable for it being suggestive of causing an effect, but I wouldn't be comfortable considering it to be more strong than that. There's no evidence for a captination. There's no evidence of change in lung function. And there's no reported evidence that I could find anyway for whether or not light exposure causes an increase in antigen-specific IgE. I thought it was reasonable.
Go ahead.
Well, I think I was sort of opposite of Susan. I guess I kind of wondered how it rose to even suggestive at that point.
Well, I mean, I think recognizing that there's no like validated model for asthma, all of my experiences with, risk assessment as it relates to asthma has all been the same. We look at a constellation of effects in an animal model, and we try to take those pieces and, assemble them into a cogent argument. And again, I mean, exposure to lead causing an increase in lymph node cell proliferation, methods that are out there for assessing skin sensitization, for example, or respiratory sensitization, they start with whether or not there was lymph node cell proliferation. So it's consistent with that. And seeing an increase in immunoglobulin E, I mean, yes, if the animal had like a parasitic infection, it would complicate the interpretation of that data, but we have no evidence that the animal was affected by any kind of infection. But again, IgE is one of the hallmarks of allergic asthma. I agree there could be more evidence, but I think suggestive is reasonable.
Okay. Should we, or does anybody else want to weigh in about the immune system effects? We're getting close to a break. Susan, what do you think? Should we keep going? I mean, we could maybe finish this up, or is there, or not? I mean, there's no rush.
Yeah, can I have just a little break, because I feel like I need to get.
Yeah.
I didn't realize that so few people have looked at this section, so I'm feeling, I'm feeling a little bit, I was hoping to have a larger.
Yeah, I think we've had so many sections. Some people have looked at it pretty carefully, but I think maybe a lot of us haven't. So, yeah, so let's go ahead and take, what's on the agenda? Oh, a 15-minute break. 15-minute break. The timer will tell us, but about 10 after when we come back. Well, the upside of a longer break is we have more time to engage with our colleagues, and the downside is that it's hard to stop. So I encourage people to get back to their seats.
Okay, we're going to get started.
All right, Aaron's louder than I am. You want to whistle? No? Oh, you wish you could.
Okay, one thing I wanted to announce that tomorrow morning, starting at 8:30, we will have, it's not noted on the agenda, but we will have a period for additional clarifying comments from the public. So those members that are watching or listening on the phone, if you're interested in making a public comment tomorrow, please email me and let me know, and we'll give you a 3-minute slot to make additional clarifying comments to the CASAC.
Okay, so we are in the middle of all the other appendices that we read more or less well collectively. So I'm going to turn it back to Susan.
Thank you. So the next appendix is hematologic effects. And I don't have a lot of comments because I think historically this is sort of a poster child for lead's toxicity, where there's very well described mechanisms of implications for lead altering heme synthesis and downstream events related to red blood cell survival and function, as well as anemia in heavily exposed populations. So this is a well-established consequence of lead exposure, particularly at high levels. But it struck me that in the ISA, where studies are largely looking at non-occupationally exposed populations and largely cross-sectional designs, that most of the causation was motivated by the very strong toxicology data and strong historical epidemiologic evidence in heavily exposed populations. And I think that's appropriate, but hopefully I'm not misunderstanding how the more recent literature was incorporated. So that's really my only just sort of generic comment about the hematologic effect appendix. I don't know if others want to weigh in.
So I'll open it up to other lead discussants if there's anybody who wants to comment. Brian.
I agree with Susan's analysis. This is a chapter that has the features that I mentioned earlier, which is what Susan just said. If we just came to lead in the last year or two, we wouldn't know much about hematological effects because they happen at higher levels. So this is one of those areas where you're relying on a different sort of set of evidence that you said, than you've said. But I agree with the single causal determination, and I agree that it's causal, but based on occupational evidence from a long time ago.
All right, I'm not seeing any other lead discussants or other panelists that want to weigh in. Is that right? That's also Bruce and Howard. I assume you'll raise your hand if you want to speak. Okay. Susan, back to you for one or two more outcomes.
Yeah, so the next appendix is reproductive and developmental effects. And I have a number of comments about these appendices just because I think they're really important to get out there, and then I'm interested in others' thoughts. Again, in this appendix, it seemed like studies of reproductive and developmental outcomes that used bone lead as an exposure biomarker were categorized as cross-sectional, and the implication was that that had limitations. And as we've talked about before, because bone lead integrates long-term exposures, I think those studies don't strictly fall into the cross-sectional design and have better strengths than perhaps the way they're presented implies. When outcomes related to fetal loss during pregnancy were discussed, I think the upshot was that there was a fairly limited literature in this area, but I would argue that the study in which women seeking assisted reproductive technology treatment was actually a really powerful, and as Bruce would say, sort of novel design, because in that setting it's possible to look at early pregnancy losses, which are otherwise typically not ascertainable. And in that study, lead exposures were associated with the risk of spontaneous abortion before 12 weeks, which is important, and the lower risk of actually maintaining a pregnancy after ART intervention. So I think this actually contributes a lot of useful information because it's a very powerful study design that was not necessarily given the credit it deserved. And I think part of the reason it didn't get that credit is that, and this comes up for studies of men as well, that the ISA indicates that studies that are limited, that are focused on populations seeking fertility treatment have limitations because of poor generalizability, but also because of the potential for selection bias. And I would argue there is a generalizability issue, but I'm not sure I get the selection bias issue. So if it's selection bias would mean that people with infertility who seek treatment are more or less likely to be lead exposed than people with infertility who don't seek treatment. And I have a hard time accepting that that's likely. So I don't think it's a selection bias issue, it's a generalizability issue. So I think it's less of a threat to validity and robustness than it is an issue of generalizability, but I think it's an incredibly important and powerful study design, especially with pregnancy loss outcomes, which are extremely hard to study. And then for puberty-related outcomes in both boys and girls, I think that some of these outcomes are relatively strong, but as blood lead levels have declined, some of the associations, for example, with menarche in girls have been attenuated. And the rationale for that was provided by the ISA said something about potential, the attenuation may be more pronounced as exposure levels decline by confounding from factors such as body weight and adiposity. And I'm not sure body weight or adiposity are confounders of the lead-puberty relationship at all. They may be causal intermediates, but you would have to argue that lead is associated with somehow, in order to attenuate the association, lead would have to be associated with greater adiposity in girls, which then in turn would be associated with earlier, not later menarche. And again, at least in boys, that's definitely not the case. So I think that there's a little bit of a misplaced understanding of what's a confounder and what's not, and that in thinking about this literature, which I actually think is really important, the reproductive health stuff is very, very important part of lead's toxic profile. Giving the literature the appropriate context is valuable. So the other thing is that I found, again, as before, I'm finding the causality determination a little opaque, and I'm having a hard time understanding some of the basis for these determinations. So for example, for male reproductive function, which was deemed a causal relationship with lead, as far as I can tell, it's largely driven by the association of blood lead levels with semen quality, which is quite strong and robust. But the causal determination for female reproductive function is only given the level of suggestive. And I would argue that the findings related to female reproductive function related to earlier menopause are just as robust as the findings in men related to semen quality. And my question is that suggestive because somehow earlier menopause isn't considered as important an outcome as semen quality, or is there something about the literature I'm misunderstanding? Because earlier menopause has tremendous impact for downstream events, including cardiovascular disease risk, bone health. So it's a really important outcome. And I couldn't tell if there was potential bias involved in deciding which of those reproductive, why reproductive function in men had a very different causality determination than in women, if maybe I'm biased and thinking that the literature in women is stronger than it really is. But I do think there's a couple of really strong, good studies, and it's a very important outcome. So I'll stop there.
Thank you. Those were very helpful comments. Anyone else assigned or on the panel want to talk about the reproductive and developmental outcomes? Mark.
Yeah, I actually just want to agree with what Susan was saying and also reiterate that point. I mean, I also agree about the issue of selection bias. So there's nothing else I can add other than, yes, I think generalizability is the issue, but I don't think it's a selected group, and this is a common misperception. It's a selected group, but that doesn't mean it's biasing the health effect that we see. So it may not be generalizable, but it's a very powerful way to look at it in those people.
Bruce?
Yeah, so I went back and looked at the renal and agree with the causal determination, which is causal. I also confirmed that the Lynn study was not cited. There was reference to some kind of a randomized controlled trial in an earlier ISA, but it wasn't cited, and they said it wasn't blinded, but the Lynn study was blinded. So in any case, just wanted to catch up on that. I mostly focused on the outcomes in these areas that I either disagreed with or I wasn't sure I agreed with. And in this case, I think there's a lot more evidence about lead and pregnancy outcomes than what was suggested by the determination. I think similar perhaps to what Brisa was saying, and she said it brilliantly, in many cases in the past, we've failed to identify an association because everybody was too heavily exposed. That's what happened with Elwood and hypertension. I think some of the earlier studies looking at cognitive outcomes, like the Cleveland study, either found no association or shallow effects because everybody was above 5 or 10 microgram per deciliter, and you missed this nonlinear relationship. And my suspicion is that's the same thing that's happening with preterm birth. There's a couple studies now, there's several studies, and I shared them earlier on a call, but where we see increases in preterm birth in a relatively affluent population with a mean blood level of 6 microgram per liter, 0.6 microgram per deciliter, a 1 microgram per deciliter increase is associated with a 50% increase in preterm birth. And that was very consistent with the literature that we looked at, particularly focusing on longitudinal studies and particularly focusing on lower exposures, not the more heavy exposures that I would have reviewed 20 years ago. So I think one of the ways that we need to really be thoughtful about looking at the lead literature is in the future, not only looking at sex stratification, but also looking at populations with different ranges of exposure. And I'll share, I've got about a half dozen studies looking at lead in preterm birth. Once again, we've got the study, and it was cited in the ISA where there was a reduction in air lead from the NASCAR removal of leaded gasoline, and you see a significant reduction in preterm birth. So there's quite a bit of evidence out there, and I just found it hard to concur with the determination in the ISA for pregnancy outcomes.
So what determination would you recommend, Bruce? Do you have one?
Well, when I reviewed the literature preparing for a study last year, I was at the point of saying it's causal, along with, and I meant to say this too, along with preeclampsia. There's been now a number of studies I've been looking at for the last 8 to 10 years or so since we were working on it, and they're all very consistent. And so I guess it didn't feel like we had given pregnancy outcomes a fair chance here. So I would certainly say for preeclampsia, causal. For preterm birth, I'm certainly leaning towards causal as well.
All right, thank you. And it might be valuable, maybe Susan and I can step up if we need to maybe make a list of the ones where we are having a conversation about different conclusions than EPA's reached, and circle back to that tomorrow morning. This is probably one of the most important things we do in the ISA is weigh in on the causal determination. So I think the ones that, and everybody is welcome to contribute to that, of course. I'm only looking at Susan because she's the lead on way too much of the health stuff. So Yeah. So thank you for that. Anybody else want to weigh in on this reproductive and developmental piece? Mark? Oh, so you were.
That's all right. Yeah, actually, this is a bit of a question for Bruce because I didn't know about the stock car paper, and I'm really excited about it. I want to go back and get it and see the details. But my one question about it, because it's not, as far as I can tell, indicated here, at least in the part that I'm looking at, is I assume they just removed lead from gasoline in the NASCAR. We know that. I would, I guess, think off the top of my head that sort of average PM levels or things like that remained relatively consistent before and after removing the lead. So that's a very important point because assuming the other stuff stayed the same, I think this is incredibly strong causal data. And so to me, that would raise it pretty quickly into a much higher level if we could show that other stuff coming out of the tailpipe was not changing so much pre and post the lead removal. But that is a very strong natural experiment that I would put a lot of stock into, no pun intended there.
And I wonder, Bruce, if you have that paper handy, if you wouldn't send it to Aaron and maybe he could circulate it to the panel?
Absolutely. I'll send you the 3 or 4 paragraphs I've written on lead and preterm birth, which includes the study by Buey, which was cited in the ISA, but I'll send you that as well. Absolutely.
All right,
and just to reiterate, I mean, I would, in the description of it, I think making an explicit statement that they looked at other things we would expect coming out of tailpipes and that those stayed the same, that really ratchets up the lead application.
I don't think they did that, Mark, but they continued to have NASCAR races just without leaded fuel.
Sure. But anything that would, I mean, I guess I don't see any reason just removing lead would change other stuff. I don't know, but if there's any way you can comment on the likelihood of that would be relevant.
We may have other people in the room that are more knowledgeable about whether changing lead in gas would affect the emissions of an automobile, other emissions that might be able to weigh in on that as well. I'm looking at Judy, for instance, maybe George, or maybe a few other people. I don't know. I don't want to put you on the spot, but that would be useful, at least if we can opine on it, to be able to say something. I see Susan. Are you ready? You want to say more? Yeah. I won't wait. I won't ask you all to comment if you're not ready, but Susan's ready to. Howard first, I guess. Go ahead.
So this seems to be an example of an outcome for which there's a lot of really interesting recent research. But then when the evidence is weighed, there's uncertainty as to what weights to apply, et cetera. And it raises for me an issue I raised in our before. It's sort of a methodological question, which is the EPA had described its approach to quote unquote systematic review. And of course, meta-analysis is a part of that. Certainly the literature is so vast that it's impossible to always do systematic review and meta-analysis of every outcome, but particularly outcomes for which there's sort of borderline, you're still trying to figure out whether the evidence justifies a change in the declaration on causality. It seems like there's, I think I would want to see a more systematic approach to how this literature is viewed. And, that, of course, that's more work. But I think even if there isn't an opportunity to do it, I think there should be an acknowledgement that this might be an area ripe for systematic review and meta-analysis.
So that's a good comment, and something we could think about incorporating in our advice is that given the workload of the systematic review is to help EPA prioritize where they might put more emphasis on doing that. And you're basically recommending that places where the evidence might change the causal conclusions is where that would be where we would recommend putting more attention. Okay, Susan, I think we're back to you.
Yeah, I just had one question, and I'm embarrassed to ask, but I'm going to ask anyway. So both Brisa and Bruce have said that there's a supernormal dose response or concentration response of lead for a whole range of outcomes. And I guess I thought that was primarily seen for neurodevelopmental outcomes and IQ. I didn't think it had necessarily been the empiric observation for other health outcomes. So is that, I'm misunderstanding the literature? I thought that was relatively specific to some of the children's neurodevelopmental outcomes and not necessarily to other health outcomes.
The first study that I'm familiar with that showed that either decelerating dose response or superlinear relationship was lead and hypertension. That was with Joel Shorts in the 1980s. Then over 10 studies with lead and IQ or lead and academic abilities have found it. And all of the ones that I'm familiar that looked at it found it. We saw it again with lead and cardiovascular disease mortality, coronary heart disease mortality, I mean, it's related, of course. So those have been the three that I'm familiar with lead, but it's also apparent for PM 2.5 in mortality. It's also apparent for benzene and leukemia. It's also been found in a systematic review for asbestos and mesothelioma. And also, just so we don't get too focused on toxic chemicals, for cycling and injuries. The cycling injuries drop off dramatically as you start to increase the number of bikes on the road. So there's a number of areas where it's been identified, and because of that, and because in particular we're focused on lead, well, like with a study, I was in Bristol for a couple months, and Elwood had found a very shallow relationship with hypertension, but all the men in the Care Philly study had blood levels between 5 and 15. So it brings up the very point that Brisa talked about, is that if all your exposures are at the high end, and now all of a sudden we're starting to see greater effects, like with lead and IQ that happened, is it because of the nonlinear relationship and the slope? So I'm at a point of saying that, if you're looking at something continuously, and we do this in most of our literature, of course, is look to see whether there's a linear or nonlinear relationship.
Yeah, we do that too. We haven't consistently seen that depending on the outcome, so.
It's still not looked at as probably as much as it needs to be. But in any case, when I looked at the literature for preterm birth in particular, I was focused on low-level exposures. And there seems to be a lot more consistency there than for some of the studies, let's say 15, 20 years ago, 20, 30 years ago now. And so I suspect that part of the difference could be because of the range of lead exposure.
All right, now I have two hands up, Brisa and then Mark.
Thank you, Susan. I think that's a really good observation about, where do we find this nonlinear dose response. And in my comments, I was focused more on the cardiovascular effects, which are where the nonlinear associations are actually shown as one of the graphs. And I think that comment of nonlinear associations just applies more broadly when we consider also the different ranges of exposure and how exposure is distributed differentially across subgroups of the population, and how it's then again also important to consider differences in exposure when looking at effect modification. So I think my comment was a broader comment, more generally in interpreting the strengths and weaknesses of the studies reported, not meant to say that lead always has nonlinear effects for all outcomes.
Thank you. Mark?
Yeah, I just want to make a comment because some of the some of the studies go into the idea of so just looking at lead versus looking at lead in a mixture setting. And as an example, there's a description of the Project Viva study here where there is an association seen in a single metal model and the results are given. And then it said that there's no but they saw no association in a for lead in a mixtures model, which may well be the case, but it's very important to also I think give the actual result, because clearly when metal mixtures start to come in, there's going to be lots of correlation. So things will, confidence limits will blow up and may not cover, may now cover the null, but that may just be because you've got a lot of correlation. So it's sort of important to see, are you saying that, is it being said because truly the effect estimate is like 0? Or is it being said because the confidence limits have now crossed 1 and we don't count it? So it's just an important distinction when looking at the mixtures models that I think are becoming a little bit more prominent or common now.
Thank you. And I mean, in general, a pervasive problem in the literature is saying results are inconsistent just because some confidence intervals cover the null and some don't, which can be quite misleading. So anyway, let's see. Are we any further discussions on this outcome? All right. Susan, I think it's back to you.
So I think we're on the final health appendix, which is cancer. And Brian has some comments on this that I think will be helpful to talk about, but I was a little unclear again about the basis for the causal determination in general. There have been essentially no new PCOS relevant toxicology studies since 2013. There were weaknesses to the epidemiologic literature at that point related to cross-sectional design or ecologic design that didn't always have direct exposure biomarkers. And the newer literature is, again, a little different than some of the other studies we've looked at in the other appendices, because a lot of the literature's in occupationally exposed cohorts, and they don't necessarily have exposure biomarkers, again, related to other occupational exposures or smoking. So the human literature seems limited, but there's very, very strong tox literature. So I sort of made the assumption that this determination was following IARC's determination of lead as a probable class 2A human carcinogen based on strong animal but inconclusive human data. But maybe, and that's a slightly different approach than the weight of evidence approach that's been used for other health outcomes, but I think it's reasonable, and it would be problematic if the conclusions were a marked departure from what's been done by other agencies that are devoted to understanding cancer risk factors. So, I don't know, Brian, do you want to, or I'll let Leanne decide how we should do this.
Go ahead, Brian.
Yeah, so the single causal determination was for cancer incidence and mortality, which is very, very strong human evidence, right? But IARC calls this a 2A carcinogen, which means that there is insufficient human evidence. So I thought that those two conclusions were incompatible, and I was a little bit surprised. I mean, maybe you could come to a causal determination that lead was a carcinogen, but I'm not so sure we can say it's about cancer incidence and mortality.
Does EPA want to weigh in at all on this?
No, I think it's helpful feedback. I get the distinction in terms of, Dr. Cork, you said about it does have strong animal evidence, and it's not, our determination is not based on IARC. I think it falls in line with what they've decided based on strong animal evidence, and that's consistent with our conclusion in the 2013 ISA, which we're building on, and there really isn't too much new evidence to change it. But I certainly get your concern about how we're phrasing that causality determination.
And is this something we want to comment on, this apparent, is it, if it's real inconsistency in how the cancer causality determination is being reached versus other outcomes? Is that's something I heard Susan mention, and I don't know how much Brian alluded to that as well.
I like the way the chapter was organized, all these intermediate endpoints. I think cancer is a different beast, so I think that made sense. I don't have a problem with that. I just have a problem with the overall causal determination.
Thank you. Go ahead.
Yeah, I mean, I think it's just more a function. This is one where it's pretty apparent that this is driven by animal, not human data. And that's less the case for any of the other health outcomes. So, I mean, it's different in that regard, but I think that's notable, but it's appropriate given the nature of the particular outcome. So.
And Brisa, your flag's just up by, okay, just checking. Okay, yeah, Perry.
I just had a question. In 2013, did it say cancer and mortality, or was it just cancer at that point?
I can get back to you on that. I can get back to you on that in just a second.
All right, I think I'm going to open it up to any more input on the health appendices by anyone. And also, I guess EPA is doing a search to see what they can learn about, answer our question, but whether there's any request for clarification or anything from EPA as well. And while we're reflecting on that, I see we're surprisingly ahead on our agenda. I recommend that we at least try to cover the welfare effects today, and depending on the time, maybe we'll get to Appendix 12, but I'm thinking even if we scream through those other two things, we're not going to try to do the executive summary and integrative synthesis today. But we'll see how fast we go. So, Susan.
Yeah, this is a little duplicative of something you already said, but in terms of general comments, it strikes me that there's a fair amount of inconsistency in the document about how associations were identified as of interest. So in some sections, if the effect estimates looked prominent, even if the confidence intervals were wide or across the null, those associations were highlighted. And in other sections, if the confidence limits were imprecise, the effect estimates weren't even presented. And the potential for an interesting or relevant association was not considered. And so I feel like there was some inconsistency about the relative importance of patterns of findings versus statistical significance. And I appreciate that the document did not use p-values, which is great, but I do think there is something to be said for at least trying to be consistent about, what patterns of effects are relevant and how important are issues of imprecision or null confidence intervals to making those kinds of determinations, because it was highly variable throughout the different health appendices.
All right, thank you for that. Anything from EPA?
Yeah, I just wanted to circle back to the question about cancer, and it was just cancer in 2013, not cancer incidence and mortality.
So easier to draw conclusions based exclusively on the animal evidence. Yeah, so good point. All right. I'm thinking we'll give EPA a minute to, I imagine there will be different people sitting up front for the welfare effects. So I'll give EPA a minute to switch gears, and then they'll give us a summary of their work on Appendix 11. So you ready for your review? Go
Yes,
ahead.
we are. So my name is Jean-Jacques Dubois. I'm an ecologist at HEED at EPA, and I assisted Dr. Lasseter here, and I focused especially on the terrestrial aspect.
And I'm Meredith Lassiter. I am an ecologist as well. I'm an aquatic ecologist, and I'm also the co-lead on this ISA. So what I wanted to do is start off just really briefly going over the key points from the previous briefing. So the next slide. So for both the terrestrial and the freshwater biota, in most of the cases, the studies that we reviewed affirmed the conclusions in the 2013 ISA, and those were for the endpoints of physiological stress, hematological effects, neurobehavior, survival, growth, reproduction and development, and community and ecosystem effects. So there were no change in causality determinations for any of those endpoints. A few of the studies that were causal occurred at concentrations lower than the 2013 ISA, but again, no change in those causality determinations. Since the 2013 ISA, there was increased research in saltwater biota, and so those resulted in changes to 3 of the causality determinations. So for the saltwater vertebrates, based on evidence in fish, was previously inadequate, and now there was sufficient evidence for a suggestive of a causal relationship. For community and ecosystem level effects in saltwater biota, was previously inadequate and is currently suggestive of a causal relationship. And then finally, for saltwater invertebrate reproduction, in the 2013 ISA, that endpoint was likely to be causal, and now based on additional evidence and some embryo larval toxicity studies, some other evidence, that is now likely to be causal. And I did want to point out that for saltwater organisms, for many of the endpoints, there is still insufficient evidence for causality determinations. And then finally, in biota, the proportion of observed effects attributable to atmospheric lead is usually not known. So next slide. And this is the figure from the executive summary showing the causality determinations for the ecological effects. And this is organized by level of biological organization, so starting at the suborganism level, going up to the ecosystem level effects, and it's color-coded by the causality determination, like the ones that you've seen for health. So the darker gradient of color are the causal, and then we have the likely causal, and then the lighter green are the suggestive of a causal determination. And the 3 that have changed are indicated with the arrows. So that's all. Okay.
All right, thank you for that. So we have 2 assigned discussants for this Chapter 11, or Appendix 11, Bill Stubblefield and Chris Johnson. So I'll start with Bill.
Thank you. I will preface this by saying I was expecting to have a good night's sleep tonight and be fresh in the morning and be able to discuss this with you cognizantly. Both of us are at a disadvantage at this point. First, I want to know who wrote this and who pulled this all together, because you've heard all of our colleagues. You guys did an incredible job of pulling stuff together. The lit search is amazing, and considering the volume of new information that's out there, you pulled it all together in a remarkable fashion. So I give you kudos for that. I like the organization of it. I like the organization a lot, especially throughout, well, it's hard for me to split this section 11. The way the questions are written, it's like 11A and then terrestrial, freshwater, and saltwater, and it's the same questions over. So it makes it a little more difficult to respond. But In any case, I'll come back to a couple of things that as we move through, as Chris and I move through all of the questions. I really like the new organization based on biological complexity. I've been a fan of that for years and years. I've taught it in my class since day one. And I think it's really important. I'm glad to see it was included in there. I was a little confused about why some of what you did with some of the information as we move through the questions, because you cover so much, and it goes nowhere to some extent, because the parameters are not looked at typically when we evaluate potential environmental impacts, if that makes sense to you. Let's see what. So I also one other thing that I'm interested in. I'd love to have your comments back. There are a lot of parts of the agency who do similar kinds of reviews. For example, the aquatic side section of this is done by the Office of Water when they do their ambient water quality criteria. The eco SSLs were done, I assume, by ORD originally, and saltwater criteria are also done by the Office of Water. They cover a lot of the same information. They haven't done it in forever. The lead ambient water quality criteria is 1985 vintage, as I recall. The eco SSLs are like 205. And the one thing that you all did in this is you reached out and got the European data. So much of the research that has been generated over the last 20 years has come about as a result of the REACH regulations that were implemented in Europe and the requirements there for additional data, and the development of the efforts that have gone on in Canada and Australia and some of the others. And you guys did a really good job of pulling that information in and relying on it. The problem is I don't know what you do with it at the end, because a causal, this kind of gets into a sidebar, a causal relationship, if I remember going back to Branford Hill and the original methodology for evaluating causality, it is more associated with an endpoint. It's like, can exposure cause this? So, is that a causal, can this be a logical cause for what you have observed? But what you're ultimately trying to do at the end of the day in this effort is derive a air quality concentration that you have to address. And I don't see how you're easily getting from what's in the air to what's in the environment, especially when you consider it's one thing for humans to inhale lead out of the air, et cetera. But what happens in the environment is the lead enters the aquatic environment, speciation changes occur, effects on precipitation in the marine environment occur, it ends up in sediment, et cetera, et cetera. It is incredibly complex what happens. And I don't see that caught in this document. Maybe it's somewhere else that, because I focused on the section, Appendix 11. And so I would like to see some more of that, because you really have to move in away from causality evaluation into risk evaluation to be able to get to the issue. I also wanted to find out a little bit more information about, there's a discussion in there about cutoffs, literature cutoffs, and how those were done. And it wasn't clear to me, it says that there's a discussion in Appendix 12 for exactly how that was done, and I apologize that I didn't get through that. given the fact that this document is a couple hundred pages in and of itself. And so I'd like to know the basis for why the cutoffs were set, especially since some of those cutoffs seemed pretty close to what I go back in the literature and look at ambient water quality criteria and some of the more germane, depending upon the matrix you're talking about. So I will leave the introduction at that.
Chris?
Yeah, so I'll agree with Bill about the quality of not just this section, but actually the entire document. As I mentioned in my introductory remarks early this morning, this is the third time I've been associated with this process, and this ISA is much stronger than the one in the last review, and that one was probably 5 times as strong as the one that happened before that. So these are getting better and better in terms of not just the scope and amount of material in them, but also the quality, the quality of the writing, the quality of the organization. So well done there. As far as the introduction to Appendix 11 goes, I think the entire section has a good and balanced discussion of a bunch of concepts and models and approaches. I want to point out that the discussion of the biotic ligand models, BLMs, as well as multiple linear regression models is especially useful. I would have found it helpful to have just a couple of sentences that maybe indicate how each of those models might lead to different, not conclusions necessarily, but just different points of view. How do they reflect different points of view about about the processes? I don't know, do you say it leases, L-E-C-E-S? How do you guys pronounce it? Leases?
Leases.
Leases. The leases approach, this gets to one of the points Bill made. The leases approach to culling the literature, I think, is a fine approach, and the fact that it is parallel to the PICOS approach, makes sense internally within the document. But the exposure cutoffs for soil, which was 230 parts per million, milligrams per kilogram, and especially for water, 10 micrograms per liter, did seem quite low in relation to ambient concentrations. And I just wonder if there are some really quite relevant materials that may not have been included because of those cutoffs. There's an equation on page 1124 to calculate what's referred to as the final chronic value. I think that equation might be mangled. It doesn't actually lead to the calculation of anything called FCV. Maybe I'm just not understanding it well, but please take a look at that, clarify it, correct it if necessary. And then just finally, I think Bill mentioned the effectiveness of getting into the literature, especially the European literature. There's also a lot of literature in here that's from Asia and even a little bit, I think, from Australia and that part of the world. And that's great. And the fact that that literature has led to the confirmation of the conclusions of previous studies is really quite reassuring in the light of the fact that aside from areas near point sources of lead, there's really very little work going on in the United States at the ecosystem level, certainly, to look at lead effects. I think where you do see some, and I'll talk about some of this in response to the later charge questions, I think where you do see some work going on is work in which the whole field is growing fast, and people are looking at this as one part of a broad perspective. For example, ectomycorrhizal fungi and other kinds of plant associations. I mean, that field is growing very, very quickly, and so people are looking at things like lead, which is really interesting, really good, really valuable for us, but that sort of comprehensive ecosystem level look isn't unfortunately happening in the U.S. a lot right now.
All right, thank you. So this, we're just on 4A, I take it. Any other comments from any other panelists? All right, we'll go back to you, Bill, for however you want to handle. You want to do 4B, or you want to lump them together? You can turn on your microphone.
It's probably easier because of the way that it's organized in our responses.
Okay,
To
go ahead.
kind of follow through the questions.
Sure.
But I won't go through the reiteration of the question. It's like,
That's-
okay, we'll talk about terrestrial now.
Okay.
And so, with regard to terrestrial, my comments on that was that I thought it was an excellent summary of all of the new information that has been generated. I think that there are some additional models that may or may not have gotten picked up. There's a PNEC calculator, potential no effect concentration calculator that came out of Europe. I think the first author on that paper is Eric Smulders and Koenorts and those guys out of Belgium. And I know that model has taken into account some of the bioavailability parameters. So things like cation exchange capacity and pH, et cetera, are included in those. I think it's really good that you picked up on that you noted that information was there, but it's not clear to me what you've done with it, with regard to causality. Because if you think about, every soil is going to be different. And so if the question from a causality point of view is, if you have the right soil conditions, can you cause an adverse effect? Okay, I agree with causality, but there may very well be soils that don't, that the concentrations aren't high enough to cause an adverse effect. But we've not defined what those concentrations are, and so it makes it a little more difficult to follow how the bioavailability information is being picked up and used.
All right, thank you. Back to you, Chris.
This is a tennis match. Again, this section was really quite impressive. Couple things occurred to me as reading it. One is there's a discussion in several places about the effect of lead aging. And so, of course, lead is an atom. It's got so many nuclei, so many neutrons and protons and electrons. So it doesn't age, right? It's the material that it's associated with that ages. So the organic matter in soil, for example, the mineral surfaces that it might be bound to, et cetera. It's those things that age that is what's meant by that idea of lead aging. And at some level, it's a pity that this has crept into our literature generally, not this document in particular, but we're not going to fight that battle. But I think that it might be useful for perspective to make that point that, when we talk about lead aging, we're really talking about the material with which it's associated. I mentioned mycorrhizal fungi a few seconds ago, and I think the importance of certain types of mycorrhizal fungi in mediating the uptake of lead is a really important observation for us. And I mean, I think one of the things that's growing in that literature is just the recognition of, the degree to which mycorrhizal fungi not only symbiotically help plants to get nutrients and to be successful, but also that there's a protective element of that as well. And so that I thought was really a nice contribution. It's also encouraging to see more and more literature on the effects of lead on microbial community structure and function. Most of those studies, as you've pointed out in in the document don't really lead to firm conclusions about any sort of effects. And I think that probably reflects as much as anything the difficulty that the soil microbiology research community is having in terms of really honing and using these methods for fairly specific questions. And so you see a lot of studies in the literature in which they try to relate soil microbial community structure and function to all kinds of different things, and they often wind up being really unable to do that. It's a lot of suggestive stuff and things like that. So, I mean, it's a very complex ecosystem, the soil microbial community, and it's also confounded by the fact that soils themselves, especially in soil organic matter, have strands of DNA and other materials that make it kind of difficult to kind of conflate some of those measurements and conclusions. But nevertheless, I think it's great that we're getting more insight into those associations, and perhaps down the road we'll see some more interesting results from that. And so, all in all, the section, I think, my reading of the section anyway supports the notion that the causal determinations are, haven't really been changed. The ones that are strong remain strong. The ones that weren't as strong, I don't see a lot of support for upgrading those. So, thank you.
All right, thank you. Any other panelists want to weigh in? Go ahead, Bill.
I would add one thing. Chris, when you mentioned the aging thing, it popped into my mind. So what happens with aging is you get speciation changes in the metal, making it no longer bioavailable in the soils, and that basically comes from sediments. The question was raised, and I can't remember if it was in the soil section or the sediment section, about spiking and whether you can do spiking studies. And I raised the issue because of my knowledge of what we've been doing with sediments, and we've come up with ways to actually be able to do spiking studies. Actually, we didn't, USGS did. It was Besser and those guys at Columbia. But they, by incorporating, it's about a 70-day aging process for sediments, you can actually replicate and the kinds of results that we get from field studies. So it occurred to me that some of that work has been done by Eric Smolders and looking at aging of soils as well. And so in answer to the question, yes, we can do spiking studies, and they should be incorporated, provided the methodology included the aging process into the process. So that was all I was going to say.
Well, I think we'll stick with you and move on to freshwater.
I'm getting tired.
Do you want to break early and do the rest tomorrow?
Not at this point.
It's only 1 o'clock in the afternoon.
That's true, and I got up at 3 a.m. So with freshwater, again, same kudos. You all have pulled together an incredible amount of information, and there is an incredible amount of information that has come in. You go back and look at it since 2013. I go back and look at it since 1985 with the ambient water quality criteria, because that truly is the basis for all of that information. All of the work that Chris mentioned, the BLM, the MLR work that have been published, I honestly was happy to see the way that you pulled it together, because I'm constantly being asked by people, what's the reference for DeForest MLR paper? And it's like, I know where I can go look now. So, because it truly, it's useful. It's pulled together in a very nice, very useful fashion. There is something in there, though, that bothered me as I started reading more and more, and that was the fact that there's several lines in there which keyed something in my mind. It was the fact that you mentioned concentrations not being measured. And that made me go back and start thinking again, what criteria did you all use to include papers into the review? So normally, if I'm doing something like this, I would go back and look at, the first thing we do is a relevancy and reliability review of a paper to see whether it's even worthy of being included into the document. It's common, EPA does this, I know OPP does, has been for years. They always review the quality of a report or a paper before it comes in. And I know that the Office of Water has also worked on that, and they have, originally it was called, I think when Duluth was working on it, it was called Evistra, and it became, now it's incorporated as part of the ambient water quality review process. But in any case, there is a review, and what would happen is those papers would get rejected. I mean, they wouldn't even be included in the review because you have no measurement of the concentrations that that the critters were exposed to, and what the response was. So those would classically, the Europeans call it a Clemish review. So it would be a K1, K2, K3, K4. Anything below K2 doesn't get included in any of the evaluations. These would all fall into K3, K4 range. And so my question is, do you have such a review process? And if so, you should include it in the appendix and implement, to make people aware that these are high quality studies that have all been included. So that was that. Oh, so the document is extremely, I won't say complex. I'm looking for the word. It's got lots and lots of things in it that you're not going to use, that you never comment on. You've got I love the intro where you talk about the importance of the classic parameters that affect populations: survival, growth, reproduction. Those are the kinds of endpoints that are classically used for criteria production and the like. And then we come into the document, and I start seeing effects on physiological parameters, effects on neurological parameters, and I don't know what to do with that data. And you don't do anything with the data. You say, I mean, you include it, and there's multiple pages of discussion, but it's not incorporated. It doesn't go anywhere beyond that. And in the effort of, if you want to make the document more concise, I'd probably leave some of those things out, even though, an incredible amount of work went into it. There's no doubt about it. That's just as a suggestion. And I'll leave it at that.
So I wanted to follow up on a question because you said it differently, but you echoed it, something that Mark said earlier today, where he said, well, he gave the chapter to one of his students because it was so comprehensive and complete. And, people have been repeatedly saying today how nice it is. But then I guess the question I'm asking is, part of the purpose of this is an integrated science assessment, so why would EPA leave it out? 'Cause there could be a criticism that, that they're incomplete then, even if they don't do anything with it. So I don't know if, since you brought up that suggestion of maybe leaving some things out, and maybe part of it is to ask EPA their view on why they're including some of these things. But I guess I'd like us to reflect a little bit on some of this information that's maybe more complete than is followed up on. And it looks like Mark wants to say something too.
Yeah, I was just going to follow up on that point. I mean, so I guess I would also agree with you, Leanne. I'm not necessarily leaving it out, but I think an alternative, and I'm not sure, I didn't read this section, so I don't know exactly how they did it, that, I would be in favor for some if there are some collection of papers that are deemed really not worthy of stating that and saying, here are the ones we did go over these, but they didn't rise to the level of, quality, whatever the terminology wants to be for this, and therefore we're not going into detail on them, right? Something like that. I mean, that seems reasonable to me if it really is believed they're not up to snuff. But.
Although here I thought it was a different topic. It was more like a topic, not the content of the papers that you were, or maybe I didn't follow your argument, Bill.
Yeah, Mark said he would give it to his students. I say give this to the Office of Water. Not critically, it's just so good. You have pulled together information that they don't have since 1985. And it really is a very good review. Now, what would happen classically to the information that's not used in an AMIA water quality criteria document, it would fall under what's called Table 6, which is information that's not useful information, but not used for the purposes of deriving a criteria. And that's a lot of what you have in this, is when you don't reach a conclusion of causality, what you're really doing is saying, we don't know if it caused an effect to the microorganisms, or to the question of the example I gave in the text, I think was the bioturbation discussion in sediments. It's useful information and it's very, very helpful, but it's not germane to the task at hand. Does that answer your question?
Yeah, a little bit, and we can certainly circle back to EPA and ask their point of view too, but I see Phil has his flag up first.
Yeah, I'm just wondering, Bill, just listening to your both providing feedback and also trying to be constructive, if there's a different purpose here. In this case, some of the literature is if it supports a mechanism of action or helps explain why one outcome in one taxonomic group maybe is a little different than another. Maybe that is helpful, even if it's quantitatively, not what we're used to seeing in a derivation of an ambient water quality criteria. Maybe the context here, it's appropriate to have those.
You raise a good point, and I agree with you, and I think it is important because there are some things, this is not an ambient water quality criteria, but it's the same kind of process. You're ultimately, they're setting a standard for what is okay in water, what is protective. Here we're trying to set what's protective in air. And ultimately it's got to go through the process that you described earlier. It's risk assessment, kind of in reverse, but so you have to know what's causing an adverse, what kind of concentrations are causing adverse effect. The other half of that is what concentrations exist in the environment. And so you have to do, and the environment becomes more complex because what came out of a stacker was in the air ultimately goes into these other matrices, and the environment changes them. And you have to take that into account. So I think you're right. I don't want to leave out information that is helpful, but I think that information for which perhaps there isn't a causality, maybe that could be incorporated into a table or something of that nature to make it less dense text-wise and more readable, if that makes sense.
Or an appendix to the appendix?
Yeah.
That way you don't have to read it unless you are really interested in it.
You could read the summary, and because that's the take-home message at the end. I think we missed Chris. You didn't.
Yeah. Are you ready to speak now? Okay.
Just wanted that discussion to reach a fulsome conclusion. I guess my thoughts on that are that the studies that appear in this appendix, but it would be applicable to other appendices too, the studies that appear that don't seem at this point to support any particular line of reasoning or conclusion still support the process of building causal determinations over the course of 2 or 3 or 4 ISAs, assuming this process stays in place, you know, for that long. But so I wasn't too concerned about that at the appendix level. I was also asked to look at the integrative synthesis, and I think that is super important there, and I will have some comments tomorrow about that. So as far as the freshwater part of the appendix goes, I did one specific causal determination that I wanted to bring up was the one for neurobehavioral effects on aquatic invertebrates. And as I read that particular section, looking for the logic behind the conclusion that was made, I couldn't help but feel that, at least based on my reading, that that could have been justified as being upgraded to a causal effect from what is now, I think, well, it's the next one down. I can't remember the exact language. And so, I mean, I didn't go back to the original, to the studies that, you know, were part of that. So I think either a question of whether that ought to be revisited, or at the very least maybe to include some kind of language on where your thinking led to making that fall short of that causal determination. So that was one where I felt like maybe there was a case to be made. I was very encouraged to see more studies that are trying to discern the relative contributions of dietary uptake versus water column uptake to the total lead burden in aquatic organisms. That was, I thought, really refreshing to read, and I'm glad it got in there. The ISA also highlights a number of interesting new findings from studies of zebrafish. And a lot of those studies are taking place at, you know, what are realistic near ambient lead concentrations, and finding some interesting effects. So this is important not just from a welfare point of view, but also the fact that the zebrafish are being studied in part because for certain biological functions, they're reasonable analogs for human or mammal processes. So that was really interesting and good to see. All that said, for the most part, significant negative effects in freshwater systems were found at lead concentrations that were well above typical ambient concentrations, and a lot of that appears to be the result of confounding effects of DOC, pH, and water hardness, which make it difficult to develop a workable model that would relate air lead to aqueous lead, which ultimately is going to help set a secondary standard if we were to if anyone were to go down that path. I will say, though, that in reading the section about revised CMC and CCC values, those values, when you look at the low hardness, low pH, and low DOC freshwater, and now you have to acknowledge that there are not that many of those waters in the United States, but you know, those values for low pH, low hardness, low DOC freshwaters are themselves quite low, and might possibly warrant consideration as we think about how freshwater might influence, ecosystems might influence the development of a possible secondary standard. Thank you.
All right, thank you. Any other further comments? Kathleen?
I just want to make one suggestion about, you know, the material that you say goes nowhere. You know, I think you mentioned earlier the Bradford Hill criteria, or the weight of evidence structure that you use to determine a causal effect. If you take that material that looks, and it was mentioned that maybe going into a table and saying, well, here's part of the weight of evidence that exists, here's the part that's missing. would be extremely helpful in determining what information might need further, research or further digging into the literature, or, whatever it takes to bring that to a full weight of evidence evaluation.
Thank you. And maybe we'll finish this section and we can circle back and unless EPA wants to chime in now, just to hear a little bit about your perspective about what you're including. And it sounds like it's relevant to this section, but it's probably relevant across the document. So if you want to reflect on that, you don't have to respond right now. I'll ask you when we get to the end of this. So I think, oh, thank you. Go ahead, Phil.
Just a quick comment, Chris. I just wanted to echo your observation. I did read that part in the freshwater criteria, and I thought, like you, it was well done in terms of bracketing the potential chronic criteria that you might come up with under extreme low conditions of pH, what is it, dissolved organic carbon and hardness, yeah, and then the opposite. And it was helpful perspective because it gave sort of the order of magnitude difference. And of course, some of the water quality criteria are contingent now on hardness, right? So they're a function of whatever the water conditions are. One thought, if one intent is to generalize, is to maybe just give some idea about what the range of typical conditions might be given monitoring data available from, the usual national monitoring programs. So how do we think about the low end versus the high end in terms of typical freshwaters?
Thank you. Go ahead, Bill.
So the Office of Water has a agreement now with several of the metals industries research organizations to work together to further exactly what you're talking about, the BLMs and the MLRs, and that process is ongoing now. And I know lead is included in a group that's going to be reviewed this summer. So that will come in as well. But the bottom line is, as you said, I mean, you're absolutely right that, if you take a worst case scenario and you pick the worst of situations and you you have to then have an effects concentration that you know what you're looking at. It's not the probable, well, it doesn't, it would more likely be like the 5th percentile of situations, and you'd pick a number that way. But the new review process, I know, has all of they've done an excellent review of water quality parameters throughout the U.S. And so we know what the hardness and the pH and everything is, and we can do exactly what you just said. And then the hard part is, how do you back that into an air quality number?
Well, I think it's back to you anyway, Bill. We have one more section, saltwater?
That's it. So, saltwater, you guys did a bang-up job again. It's really useful given the fact that even back in '85, when the saltwater criteria was prepared, there wasn't a lot of information. There hasn't been a lot of information that has been developed until the European REACH requirements went into place. Data was generated then. You caught all of that. You pulled it all in, and I can't compliment you more for pulling all of that information together. The one thing that I will say, because I actually ran some of the marine lead studies back many moons ago, and when my technician came in and said, "Why is there a bunch of white stuff at the bottom of the diluter?" Well, it's because go back and you grab your inorganic case, text, and it's like, insoluble lead chloride. Where do I know there's a lot of chloride? Seawater. So that kind of text is really, really important if you're evaluating potential effects on saltwater species. And it's not contained in the document. And I would just love to have some sort of expansion to cover that particular aspect, because it is so unique. Otherwise, great job.
So, yeah, I don't have a whole lot to add other than to say that I think we've gone from knowing next to nothing about lead in saltwater systems to knowing a little bit about lead in saltwater ecosystems. So, you know, and you've summarized it wonderfully, and to the point where you feel comfortable making a few causality determinations, which certainly makes sense to me. I think the generally high pH and salinity of these systems, and in some cases relatively high DOCs as well, create conditions where the percentage of lead that's in a free, like lead 2+ form, is virtually nil. And, you know, that's not to say that other forms of lead might not have toxicological effects, but it just seems very likely that the most, we need to keep looking. We need to keep looking at the literature. We need to keep encouraging scientists to look more closely at these systems. But it does seem like terrestrial and freshwater systems are much more likely to be the places where you would see welfare effects eventually that might possibly lead to some sort of action.
All right, thank you. We've reached the end of the assigned discussants and charge questions for the welfare effects. Any panel questions or comments? How about EPA, requests for clarification or other comments?
We have a few clarifying comments to pass on, and then a few questions as well. I did want to point out that since there were several questions about the concentration cutoffs, that table 12-4 in the process appendix provides a lot of detail on the justification for those concentration cutoffs, as well as the exceptions to those cutoffs. Like, for example, if it was a organism that was under a protected status, we included that information even if it was above the concentration cutoff, or if it was a toxicity data on a previously untested organism, we included those studies as well. So, you know, we had concentration cutoffs, but then again, there were lots of exceptions where we brought in those studies. So I think that I think we pulled in a lot of the relevant literature and just use that as a guideline for screening. But there's a lot more detail on that in table 12-4. Oh, and then for the study quality guidelines, we followed the study quality guidelines in the preamble to the ISAs. There's a series of questions that are there about study quality, and then also in Appendix 12, there's more information on the study quality that we used for the ecological sections. And then I did also want to point out that there's some fate and transport information in Appendix 1 that cross-talks with what we talk about in Appendix 11, so maybe we need to add more call-outs to those sections. But some of the questions that have come up about fate and transport of lead in marine environments and freshwater environments is in that appendix, and if not, we can enhance that information.
The only thing I would just add to that nice summary of how we reached inclusion of the studies that are in the ISA is, you know, part of the charge to the CASAC is to help us identify areas for addition or expansion, but also for reduction or removal if there is information here that you're finding is not kind of helpful for our end goal. And some of that might become a little bit more clear tomorrow as we discuss the integrated synthesis, and then we'll also hear a discussion with our partner office, Office of Air, who will be describing how they're going to use the information in their plans for the quantitative analyses.
I think, well, as I indicated, I didn't get to read into all of Appendix 12. I think what you suggested is an excellent idea for how to do that, and to tie it, if you can, to the BLM, MLR kinds of parameters, or in the case of soils, the BLM kind of parameters that are included there as well would be very helpful.
And I would just say that, you know, the crosswalk with Appendix 1, I agree entirely. I did get a chance to read those sections, which were very well done, and you know, I thought between the two they worked really quite well together. So.
And I did want to speak really briefly about your question about the neurobehavior in freshwater invertebrates. In this most recent ISA, there were really two studies out of one lab on amphipods, and then low lead concentration, and they quantified the lead in the environment, in the water. And then there was a different study on bivalve. But then if you go back to 2013, I say there weren't a lot of studies supporting that endpoint. And then going back further into the AQCDs, a lot of those studies where they were looking at neurobehavioral effects were at really high lead concentrations, or where there were multiple metals, so it wasn't as clearly attributable to lead. So because there were just a few studies, and because of going back to what happened in the previous AQCDs, we went with the likely to be causal relationship for that endpoint.
So I wonder if there's any wordsmithing that can be done just to kind of get a little bit of that lack of certainty into that text. So.
Yes.
Okay. Anything else on this section? Steve, you commented a little bit on inclusion and exclusion and our advice. Is there anything more that we should weigh in on about, you know, like including more, you know, topics that don't seem to enter into the causality conclusions? Or I think that was a lot of what Bill was talking about. Is there anything more that you all want to share that, or with respect to that?
I don't think so. It may come up actually as we discuss Appendix 12 on our process for inclusion, so it might be an opportunity to circle back there, but I'm not sure there's anything else at this point.
All right, well, it's 4:40. I don't think we want to start another topic today. I don't think anybody has stomach for that, particularly the people who are lead on that section. Oh, wait, Bruce has got his hand up. Thank you. Go ahead, Bruce.
Yeah, thank you, Leanne. Yes, I won't be able to join you tomorrow. I'll be traveling. But I did want to just comment on what I thought was some consistency across the different appendices. And we said it different ways, but I struggled too with just feeling like, you know, you're trying to drink from a fire hose. There's just so much, and trying to identify what the key articles are. And then in some cases, there was all this new stuff, which has some value, but to the extent that you're trying to include all the new stuff and you can't include some of the key studies that were used to determine causality in the past, then there's a trade-off. You're losing something. And it's, to me, it's like writing a book. You have to know what to include, but you also have to know what to leave out. And that doesn't mean you don't write twice as much as ultimately is in the book, but you don't necessarily want to include everything you put down on your first or second or 10th draft. So I think there's something that we could say to try to help give some direction about what would be the key things to include in future ISAs. I don't know that we want to say this one, but that would make it more useful, allow us to be more critical. To say that previously there was an RCT on lead that didn't include blinding but it wasn't included, and now we're trying to make a causality determination. It wasn't that useful to have that sentence in there. Anyway, so I think there was a lot of consistency, and I think we should try to give some recommendations about how to improve that part of it.
Thank you. I think that's a very helpful comment, and I would encourage you and others to maybe write something down so that we can try to distill that and figure out how it goes, where it goes, and maybe it goes in a couple of sections so we don't have a specific charge question on it, but we should address that point. Thank you. Any other further comments today? So I guess we don't adjourn because we just recess. Yeah. So, and I get to do that? I'm going to turn it over to Aaron because I don't want to miss anything official.
Yeah, it doesn't matter. We can be recessed till tomorrow, 8:30 a.m. And again, tomorrow at 8:30, we'll start with the additional clarifying comments from the public. All right, we'll see you all tomorrow.
Thank you, everybody.
Yeah, and don't leave your laptops in the room, please. Yeah.
Thank you.
Thanks, bye.
Bye.